All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to Unacademy NEET English. If you have not subscribed to the channel yet, hit the subscribe button as soon as possible. So, in the today's session, we're gonna be talking about that is ray optics, okay? And this is going to be ray optics like never before. Every single detail we will be discussing over here. This is a big chapter, okay? From the scratch, I'll be taking it and I'll give you the level which you actually need in order to solve all the problems of your NEET, okay? So guys, before that, let me know in the chats if I'm perfectly audible, visible to each and every single student. And if you have not basically smashed the like button as of now, I would want you guys to smash it as soon as possible, because liking this session is extremely mandatory. Smash the like button as soon as possible, okay? And then we will start and let everybody join, and we are starting this particular session over here. We are starting this particular session. So guys, ray optics from the scratch. And when it comes to the ray optics, it is one of the important chapters when it comes to the NEET and when it comes to the JEE. Yes, we will be doing the optical instruments also, okay? The complete ray optics, okay? So when it comes to the ray optics, guys, see. This ray optics is basically divided in 4 parts, okay? I would say first is reflection. We will have to study over here reflection in detail. Then we will be studying over here, that is refraction. Okay. And then we will be talking about the dispersion and all. Okay. Okay. And then we will be talking about the optical instruments. Optical instruments, like we say telescope or we say microscope over here. So these are the 4 parts of the ray optics, and it's a very big chapter. I would say very big chapter. Okay. So guys, I think we should start this particular session with a reflection. Okay. Reflection of light. When it comes to the optics, in this optics, we basically talk about light. We deal with the light. Okay. And my dear friends, I would want you guys to smash the like button and watch this session till the end. It will take us time. We will have to finish the entire chapter. Now. First and the foremost thing over here is that I want to tell you in this particular case, guys, see. When it comes to the modern physics, I have told you in modern physics previously, we consider this light. If you say, sir, this is a light source over here. Light source means bulb. Bulb gives the light. Okay. So we say in modern physics, sir, these are the photons coming out of the light source. These are the photons coming out of the light source. If you remember, this light over there, we called these light as photons. But when it comes to ray optics, I would want you guys to listen, guys, see. And I have discussed this previously. Light has dual nature. It behaves like a ray, it behaves like a particle, as well as it behaves like a wave. Okay. So we say here, we consider light as a ray, or we say straight line. Guys, I have not started the chapter yet. As of now, I am saying when it comes to the modern physics or dual nature of matter and radiations over there, we used to say if this light is falling on my hand, these are the photons falling. But right now in this chapter, if I say light is falling on my hand, I would say this is the ray of light, straight line falling. As simple as that. So basically, in nutshell, in this particular chapter, we will have to discuss about the light. We'll have to study light over here. That's why optics is the name of this branch. Optics is the branch of physics in which we deal with the light. Okay. So we are starting the first topic of the today's session, and I would want you guys to smash the like button if you have not smashed it yet. Guys, see, the very first thing over here is reflection of light. Reflection of light. Okay, guys, I would want you to understand. I would want you to understand one thing. This is a very big chapter. So there are a lot of diagrams over here. That's why we call it the geometrical optics. Okay, there are a lot of diagrams that you will be seeing, and there are a lot of formulas that you will be seeing. I would recommend once we are done with this chapter, afterwards, you guys should make a separate formula sheet for this particular chapter. Okay. Now, guys, see, first and the foremost thing over here is we have to discuss the reflection of light. What the reflection of light is all about. See, guys. Let's suppose I have got a surface over here. Sir, what kind of surface? Like I have a surface sheet over here. Okay. And this surface, I call this surface as a reflecting surface. Reflecting surface. I call this surface as a reflecting surface. Okay. Guys, focus completely over here. I'll be starting from the scratch so that you understand each and every single thing. Now, my dear friends, let's suppose there is a light source placed over here. If there is a light source, we know light source will give light. Light will come out of this particular light source. And I am representing that light with the help of this straight line, not with the photons. I won't say these are the photons falling over here. I say this is a straight line or a ray. This is the ray of light. Where is it coming from? There is a light source over here. From that light source, this is the light falling on the surface. Okay. And this ray is what we call the incident ray. This ray, first topic is reflection of light. What does reflection mean? You throw something, it will be reflected. So this ray is what we call the incident ray, which falls onto the reflecting surface. Okay. My dear friends, what is going to happen? We know, sir, it will be reflected something like this. Like you have a ball, you throw it on the surface, it will be reflected. Similarly, when you throw the light on the reflecting surface, it can be mirror also. So we say it will be reflected something like this. This is what we call the reflected ray. This is what we call the reflected ray. And I would want you guys to draw a line on this reflecting surface such that this line is perpendicular to the reflecting surface. And we call this line as normal. Okay. This normal is perpendicular to the reflecting surface over here. Now, guys, in this particular case, I would want you to focus, sir, angle between this normal and this incident ray. This is what we call the angle of incidence. Angle between this reflected ray and this normal is what we call the angle of reflection. This is angle I, this is angle R. Okay. And this is the angle which is between the incident ray and reflecting surface. Let's call it alpha. And this is the angle between reflected ray and the reflecting surface. Let's call it either alpha or beta. Both of these angles will be same. This is called the reflection of light. We say when light falls, guys, understand. When light falls on a reflecting surface, it gets reflected. The process is called, the phenomena is called a reflection of light. And my dear friends, see. We say this is medium 1. What does medium 1 mean? Like this is a surface. We say below this surface, it can be water, something else. Above this surface, it can be air. So this is air medium, this is water medium. So I say this is over here medium 1 and this is over here medium 2. Now, guys, we say in this particular case, if the incident ray, if a light is reflected in the same medium, you are throwing the light and it is reflected in the same medium, then we call it the reflection of light. Sir, what if enters the another medium? In that case, we call it the refraction of light. That we'll study later on. Okay. Now, the first law, that is the law of reflection. What is that? We say, guys, the incident ray, reflected ray, this incident ray, this reflected ray, and this normal and the normal at the point of incidence, lie in the same plane, means, guys, this is a plane of the board over here. We said this incident ray, this reflected ray, and this normal, all are in the same plane. This is the first law. This is the first law of reflection. I would say over here, this is the first law. Okay, law 1, first law of reflection. Next, what is the next law? And when it comes to the second law of reflection, guys, second law of reflection says, if reflection takes place somewhere, we say angle of incidence, that is this angle, is equal to the angle of reflection. This angle of incidence is equal to the angle of reflection. This is also the, we say, law of reflection. This is the second law of reflection. And my dear friends, one thing I just want to tell you over here. Could you please tell me how much is this angle total? This is 90 degrees. And how much is this? This is I. How much will be this alpha? Clearly you can see over here, sir. Also, I can say this alpha is equal to 90 minus I. Okay. Now guys, let's suppose this is not alpha over here. This is beta over here. Now in this particular case, I would want you guys to focus. Sir, how much is this angle total? This is 90 degrees. And how much is this? This is R. So can I say in this particular case, sir, this beta will be simply, that is 90 minus R. This beta will be 90 minus R. Absolutely. Now guys, we have recently studied angle I is equal to angle R. So I can also say, or we can say this beta will be equals to 90 minus, instead of R, I can write over here I. Now take a look at this alpha. It is 90 minus I. Take a look at this beta. It is 90 minus I. So can I not say this alpha is also equals to beta? So this alpha is also equals to beta. Okay. So we say this alpha is also equals to beta. So what did you study from the law of reflection? Law of reflection says if the light ray is incident on some reflecting surface, it gets reflected in the same medium. The phenomena is called law of reflection. The phenomena is called reflection of light. There are two laws of reflection. First one is angle of incidence, that is angle between normal and incident ray, is equal to the angle of reflection, that is angle between the reflected ray and the normal. Then we discussed the incident ray, the reflected ray and the normal all lie in the same plane. Then we also discussed this angle alpha is also equal to the angle beta. These are the three things which you guys are supposed to remember in law of reflection. Please give me the signal in the chats if this is crystal and clear to each and every single student. I would want you guys to tell me. Everyone means everyone. Tell me guys, if this is crystal and clear, if this is crystal and clear, everyone. Tell me. Now guys, see, we have got a question over here. If the angle made by the incident ray, from the mirror is 30 degrees, then angle of reflection will be. Now guys, see. What does the question actually say over here? Let's suppose this is the reflecting surface. Okay. And this is the incident ray. Okay. And this is the reflected ray in this particular case. And I'm saying, let's suppose this is the normal. This is normal over here. This is normal. Okay. And we know guys, this is angle of incidence. This is angle of reflection. And angle of incidence, we know it is equal to the angle of reflection. Angle of incidence, we know it is equal to the angle of reflection. Now guys, in this particular case, the question says, if the angle made by the incident ray with the mirror, you can call this as a mirror also or the reflecting surface. If this angle is given over here as 30 degrees, then it says what will be the value of angle R? Guys, tell me one thing. How much is the total angle? That is 90. And how much is, guys, total is 90. This is 30. How much will be I? So here, can I not say I will be, that is 90 minus this 30, 90 minus this 30. So I will come out to be 60. If angle of incidence is 60, Don't you think that angle of reflection will be also 60? So angle I is equal to angle R. So I can say angle R in this particular case is also 60 degrees. Don't say it is 30, it is 60 degrees. Okay, simple, basic question. Next. Guys, listen to me very carefully. Listen to me very carefully. We say when it comes to this reflection, this is what we call the convex mirror. There are different, see, the mirror that you have in your home is a straight, okay, that is what we call the plane mirror. There is one more type of mirror, spherical mirror, that is convex mirror. Sir, do we have to study this in detail? Yes. There is one more type of mirror, okay, this is concave and this is convex. Sir, do we have to study this in detail? Yes. And there is the plane mirror. Plane mirror means which you have in your room, okay, while basically you wake up in the morning and you see yourself in that mirror. That's a plane mirror. Okay. Now, guys, this is the plane mirror. This is the concave mirror. Sir, later on we'll discuss these. Okay. As of now, remember. And this is a convex mirror. Now, guys, if the light is incident on concave mirror, we say here also, guys, this is the concave mirror. Draw a normal. This is normal in this particular case. This is normal. Okay. And this will be incident ray and this will be reflected ray. Sir, is this law of reflection valid here also? Yes. Here in this particular case also we say angle of incidence is equal to angle of reflection. Sir, when it comes to the convex mirror, this is the incident ray, this is the reflected ray, and this is normal. Sir, in this case also, guys, in this case also, is this valid? Yes, here also it is valid. Angle of incidence is equal to angle of reflection. Sir, when it comes to the plane mirror over here, we say in case of the plane mirror, we say this is the incident ray which falls onto the plane mirror. This is the incident ray. This is the reflected ray. And this is, we say, sir, normal. In this case also angle of incidence is equal to angle of reflection. We say in all the three mirrors, we say law of reflection is valid. Law of reflection is valid. As simple as that. Next. Is this clear to each and every single student? Guys, tell me in the chats. I would want you guys to tell me in the chats if this is crystalline clear to each and every single student. Okay, great. Now, guys, see, first and the foremost thing is deviation by the plane mirror. Let's discuss this topic a bit. Deviation by plane mirror. Guys, see, when it comes to the plane mirror, let me just tell you a bit detail about this plane mirror. If you check the plane mirror inside your room, you see that it is something like this. It's something like this straight. It is something like this. This is a plane mirror. It would be something like this. And we say from the back side of the plane mirror, it would be polished with some paint. You check it. So this is the polished side. Okay. And this is what we call the reflecting side. Reflecting side means from this side reflection takes place. From back side, it would be basically polished with some paint or something like that. So from the front side, we say reflection takes place. Let's suppose if I am taking over here plane mirror. Okay. This is the plane mirror in this particular case. Okay. So it is polished from the back side. That's why reflection is taking place from the upper side. Now, guys, in this particular case, let's suppose I'm saying this is the incident ray which falls onto the mirror and it gets reflected something like this. This is the reflected ray. And this is the normal over here. This is angle of incidence. This is angle of reflection. We know both of these angles will be same. Angle of incidence is equal to angle of reflection. Now, guys, let's suppose if there was no mirror present over here, can I not say, sir, then the path of this reflected ray, incident ray it would have gone straight something like this. It was reflected because of this mirror. If I say no mirror is present over here, it will go straight something like this. Okay. Now guys, this is what we call the deviation. How much it deviated. This is the original path and this is the reflected path. How much it is deviated from the original path. That's what we call the deviation over here. Okay. This is what we call the deviation. How much it is deviated from the original path. And this deviation, we say it will be equal to 180 minus 2 theta. 180 minus 2 theta. Okay. Guys, see. How much is this total angle? Sir, this is 180. Okay. We are supposed to find this angle, deviation. Total angle in this case is 180. How much is this? Theta plus theta is 2 theta. So 180 whole angle minus 2 theta. That will be this deviation. So that's why we call it the deviation 180 minus 2 theta. Okay. Okay. So basically, how much it got deviated from its original path, that's what we call the deviation. Okay. I'll write over here. Deviation is, I'll write over here. Deviation is how much the light ray, how much the light ray gets deviated from its original path. Is this crystalline clear? Is this crystalline clear? Next, my dear friends, we have to talk about that is what we call the deviation by two plane mirrors. Tell me guys one thing, how many plane mirrors were over here? Sir, just one plane mirror. And how much is the deviation? Deviation came out to be 180 minus 2 theta. Okay. Next, my dear friends, guys, if I say at some particular point, you have to remember this point, just remember it directly. Because I will be skipping the derivation part. Okay. Because this is a very big chapter and you don't have to remember the derivation part at all when it comes to your NEET examination. Now, guys, see, when it comes to the deviation because of the two plane mirrors, let's suppose this is a first plane mirror, it's M1, and another plane mirror is over here, this is M2. This is polished side, okay, this is the polished side, and this is polished from this side. Angle between these two mirrors is, let's suppose, theta over here, okay. Angle between these two is, let's suppose, theta over here. Now, guys, say, let's suppose this is the incident ray which falls onto the mirror 1. This is the original ray which falls onto the mirror 1. What will happen when light ray falls onto the mirror? We say it gets reflected. It will be reflected something like this. So when it is reflected, it falls onto the mirror 2. When it is reflected, it falls onto the mirror 2. Over here, it falls onto the mirror 2. Guys, this is the first reflection that takes place on mirror M1. And then, guys, when this light ray falls over here, again it gets reflected something like this. So when it is reflected something like this, this is the second reflection. I would say this is the first reflection over here. This is the first reflection. Okay. And on the mirror M2, this is the second reflection. This is the second reflection. And finally, my dear friends, we call this will be the final ray. This will be the final ray. This was the original ray. Then it is reflected, then again reflected. This is the final ray. This is the original ray. Now, guys, here also we discussed angle between the original ray and the final ray. This was the path of original ray. This is the final ray. Okay. Angle between these two is what we call the deviation. Here also, angle between this final ray and incident ray, this is the deviation that we define over here. Okay, this is the deviation that we define over here. And my dear friends, we say this deviation is equal to, that is 360 minus 2 theta. Whenever you have two mirrors which are inclined at some angle, In that case, if they ask you to find the deviation, means the deviation between the incident ray, original ray, and the final ray, final path. So it is 360 minus 2 theta. Directly, I would want you guys to remember this over here. Next. See guys. Next we have this over here. Okay, before this, I would want you guys to solve this question. Okay. This was the question which was asked in JEE mains. JEE mains. Okay. Now, look at the question. Two plane mirrors are inclined to each other such that a ray of light is incident on the first mirror. Guys, see. I'll make the figure. It says that you have got, let's suppose this is the first mirror that we have exactly over here. Okay. Let's call this as yes. This is the first mirror that we have exactly over here. And my dear friends, in this particular case, this is the second mirror that we have exactly over here. Okay. Let's call this mirror as M1. Let's call this mirror as M2. And this mirror is polished from this side, something like this. Okay. And this mirror is polished from this side, something like this. This is polished from this side, something like this. Yes. An angle between these two mirrors is, let's suppose, we are supposed to find the angle between the two mirrors. Now see, what does the question say? See, two plane mirrors are inclined to each other such that a ray of light is incident on the first mirror. It says where I have written I and I, because I have mentioned I and I over here. This is the angle of incidence. This is the angle of incidence. This is angle of reflection, because we know I is equal to R. Either you say R and R, I and I, X and X, whatever you say, it is same. Because in case of reflection, angle is same. Now take a look over here. We say light ray is falling on the first mirror, something like this. Two plane mirrors are inclined to each other such that the ray of light is incident on the first mirror M1, parallel to the second mirror. This ray of light falls in such a way so that it falls on the mirror M1, but is parallel to the second mirror. It is parallel to the second mirror. Okay. And then it says, and is parallel to the second mirror M2, and is finally reflected from the mirror M2. Guys, what happens? Here reflection takes place. It falls onto the mirror M2. Okay. Then it says that when it is reflected from the second mirror, it becomes parallel to the first mirror. This is the complete detail of the question. Guys, this is the incident ray. This is the incident ray initially. This is the first reflection taking place over here. Then it falls onto this mirror. Then again, this is the second reflection. This is the final ray. This is the final ray. Final ray. Incident ray. This is the final ray. Original ray and final ray. Guys, see. Can I not say in this particular case, I would want you guys to focus. If this is the first reflection taking place over here, this is the incident ray, this is the normal. Normal is always perpendicular to the mirror. If this is angle I over here, this is angle of incidence, can I not say this will be angle of reflection? Yes, sir. And my dear friends, I would want you to focus exactly over here. Let's suppose this is I, this is R. Okay, angle of incidence, angle of reflection, angle between reflected ray and normal. And how much was this angle? This angle we discussed over there. This is alpha, beta, gamma, theta, whatever you say. This angle is alpha. Okay, don't you think that, sir, this angle and this angle is also equal? This will be also alpha. Because in case of reflection, if you remember, I have told you this angle and this angle is equal. This angle and this angle is also equal. So I'm using the same logic in this particular case over here. I'm using the same logic over here. Okay. Now guys, tell me one thing. If this angle is alpha, this line is parallel to this line. Now, this line is making with the horizontal alpha. Don't you think that this angle will be also alpha? Because you might have seen this many times, sir. This angle alpha, this angle will be also alpha, this angle will be, all of these angles are equal. Okay. Now guys, if this angle is alpha, tell me one thing. What about this angle? This angle will be also alpha. This is the second reflection over here. This is the second reflection over here. So we say when it comes to this second reflection, just take a look over here. Just take a look over here. In case of this second reflection, I would want you guys to focus exactly. I would want you guys to focus. Guys, see, if this is alpha, okay, this is the incident ray for this mirror. This is the reflected ray for this mirror. Angle between reflected ray and reflecting surface is alpha. Don't you think that this angle will be also alpha? Because if you are saying here alpha and alpha are equal, here also, this is the incident ray, this is the reflected ray. This alpha, if this is alpha, why, sir? Because you might have seen in case of the straight line, this is alpha, this is alpha, this is alpha. All the angles are equal. So we say, if this is alpha, if this is alpha, this is alpha. Now look at this triangle. Guys, look at this triangle. We say from the triangle, this alpha, this alpha, this alpha. Don't you think that, sir, 3 alpha will be equal to 180? Because sum of all the angles of a triangle are equal to 180. So alpha plus alpha plus alpha is 180. Okay. So I can say 3 ones are 3, 6, 3 into 0. So alpha will come out to be 60 degrees. So angle between the two mirrors is 60 degrees. Angle between the two mirrors is 60 degrees. Guys, tell me in the chats if this is crystal and clear to each and every single student. Everyone means everyone. Tell me in the chats if this is crystal and clear to each and every single student. This is the previous year question of JEE Mains. Great. Okay. Next, my dear friends. Next, my dear friends. If you are getting confusion at any point, so don't be confused, okay? We'll sort it out every single thing, so have patience, okay? Next, my dear friends, let's talk about object and let's talk about the image. Before this object, I would want you to understand this. I would want you guys to understand this thing. What is that? See guys. Everyone means everyone. Look at this. Let's suppose we have a mirror over here. Let's suppose we have a mirror over here. This is a plane mirror. Okay. And this plane mirror is polished from the back side, from this side. Okay. And I am placing a box in front of this plane mirror. I am placing a box in front of this plane mirror. Tell me one thing, what is going to happen if you place a box in front of the plane mirror? Sir, clearly I can say inside the plane mirror, we can see its image. We can see the exact same box inside the mirror, and I'll make that over here. I'll make that over here. Okay. This is what we call the object. Okay. Which is placed in front of the mirror. This is mirror. And this is what we call the image. Basic, simple definition. If you have got over here mirror, sir, if I am standing in front of the mirror, then I'll be the object. Inside the mirror, my image will be produced. Okay. And if I say this is at certain distance, let's suppose this is D. Sir, this image will be also at the same distance, that is D, from the mirror. This is the object, this is the image. Basic definition. Now guys, always remember how this image and object is created, that we need to discuss. How this, I'll be telling you of virtual, real image, everything. Please wait. Now guys, when it comes to the ray optics, there is a proper sequence. Okay. If you follow that sequence, if the teacher goes with that sequence, step by step, the chapter becomes extremely easy. If you do not follow the proper sequence, it becomes very difficult. Now see, we say when it comes to the object, It is defined as the point of intersection of incident rays. This is the technical definition. Sir, how am I supposed to understand this? See guys, let's suppose this is a plane mirror over here. In front of the plane mirror, you place something. That's what we call the object, sir. Okay. Always remember, if this is a mirror, in front of the mirror, this is the object. We say, incident rays, light rays will leave from this object. We say, sir, light rays will leave from this object, and these are called the incident rays. Because if the light ray falls on the mirror, those light rays are the incident light rays. And always directly remember, if this is a mirror, you are the object, light rays will leave from you. Technically, light rays, we say, light rays will leave from the object, it falls onto the mirror. Okay, it falls onto the mirror. Now, my dear friends, I would want you to understand one thing. We say, then it will be reflected, these light rays will be reflected, and image will be formed. As of now, when it comes to the object, we say incident rays leave from the object, or we say incident rays meet over here or leave from the object. You say it like that. Okay. Now guys, listen to me very carefully. Let me come over here. If I'm saying in this particular case, see, look at this example. Sir, this is the incident ray which is falling on this mirror. This is the incident ray which is falling on this mirror. Okay. And we say, sir, these incident rays will be reflected. Yes, sir, these will be reflected. Sir, where are these incident rays coming from? There is some object. Because of that object, incident rays are falling on this one. Now, after reflection, we say it will leave like this. After reflection, it will leave like this. So, my dear friends, the point where these incident rays meet, that is what we call the image. The point, sorry, not incident rays. The point where these reflected rays meet, that is called the image. So we say it is the point of intersection of reflected rays. And what is object? Object is basically the point of intersection of incident rays. And what is image? Image is the point of intersection of the reflected rays. Now guys, I'll make you understand. I know you are confused. Wait. If I say this is the mirror over here, from the mirror incident rays are leaving. So we call this as object. Okay. Now, if I'm taking the mirror over here, and I'm saying, sir, this is the incident ray falling something like this. In this particular case, it will be reflected like this. Here, it will be reflected like this. Here, it will be reflected like this. Cool. Now, if you extend these, guys, sir, in this particular example, I don't feel like these incident rays are meeting at some point because they will be reflected something like this. These are the reflected rays meeting over here. Now, if you extend this incident ray, the point where these are meeting, this is the incident ray. I'll mention over here. This is the incident ray. This is also incident ray. Guys, if you extend this, the point where they meet, this is called the virtual object. Sir, what is the difference between real object and virtual object? Real object means that point where incident rays are actually meeting. In reality, they are meeting. Yes, sir, from here, these are leaving. But when it comes to the virtual object, we say here, we are assuming that this reflected ray, if we extend, it will meet over here. We say in case of virtual object, incident rays appear to meet at a point. They are not actually meeting. They appear to meet at a point. So I say in virtual object, incident rays meet, incident rays appear to meet at a point. So the point where these incident rays appear to meet is called the virtual object. This is not real. Real object is that where incident rays are actually meeting. Now let's move on to this one. Image. Now what is image? Sir, the point where reflected rays are meeting, that is called the image. Now can I say in this particular case, guys, if this is the object, we say incident rays will leave from the object, and after reflection they meet over here. That's why image is formed over here, object is over here. Simple logic. See, if I'm saying in this particular case, this is the mirror, this is the object, incident rays will leave from the object something like this. After reflection they go something like this. Now guys, if you extend this, we say in this particular case reflected rays are not meeting. Now if you extend this, they appear to meet at this point. In reality they are not meeting, they appear to meet at this point. So this is called virtual image. When reflected rays are not actually meeting, they appear to meet, then we say it is virtual. Okay, when incident rays appear to meet, then we say it is virtual object. Now guys, take a look over here. If I say incident rays are something like this, after reflection they go something like this. Here reflected rays are actually meeting. Reflected rays are actually meeting. In reality they are meeting. That's why we call this as a real image. Please give me the signal in the chats if this real and virtual is clear. Everyone means everyone. So here virtual image is also formed, real image is also formed. Whosoever is watching this lecture, I would want you guys to give me the signal. Everyone means everyone. So I'll just write, in case of real image, reflected rays are actually meeting. Okay, so once again, because this is confusing, that's why I'm giving it a time. So once again, if I say in this particular case, if this is a mirror, we say this is an object. So we say incident rays leave from this object. They are actually leaving from this point. In reality, they are meeting or leaving from this point. This is the real object. Now, if the incident rays are something like this, okay, we say if we extend these, they appear to meet at this point. So this is called virtual object. Next. Sir, if the incident rays are something like this and they are reflected, I know after reflection they'll go something like this. And if you extend this, if you extend these reflected rays, they appear to meet at this point. So this is virtual image and this is real image. Okay. Next. Now guys, understand this thing. If the incident ray is rotated by theta, keeping the mirror fixed. See guys. Here, you need to keep your mind completely over here. I want your 100% attention. See guys. Otherwise, you'll be confused because I told you there are a lot of diagrams in this chapter. You have to keep your mind over here. See guys. I say in this particular case, this is the mirror that we have over here. This is the mirror. Okay, this is the mirror. And this is the incident ray. Guys, this is the incident ray. Incident ray is falling. And incident ray, when falls on the mirror, it is reflected something like this. So this is the reflected ray. This is the reflected ray. Now guys, the question says, if the incident ray is rotated by theta, if you rotate this incident ray by how much by theta? Sir, how can we rotate the incident ray? Initially, the light source was over here. Finally, you take the light source exactly over here. Okay, so initially the light source was over here. So you take the light source from here to here. Okay, you have rotated it by theta. Now guys, understand one thing very carefully. If, can I say now, this is the new incident ray. This is the new incident ray. Okay. And my dear friends, don't you think that if you shift this incident ray, this reflected ray will also shift? Why? Because angle I has to be equal to angle R. Guys, in this particular case, I would want you to focus. If this is angle I, if you are rotating this by theta, if you're rotating this by theta, my dear friends, how much will be this angle? This was the angle of incidence. Now this is I plus theta. Okay. This is the angle between new reflected ray and normal. Now, sorry. This is the angle between new incident ray and normal. Sir, don't you think that in this particular case, this is the angle of new reflection? This is the angle of old incidence, angle of old reflection. New angle of incidence, new angle of reflection. This also has to be I plus theta. This also has to be I plus theta. Okay. Now guys, if I say this also has to be I plus theta, in this particular case, how much is this angle? Theta, sorry, I. How much is this angle? I plus theta. Could you please tell me how much will be this angle? Guys, total angle minus this angle. So that is I plus theta minus I. This and this will cancel, so it will be theta. So this angle is theta. So can I say, if the incident ray is rotated by theta, if you rotate the incident ray by theta, see, keeping the mirror fixed, if the incident ray is rotated by theta, keeping the mirror fixed, reflected ray will be rotated by theta, but in opposite sense. What does opposite sense mean? If you rotate this in anti-clockwise, this is anti-clockwise, this will be rotated in clockwise direction. This is anti-clockwise, this is clockwise. That's why I told you magnitude-wise it will be same, but direction will be opposite. Give me the signal in the chats if this is crystalline clear. So from now onwards, if incident ray is rotated by theta, keeping the mirror fixed, okay? Fixed means you do not rotate the mirror in this particular case. Then reflected ray will be rotated by theta over here. Okay. Next, this one is more complicated. I would want you guys to give me the 100% attention once again. See guys, if the mirror is rotated by an angle theta, keeping the incident ray fixed, in this particular case, guys, you have to keep the incident ray fixed, but you have to rotate the mirror. Now guys, understand one thing. This is mirror. This is the mirror that we have exactly over here. This white color is the mirror. Guys, give me the 100% attention. This will be crystalline clear. This is the mirror that we have exactly over here. Okay. This is the incident ray. I am saying this incident ray is falling on the mirror and this will be its reflected ray. Green color. Incident ray, reflected ray. Cool? Yes, sir. Now rotate this mirror I am rotating this mirror here. We say how much angle by how much angle, sir? Theta angle by theta angle. You are rotating this mirror by theta angle. Guys, this is the normal, old normal. If you are rotating this mirror by theta angle, so here also this will be theta. Don't you think that this normal will also shift? Why, sir? Because normal always makes 90 degree with the mirror. So this normal has to make the 90 degree. That's why normal will also shift. So if you are rotating this mirror by theta, we say normal will also shift by how much? That is theta. This is what we call the new normal. This is what we call the new normal. Cool? Yes, sir. Now guys, listen to me very carefully. Listen to me very carefully. Can I say this is the old normal? Angle between the old normal and incident ray is angle of incidence. We have studied this. Now, angle between the old normal and old reflected ray is what we call the angle of reflection. And this is I and I. I am mentioning I over here because both are same. Both are equal. That's why either mention R and R, I and I, or I is equal to R. One and the same thing. Okay. Now, since you guys are, guys, understand. Since you guys are rotating this mirror by theta, in that particular, and you are keeping the incident ray fixed. This is not rotating. But when it comes to the reflected ray will also rotate. Reflected ray will also rotate. Okay, so this is the new reflected ray. This is the new reflected ray. This is the mirror. You are rotating this. This is the old incident ray, old reflected ray, new reflected ray, old normal, new normal. If you are rotating this by theta, we say normal will also rotate by theta. This angle is angle of incidence, angle between old normal and angle of incident ray. This angle is also, we say, sir, I, angle of incidence. Now, guys, if this angle is theta, this is I. How much is total angle? That is I plus theta. Done and dusted. Now, guys, see. Angle between new normal and incident ray is I plus theta. Don't you think that angle between new normal and new reflected ray should be also same? Why? Because law of reflection. This is I plus theta. This should be also I plus theta. This should be also I plus theta. I know this is confusing, but you have to keep your mind over here. It will be crystal and clear. So if this is I plus theta, this angle is also I plus theta. Now guys, if this is I plus theta, this is theta, how much is total angle? I plus theta, that will be I plus 2 theta. Crystal clear, sir. Now, this is the angle between old normal and new reflected ray, means this is I plus 2 theta. Now guys, tell me one thing. If this is I plus 2 theta whole, okay, and this is I, angle between this ray and this normal and this ray, old reflected ray. This angle is I, this angle is I plus 2 theta. So I plus 2 theta minus I, that will be 2 theta. So this angle will be 2 theta. Because whole angle is I plus 2 theta, this angle is I, so this will be 2 theta. Now guys, this 2 theta is the angle between reflected ray and new reflected ray. Means we can say, in this particular case, reflected ray has rotated. Reflected ray has rotated by an angle of 2 theta in this particular case. Sir, can I ignore all of this detail that you have said? You can. What you are supposed to remember in this case, if the mirror is rotated by angle theta, keeping the incident ray fixed, then reflected ray will rotate by 2 theta. And that too in the same sense. Same sense means this is clockwise, this is also clockwise. So I would want you guys to remember this. We say, here, reflected ray is rotated by 2 theta in the same sense. Guys, tell me in this case, is this crystal and clear? Please. I would want you guys to give me the signal if this is crystal and clear. Sir, I am a JEE aspirant. I want to ask if I would be able to complete the syllabus before JEE mains examination. When is your JEE Mains examination? That's in the month of February, I guess, huh? November, December, January, February. Yes, you can go with the marathons, okay? I would recommend you the channel that is JEE Nexus by Unacademy. You can go and watch the lectures of Arvind sir, Mohit sir over there. Okay. So you will be remembering from this. You will be remembering this from now onwards. What is that? Guys, smash the like button if you have not liked the session yet. What is that? If the mirror is rotated by theta, keeping the incident ray fixed, then reflected ray rotates by 2 theta in the same sense. Okay, third one. If the mirror is rotated by, if you are rotating the mirrors, guys, if you are rotating the mirror something like this, in that case, this angle of incidence is equal to angle of reflection. Reflected ray will not rotate, it will remain the same. You are just rotating the mirror something like this, okay? So reflected ray will be at the same position. Let's take a look at this question. See, the question says, if the incident ray is rotated by 2 degree, let's suppose I'll mention over here 2 degree anti-clockwise, ACW. And mirror is also rotated by 6 degree anti-clockwise, ACW. Find the rotation of the reflected ray. Find the rotation of the reflected ray. Guys, see. What does it say? It says that, let's suppose this is the mirror over here. And on this mirror, okay, and on this mirror, this is the incident ray falling, and this is the reflected ray in this particular case, okay, and this is the normal, this is the normal, okay. Now guys, this is the angle of incidence and this is the angle of reflection over here. This is the angle of incidence and this is the angle of reflection. Now guys, in this particular case, it says that if the incident ray is rotated by 2 degree, this is the incident ray in anti-clockwise direction, this is rotated by 2 degree ACW. And consider anti-clockwise as negative, okay? Consider anti-clockwise as negative. Tell me one thing. If incident ray rotates by theta, what happens to the reflected ray? Sir, reflected ray will also rotate by the same angle theta, but in opposite sense. We say due to the rotation of incident ray, I can say reflected ray will rotate by we say same angle, 2 degree but clockwise. 2 degree but clockwise. Why? We say opposite sense. Okay. Now guys, tell me one thing. Then it says that, and mirror is rotated by 6 degrees. So it says this mirror is rotated by 6 degrees ACW, anti-clockwise. ACW means something like this, anti-clockwise. Okay. So we say due to the rotation of mirror, we say reflected ray will rotate by, guys, if mirror is rotated by theta, reflected ray is rotated by 2 theta. So here is 6 degrees. It will be how much? 12 degrees. So I can say minus 12 degrees. Sir, why minus 12 degrees? Because it is anti-clockwise. If you are taking clockwise as positive, anti-clockwise you take negative. Okay. Now tell me, in this particular case, this will be clockwise positive 2 degree. What will be the net rotation? Net rotation of reflected ray. How do we write the net rotation of reflected ray? Guys, that is minus 12 degrees and then we say plus 2 degrees. That will be minus 10 degrees. Minus 10 degrees means ACW. 10 degrees in anti-clockwise direction. I hope this is crystalline clear. Now it is easy. Now it is easy, okay? Okay. Next. This question is done already. Let me take it here. Let me place it here. This is the, yeah. Next. Okay. Let's talk about this one. Let's talk about this one. Image formation by the plane mirror. Okay. Guys. Listen to me very carefully. When it comes to the image formation by the plane mirror, okay, see, let me make you understand one thing over here. Let's suppose, my dear friends, we have got a mirror over here. This is the mirror that I'm placing exactly at this point. This is the mirror. Okay. And my dear friends, if this is the mirror, this is polished from this side, back side. And I am placing, guys, understand very carefully, I am placing an object in front of the mirror. This is the object in front of the mirror. Okay. This is the object we have over here. Okay. Now guys, if this is the object over here, we know its image will be formed something like this. Okay. Yes. Guys, see. And this is the person who is looking at this image. We call this as observer. It is like, guys, it is like you have the mirror in front of you and you place a box in front of the mirror, and behind that object you are standing. So means you will be the observer. Observer is the one who is looking at the image, yes, that is the image. Sir, what if we do not place the box over here? Then in that case, you will be the object, you will be the observer. You will be both. Okay. Now what happens in this particular cases, guys, see. We say if this is the object, always remember, we say incident rays will leave from this, okay, and it falls onto the mirror. This is the incident ray. After reflection, it falls into the eyes of the observer. Okay, it falls into the eyes of the observer. So another ray, or lot of rays, okay, from top to bottom, we say rays will leave and it falls into the eyes of the observer over here. Okay, yes, this is the incident ray. When, guys, understand very carefully. If you have the mirror over here, this is the object. I want to see the image of this object. What will happen? We say incident rays will leave from this pen. It falls on the mirror and then it falls into my eyes. When these rays fall in my eyes, then only I would be able to see the image of this object. If, sir, these rays will not fall into my eyes, then would I be able to see the image? No. Now see, guys, this is the reflected ray. If you extend this reflected ray, okay, we say the point where reflected rays meet, we say image will be formed over there. The point where reflected rays meet, image will be formed over there. See. Now, if somebody asks you, is this the real image or the virtual image? Sir, in this case, these reflected rays appear to meet. If these reflected rays appear to meet, so I can say this is the virtual image confirmed. And over here, this object is real object. Why? Because the incident rays are actually leaving from this object. So from now onwards, my dear friends, observer is the one who looks into the image. Tell me one thing. If you place the observer over here, Do you think that these light rays can enter his eyes? No. That's the reason we won't be able to see the image if you sit over here. If you want to see the image, you have to stand over here in front of the mirror. So, incident rays leave from the mirror. They fall into the eyes of the observer. If you extend these, the point where they meet, image will be formed. This is the virtual image, a real object. This is the observer. I hope you got the feel of this one. Now, let's understand this. Let's understand this. See, guys, this is the object. This is the mirror. Okay. Now it will become easy. Now it becomes easy. See, guys. We say light rays will leave from this. This is the incident light ray. Incident light rays leave from the object. So it will be reflected. Okay. My dear friends, we say another light ray something like this, it will be reflected. Another light ray something like this, it will be reflected. Okay, I'm showing with a lot of light rays. Now, if you extend these light rays, these reflected rays, this is the reflected ray, this is the reflected ray. If you extend these reflected rays, the point where they meet, image will be formed. The point from where the incident rays are leaving, that is the object. And if the observer, this A is the observer, if observer is within the field of view, what is field of view? If this is the last ray, sir, beyond this, there won't be any light ray from the object. This is the last ray. If the observer is placed within the field of view, he would be able to see the image. Why? Because then only these reflected rays can enter his eyes. If you place over here, we say, I'll just mention this point. This point is important. If the observer is within the field of view, if the observer is within the field of view, then only rays will enter his eyes and he would be able to see then only he would be able to see the image. Okay, so I can say, my dear friends, in this particular case, what you can mention over here, we say incident rays leave from the object. Incident rays leave from the object and then falls. Incident rays leave from the object and then falls into the eyes of the observer. Okay, incident rays leave from the object and then falls into the eyes of the observer. Then only observer is able to see the image. Like here the observer is placed within the field of view. If you place the observer here, you won't be able to see it. Okay, he won't be able to see it. Okay, now my dear friends, listen to me very carefully. I hope this slide is crystal and clear. Next, see guys, in this particular case, find the minimum. Okay, guys, see. Let's suppose you have this mirror exactly over here. This is the mirror that you have exactly over here. Okay. And in front of the mirror, you have placed a person over here. This person is the object. This person is the observer itself, because there is no other thing which you can keep as object. So if there is only one person, you can call him as object and observer both. Now guys, see, we know, sir, the image of this object will be formed in this particular case. Yes. Now, what happens in this case? Sir, this is the object. First, consider this as object. We know incident rays will leave from the object. This is the incident ray, which leaves from its head. Which leaves from its head. This is the incident ray. First incident ray. Another will be from here, from this, okay? Last one will be from the bottom, from the foot. This is also the incident ray. This is also the incident ray. So we say these rays fall onto the mirror. This is the mirror, okay? These rays fall onto the mirror and they get reflected something like this. This is reflected ray. This will be reflected something like this, okay? This is the reflected ray. Now guys, after reflection, as I have told you, these light rays enter the eyes of the observer. See guys, this light ray is incident. After reflection, it enters the eyes of the observer. This light ray is incident. After reflection, it enters the eyes of the observer. Observer is this. Sir, is this object or observer? Both. So now, my dear friends, these are the reflected rays. If you extend this reflected ray, the point where it meets, image will be formed. See, this is the image. Now guys, you take a look. This is the lowest light ray coming from this object. This is the topmost, highest light ray coming from this object. Means all the light rays fall on the mirror between this point and this point. So this is the part of the mirror where all the light rays of the object are falling. Sir, how much will be this? This is X, we call this. Now see, find the minimum size of the plane mirror. What should be the minimum size of the plane mirror required to see the full image of the observer or to see the full image of the object? Sir, only this much of mirror is required. Why? Because all the rays fall within these 2 points. This part of the mirror is not required. This part of the mirror is not required. Sir, how much is the length? Guys, see, if I say height of the object is h, height means from top to bottom, from head to bottom to toe. So I would say this will be x is equal to h by 2. Sir, how can you prove this? Similarity of the triangles. This bigger triangle, this triangle. Okay. So from the similarity, you will get directly, you remember, sir, x will be h divided by 2. This is the minimum size of the mirror required so that you can see the full image of the object. Why? Because all the light rays are falling between this, within this part of the mirror only. Tell me in the chats, is this crystalline clear? Is this crystalline clear? Guys, give me the signal in the chats. Everyone means everyone. Next, you have a question. A man 180 centimeters tall, a man 180 centimeters high stands in front of the plane mirror. It says that height of the man is 180 centimeters. His eyes are at the height of 170 centimeters from the floor. Means the height of the eyes from the floor is 170. From top, head to toe, it is 180. Okay. Next, from the floor, the minimum length of the plane mirror required to see the full image. What is the minimum length of the plane mirror required to see the full image? What will you say, sir? X is equal to h by 2. Simply, x is equal to h by 2, and that is 180 divided by 2. That is 90. Is that clear? 90 centimeters. Simple. Next. Now guys, see in this particular case, if the child wants, see, this is a good one. You have got the child over here and you have got the father over here. Okay, and this is the mirror. In front of the mirror, you have got the child and son, and this is the father, child and father. Okay. Now, my dear friends, see. We say, if the child wants to see the complete image of his father, child wants to see the image of the father. So could you please tell me which one is the object and which one is the image? Sorry, which one is the object and which one is the observer? I can say, sir, this is the observer and this is the object. Because the one who sees the image is the observer. So child wants to see the image of the father, so this is the observer. Now guys, tell me one thing. See. I would want you to understand. This is at distance d1 from the mirror. Father is at distance d2 from the mirror. Height of the observer child is h1. Height of the object is h2. Now guys, see. In this particular case, what is going to happen? We say, sir, if this is the object, light rays will leave from the object. After reflection, it enters the eyes of the observer. Another light ray from the bottom of the object leaves and it enters the eyes of the observer. Okay. Now, this is the reflected ray. This is the reflected ray. If you extend this reflected ray, the point where reflected rays meet, image will be formed. This is the image of the father. Okay. And if height of the object is h2, height of the image is also h2. Okay. And if I say this object is at d2 distance, don't you think that image will be also at d2 distance? Yes. And my dear friends, see. This is the lowest light ray which falls on the mirror. This is the highest light ray which falls on the mirror. So don't you think that in this case, only this part of the mirror is required to see the full image? Why? Because all the light rays will be within these 2 points only. And what is the length of the mirror required? Minimum length of the mirror required to see the full image. Guys, D1 H2. What is D1? Position of the sun, child, and H2, height of the object, divided by D1 plus D2. Next. If father wants to see the sun's image, now could you please tell me which one is the observer and which one is the object? Father wants to see the sun's image, so this is the observer and this is the object. This is the observer and this is the object. Okay, now tell me one thing. What is going to happen in this particular case? Sir, if this is the object, light rays will leave from the object. This is the highest topmost light ray and it enters the eyes of the observer. Sir, this is the lowest light ray. It enters the eyes of the observer. Okay, so this is the incident ray. This is the incident ray. This is the reflected ray. This is the reflected ray. And guys, if you extend this reflected ray, topmost reflected ray, if you extend this reflected ray, the point where these two reflected rays meet, image will be formed. And don't you think that, guys, this is the lowest light ray falling on the mirror, this is the topmost light ray falling on the mirror. Only this part of the mirror is required to see the full image. So here the value of this x is D2H1 upon D1 plus D2. Here it was D1H2. Here it is D2H1. I would want you guys to tell me in the chats if everything is crystalline clear. Then only I'm moving forward. Everybody, guys, tell me in the chats if this is crystalline clear. Everyone means everyone. Is this crystalline clear? Guys. We don't have to derive these over here. There is the similarity of the triangles that we use. That's the reason I'm saying ignore that. Directly you remember what is the size of the minimum size of the mirror required to see the full image. What is the size of the mirror required to see the full image in this case and that case. That's it. Next, guys, see, in this particular case, relation between the velocity of the object and the image. A relation between the velocity of the object and the image. I would want you guys to understand this very, very, very carefully. See guys. See. In this particular case, here I have got the mirror over here. Okay, I have got the mirror over here. Okay, this is the object. Like I have the mirror in front of me and I am the object. If I am moving towards the mirror, if object is moving towards the mirror with a velocity v, okay, and we call it velocity of the object, so let's call it VO. Okay, and velocity of the mirror is, let's suppose, Vm. Mirror is also moving with some velocity, let's call that Vm. Okay, sir, I have experienced this in my real life. If I have a mirror in front of me and inside the mirror my image will be formed. If I start moving with certain velocity, this image also moves with certain velocity. Okay, if the object moves with some velocity, image will also move. And if you ask me, sir, what is the velocity of the image? Guys, directly in this particular case, and the velocity of the image will be, you can say, sir, velocity of the image is 2 times velocity of the mirror. Sir, this mirror, in 99% cases, we consider the mirror at rest, so means velocity of the mirror will be 0. So this will be the velocity of the image. Sir, with what velocity? Sir, it is 2 times velocity of the mirror, whatever the velocity of the mirror is, minus velocity of the object. And make sure object is moving perpendicular to the plane of the mirror. So this is the mirror. I am moving perpendicular to it. Okay, I am moving perpendicular to the plane of the mirror. This will be the velocity. Okay, now guys, I can say in this particular case, in 99% cases, velocity of the mirror will be 0. Means mirror will be at rest, only object will be moving. In that case, what will be the velocity of the image? Sir, velocity of the image will be 2 into 0 is 0. It will be minus velocity of the object. It will be minus times velocity of the object. What does minus actually mean? Minus means if the object is moving towards the mirror, image will be moving also towards the mirror, something like this, opposite. Image will be moving opposite to the direction of the object. So if the object is moving towards right, we consider the velocity as positive. We say if image will be moving towards left, we consider that velocity as negative. That is the meaning over here. Next. Look at this. Object and mirror moving parallel to the plane. Now guys, see. Let's suppose this is the mirror over here. This object is moving parallelly. Parallel to the mirror like this. In this particular case, whatever is the velocity of the object, same will be the velocity of the image. Velocity of object is equal to the velocity of image is velocity of object. If it is moving parallelly, you have the mirror, you are moving parallelly. It's a long mirror, you are moving parallelly in the upward direction. So image will be also moving in the upward direction with the same velocity. If this is moving with a 10 meter per second in J cap in Y direction, this will be also moving in the J direction with the 10 meter per second. Cool? Yes. Let's take a look at the question first. A man runs to a stationary plane mirror. See, mirror is given over here. Okay. Is this clear, guys? Is this clear? Is this clear? Now see guys, let's take a look. A man runs towards a stationary plane mirror with a velocity of 15 meters per second. You guys have over here a mirror. I'm taking a mirror over here. This is a stationary plane mirror. What does the stationary plane mirror actually mean? What does the stationary plane mirror actually mean? Stationary plane mirror means which is at rest. Okay. So means the velocity of the mirror in this particular case is 0. Cool? Yes, it is rest. Vm is given as 0. Okay. A man runs means there is an object. This is the man. So velocity of the object in this particular case, this is man is the object over here. Its velocity is given as 15 meters per second. Its velocity is given as 15 meters per second. And we know the image of this object will be formed over here. Its image will be this. This is the image. This is the image of the object. Okay. The magnitude of velocity of the man relative to his image, we are supposed to find velocity of man. Guys, see, velocity of man with respect to the image. Velocity of man with respect to the image. Sir, what is this velocity of man? What velocity is this? This is the velocity of the image with respect to the ground. If there is a person who is exactly at the ground, so this is the velocity in that particular case. Sir, how to find this velocity of man with respect to the image? See, I will be telling you one thing. There is a concept in kinematics that is what we call the relative motion. Relative motion. Guys, let me clear these basics exactly over here. Let's suppose I have got a car over here. And this car is moving with some speed, with some velocity. VA is equal to 10 meters per second. I have got another car over here. Okay. And this car is also moving. VB is equal to 10 meters per second. Guys, understand very carefully. Now, if there is a person who is on the ground over here at rest, I am asking this person, what is the velocity of car A? He'll say, I'm at rest, the car is moving with 10 meters per second, so 10 meters per second. So according to this person C, velocity of car A is 10. Similarly, according to this person C, velocity of car B is 10. But if I ask this person A, what is the velocity of car B? A will say, the car B is moving alongside of me. I can speak to the driver. I can give the things to him. So according to me, he is at rest. Why? See, how do we find it? Velocity of B with respect to A. This is velocity of A with respect to ground, with respect to the C, that is 10. Velocity of B with respect to C is 10. But velocity of B with respect to A, how do we find it? Velocity of B, whatever is the velocity, minus velocity of A. VBA minus V is VB minus VA. So this is 10, and minus 10. So it is 0. That's why I am saying, if you are moving with certain speed in a car, your friend is also moving with the same speed in the car. So with respect to you, his speed is 0. Or with respect to him, your speed is 0. That's called the relative velocity concept. Same is the case over here. We have to find the velocity of man, velocity of this object with respect to the image. Let's suppose if this is moving with velocity of O, velocity of the image is, let's suppose, VI. What we are supposed to find out? Sir, with respect to the ground, its speed is 15 meters per second. Now, we have to find the velocity of, the magnitude of velocity of the man related to his image. We have to find velocity of man with respect to the image. That will be, sir, that is velocity of man minus velocity of image. Tell me one thing. If this object person is moving with 15 meters per second, mirror is at rest. This is moving with some velocity. Mirror is at rest. If mirror is at rest, velocity of image is minus times velocity of object. First, we'll find the velocity of image. So velocity of image here, velocity of image will be minus times velocity of object. So velocity of image will be minus 15 meter per second. So this is 15, this will be minus 15. Now, we have to find velocity of the man object with respect to the image. Tell me, the velocity of man with respect to the image will be, velocity of man is how much? That is 15 minus. Velocity of image will be how much? Minus 15. Minus into minus is plus. So velocity of man with respect to the image is 30 meter per second. Simple, bro. Sir, how? Let's suppose I'm giving you, there is one car which is moving at 10 meter per second. There is another car which is moving with 10 meter per second. Okay, this is car A, this is car B. I am asking you, what is the velocity of the car A with respect to B? You say it is velocity of A minus velocity of B. What is velocity of A? 10 meter per second. What is velocity of B? It is minus 10. Why, sir, minus 10? Because if the car is moving in the left direction, we consider its velocity as negative. It will be minus of minus 10. So it will be 20 meter per second. Is this clear? Okay. Is this clear? Whenever we talk about the velocities, we always take along with the sign. We always take along with the sign. Okay, even if you are finding the magnitude, you take along with the sign. Okay. Okay. Is this crystalline clear? Next, let's take a look at this question. An object is moving towards a stationary plane mirror with a speed of 2 meter per second in the left direction. See, guys, you have a plane mirror over here. This is the plane mirror I have. Okay. And in this particular case, it says that an object, this is the object. It is moving towards the stationary plane mirror with 2 meter per second left direction, because it is saying in the left direction. So velocity of the object is, that is, I would say minus 2 meter per second. Sir, why are you mentioning minus over here? Because if the object is moving towards left, we consider its velocity negative. If the object is moving towards right, we consider its velocity as positive. Keep that thing in your mind. Okay. Then it says velocity of image with respect to the object. Guys, see. We know its image will be formed over here. This is the image. Okay. And guys, if object is moving in this direction, we say image will be moving opposite to it. And velocity of the image will be simply, guys, I have told you velocity of the image is minus times velocity of object. Mirror is stationary. Recently we saw velocity of image is negative times velocity of object. So velocity of image is minus, velocity of object is how much? Minus 2. So it will be plus 2 meter per second. Now guys, what we are supposed to find out? Velocity of image with respect to the object. To find velocity of image with respect to the object. How can we find that? Will be velocity of image minus velocity of object. So that will be, what is the velocity of image? That is 2 minus, what is the velocity of object? That is minus 2. So it will be 4 meter per second. Is this clear? Guys, is this clear? Please give me the signal in the chat. And if you have not liked the session yet, I would want you guys to smash the like button as soon as possible. This is the next level question. This is a very good question that we have exactly over here. See guys, in the given situation figure, find the velocity of the image. See. Here, if you take a look, this is the object. Object is moving with 10 meter per second at an angle of 60 degree with the horizontal. This is the mirror. This is the mirror. And in this case, mirror is also in motion. Velocity of the mirror is, we say, 5 meter per second at an angle of 37 degree with the horizontal. And you have to find the velocity of the image. Let's suppose the image is over here. You have to find the velocity of the image. Cool. Let me just tell you. Very nice question. Guys, see. In this particular case, object is not moving perpendicularly. Object is not moving parallelly. If it was the perpendicular and parallel case, I would have used these two cases over here. Sir, in case of the parallel case, velocity of image is velocity of object. In case of perpendicular case, sir, I would have used this scenario over here. But when it comes to this question, object is moving with 10 meter per second. See guys, we say it is moving horizontally. This is its horizontal component and this is its vertical component. Sir, how much will be the horizontal component? See guys, when it comes to the velocity of and horizontal component will be perpendicular component. Sir, when it comes to the perpendicular component, it will be perpendicular to what? Perpendicular to the mirror. It will be V perpendicular is, that is, this is 10 meter, this is 60. This will be 10 cos of 60. Cos 60 is 1 by 2. So 10 by 2 is 5. So this is 5 meter per second. And is that it is in the x direction, guys. It's in the x direction. So I can write over here 5 I cap meter per second. Sir, why did you mention I cap? I cap basically tells you the velocity is in the x direction. Now, if this is 10 cos 60, which component of velocity is this? Sine component. We can resolve the vector in two components. So this will be V parallel in this particular case will be simply 10 sine of 60. Sine 60 is root 3 by 2. So that will be 5 root 3. And this is in the y direction. So j cap meter per second. Because sine 60 is root 3 by 2. 2 into 10. Sorry, 2 ones are 2 5s are 10. So 5 root 3. So parallel component came out to be this, perpendicular component came out to be this. Cool. This is the velocity of mirror. Guys, see. This will be the perpendicular component of the mirror. Velocity of mirror, and that will be the perpendicular component. So how much is this? Guys, see, this will be 5 cos 37. Because if this is theta, this will be cos component, this will be sine component. What is the value of cos 37? Guys. I have told you so many times, this is 3, this is 4, this is 5. This angle is 37. This is the 37 degree triangle. What is the value of cos 37? Sir, cos is base by hypotenuse, that is 4 by 5. So cos 37 is 4 by 5. So this will be, P perpendicular will be, so it is 5 into cos 37 is 4 by 5. 5 will cancel, so it will come out to be 4. And it is in the negative direction. So I can write over here, V perpendicular in this case is minus 4 I cap meter per second. Sir, why did you mention minus? Minus is in the negative x direction. That's why. If velocity is in the negative, we say minus. Now, guys, understand very carefully. See. To find the velocity of image. Guys, this is the image over here. If object has perpendicular component, parallel component, don't you think image will also have perpendicular component and parallel component? Yes, sir, agreed. Let's find perpendicular component and parallel component. Let's find perpendicular component. I see. When it comes to parallel component of velocity of image. Parallel component of velocity of image. Guys, see, when it comes to the parallel component, object and mirror moving parallel to the plane. So both are moving parallelly. In that particular case, I would want you guys to remember velocity of image is equal to the velocity of object. Whatever is the velocity of image, same is the velocity of the object. Guys, tell me one thing. If this is the object, this is the perpendicular component, this is the parallel component. So whatever is the parallel velocity of the object, same will be the parallel velocity of the image. So I can say velocity parallel. Guys, how much is this? 5 root 3 j cap. This will be also 5 root 3 j cap. Because velocity of image is equal to velocity of object. Simple. We got the parallel component. Let's find the perpendicular component. So now, perpendicular component of velocity of image. Guys, how do we actually find the perpendicular component? Object is moving perpendicular to the plane of the mirror. This is the actual velocity. Sir, when is this? This is when mirror is at rest. Here in this question, mirror is not at rest. So in this particular case, when it comes to the perpendicular component, what will you say? Sir, 2 times velocity of mirror minus velocity of object. Now tell me, 2 times velocity of mirror. But you have to take which component, my dear friends? You have to take which component? Perpendicular component. Velocity of object, perpendicular one, is 5i cap. Mirror. Where is mirror? Yes, perpendicular component, that is 4i cap. Minus 4i cap. So I'll write over here minus. This is 4i cap. Then minus velocity of object. But parallel or perpendicular? Sir, we are talking about the perpendicular component, so take perpendicular. So this will be minus 5i cap. Tell me, 2 into 4 is 8. Minus 8i cap, minus 5i cap. So minus 13i cap. This is the perpendicular component. Now tell me one thing. You got the perpendicular component, parallel component. When it comes to the net velocity for image, what will you say? That is parallel component plus we say perpendicular component. Now I can say what is the parallel component? That is 5 root 3 j cap and plus not plus, it is minus you say 3 I cap. This is the net velocity of the image. Sir, how do we find the magnitude? I have told you many times, when it comes to the magnitude of any vector, that will be under root of this square 5 root 3 whole square plus this square, that is minus 3 whole square. Okay, solve this and whatever comes out to be the answer, that is the net velocity in terms of magnitude, and this is the velocity in terms of the vector form. Give me the signal in the chats if this is crystalline clear. This is a very good question. Mark it important. This is a mains level question. Okay, this is a mains. Yes. This is 13. Yes. I changed it. Okay, 13, and here also it is 13. Okay, I changed it, minus 13 square. Done. Okay, next we have images formed by the plane mirrors. I will be sharing the PDFs in the Telegram channel. and you can join the Telegram channel. I'll share the link over here. The link of the Telegram channel is, we say t.me slash YAWAR MANZOOR. t.me slash YAWAR MANZOOR. This is my Telegram channel. You can join this. Now, guys, let's take a look exactly over here. Let's take a look exactly over here. See, in this particular case, image is formed by the two plane mirrors, two parallel plane mirrors. When you have got the two parallel plane mirrors, how many number of images will be formed? See, directly, it will just take 2 minutes. You have got the mirror M1 over here. You have got the mirror M2 over here. These are the very long mirrors, okay, M1 and M2. Let's suppose you are placing the object over here. Let's keep the object over here. Sir, at what distance? It is at 2 centimeters from M1 mirror. Cool? Yes, sir. Now, guys, incident rays will leave from this object. It falls on the mirror M1. Another ray, it falls on the mirror M1. Now, they will be reflected something like this. This will be reflected something like this. If you extend, this is the reflected ray, this is the reflected ray. If you extend these two reflected rays, the point where they meet, image will be formed at that point. Image will be formed at that point. Now, guys, in this case, this image will be also at 2 centimeter. If object is at 2 centimeter, image I1 will be at 2 centimeter. So, mirror M1 is creating the first image I1 at 2 centimeters. Yes. Now see the interesting fact. Now, guys, when these two light rays are incident on this mirror, these two light rays are incident on this mirror. Sir, is this reflected ray or incident ray? For this mirror, this is the reflected ray. For this mirror, this is the incident ray because they fall. So when these two fall over here, this fall over here, they will be reflected something like this. They will be reflected something like this. Now, my dear friends, in this case, if you join these two, if you extend this reflected ray, see, I'll make it over here. So this will be reflected something like this. This will be reflected something like this. So this one and this one, reflected ray. Now, if you extend this reflected ray, if you extend this reflected ray, so the point where these two rays meet, this is called, we say, another image, that is I2. This I2 is formed. This I2 is formed due to M2. Now, guys, tell me one thing. See. For this mirror M2, understand this point. For this mirror M2, it feels like, sir, this is the incident ray which falls onto the mirror M2. This is the incident ray which falls onto the mirror M2. It feels like this ray is coming from this point, from this point. So, my dear friends, this I1 behaves like an object for M2. And this I1 is actually the image of M1. But for M2, it behaves like an object. Why? Because this is the original object. Light rays go, it will be reflected. Light ray go, it will be reflected. It falls over here. So when this light ray falls over here, this behaves like an incident ray. This behaves like an incident ray. It feels like they are coming from this object. So I1 behaves like an object for what? M2. Now tell me, guys. Distance between these two is 10 centimeters. And from here to here, it is 2 centimeters. What is the distance of M2? What is the distance of M2 from this I1? So this is 2 plus 10 is 12. So, my dear friends, if this is the object for this mirror, its image will be formed also at 12 centimeters. So I2 will be also at 12 centimeters. I hope this is crystalline clear, guys. There is no confusion. What I'm trying to say is that for mirror M1, this is the object at 2 centimeters. So image will be at 2 centimeters, I1. Done. For mirror M2, this is the object, which is at what distance? 2 centimeter plus 10 centimeter. So object is at 12 centimeter. Image will be also at 12 centimeters. So 10 plus 2. Similarly, after this is a big mirror. This will fall again on this one. It again creates the image. See, another image will be formed at 12 plus 10, that is 22. Okay. Okay. Because, see, now this I2 will again behave like an object for this. Now this I2 is at what distance? 12 centimeter plus 10 centimeter. That is 22. Another image will be at 22 centimeters from this side. 22. Similarly, another image will be at 32. Another image will be at 42, and it keeps going. So we can say between the two parallel mirrors, number of images will be infinite. Tell me in the chats, is this crystalline clear? Guys, give me the signal in the chats. Is this crystalline clear? Guys, is this crystalline clear to each and every single one? So, number of images in case of two infinite mirrors, in case of two plane mirrors will be infinite. So, I can write over here. Number of images will be infinite. Number of images will be infinite. Next, this one is important, guys. This one is important. See, this one is important. This one is important. Number of images found by two plane mirrors. Guys, see. You have got over here, this is a plane mirror. This is a plane mirror M1, and this is another plane mirror M2. Okay, and these two plane mirrors are at an angle theta. Guys, this one is very important. So we say you have got a plane mirror M1, you have got a plane mirror M2. This is M1 over here, this is M2 over here. And angle between these two plane mirrors is, we say, theta. Okay, yes. Now guys, what I want you to understand is, let's suppose you place, sir, why is it this circular shape over here? Because we are placing at an angle theta. They are at an angle over here. Okay. Now guys, let's suppose we'll place the object between these two plane mirrors. We'll place the object between these two plane mirrors. Okay. See guys. Sir, this is like previously, this was kind of when you have the two plane mirrors parallel to each other. Number of images will be infinite. So this is, we say, linear thing over here. When you talk about the angular thing over here, like two plane mirrors are placed at an angle theta. So object is placed at an angle alpha from M1, and this is at an angle of beta from this one. Like here. When your object is placed at 2 centimeter from M1, 8 centimeter from M2. Here I am saying, in this case, object is placed at alpha from M1, beta from M2. Tell me one thing. Let's take this mirror. Guys, see. If this is the object which is at an angular distance of alpha, don't you think that this mirror M1, guys, please understand this. This mirror M1 creates the image of this object that will be over here. If it is at alpha distance, angular distance, sure also it will be at angular distance alpha. Like here, object is at 2 centimeter, image will be at 2 centimeter. Similarly, if object is at angle alpha, image will be also at angle alpha. I hope this is crystalline clear. Now this is the image I1. Now tell me, my dear friends, like this I1 then you said behaves like an object for M2. Similarly over here, sir, this I1 behaves like an object for M2. We say, I'll just write over here. We say I1 is the image of M1, behaves like an object for M2. This I1 behaves like an object for M2. Now guys, in this particular case, can I say, guys, this I1, what is the distance between I1 and M2? Sir, that is this theta plus alpha. So don't you think that if the distance, if this I1, this object is placed at alpha plus theta, its image will be formed because of M2 at what angle? This is the image I2. At what angle? Alpha plus theta. And its image I2 is formed at alpha plus theta due to mirror M2. Now this mirror M2 will create the image of I1 at what angle? Alpha plus theta. Now my dear friends, once again, this I2 will behave like an object for M1. Now this behaves like an object for M1. Now again, I2 behaves like an object for M1. Now, what is the distance between M1 and this object? I2. Sir, that is this alpha plus theta plus this theta. That will be alpha plus 2 theta. So, this M1 will create another image I3 at what angle? Alpha plus 2 theta. Okay. Now, again, I2 behaves like an object for M1. I2 behaves like an object for M1 and creates its image I3 at what angular distance? Sir, that is alpha plus theta plus theta. That will be alpha plus 2 theta at alpha plus 2 theta. And once again, my dear friends, this I3 behaves like an object for M2. Okay, now this M2 will again create its image somewhere around over here. That will be I4. At what distance, my dear friends? See, this is alpha plus theta plus theta. How much is that? Alpha plus 3 theta. So this will be alpha plus 3 theta. Because from here to here it is alpha plus 2 theta. From here to here it is theta, alpha plus 3 theta. So this will be creating its image at alpha plus 3 theta. And it keeps on going. Okay, now guys, let's take a look over here. Sir, previously in this particular case, you said number of images created between the two parallel mirrors will be infinite. Sir, how many number of images will be exactly in this circular concept over here, in this angular concept over here, if the two mirrors are placed at an angle theta? See guys, in this case, what you need to remember is, in order to find, see, here is a bit trick that you need to remember. In order to find the number of images, now to find the number of images, first find M. Sir, what is M? You'll get to know. M means 360 divided by theta. What is 360? 360 is the one complete cycle, 360 divided by theta. Theta is the angle between the two mirrors. If I am saying you have got the two mirrors over here. Sir, two mirrors. Angle between these two is 60. So that is theta. So m will be 360 by 60 in that particular case. Okay. Once you get the value of m, that is 360 by 60, where theta is the angle between the two mirrors. Okay. Now. Take a look. If m is an integer, means if m comes out to be 2, 5, 7, 10, okay, integer, okay, and integer, and if m is even, okay, 2 is also integer, 7 is also integer, 9 is also, 10 is also, and if integer and even, then we say number of images will be m minus 1. Like, let's suppose, I'll show you the questions, guys. Let's suppose if I'm saying value of m, comes out to be, let's suppose 12. 12 is an integer, 12 is even. So number of images in that case, n will be m minus 1, that is 12 minus 1, that is 11. This is the answer. And my dear friends, listen to me very carefully. If m is an integer and m is odd, if m comes out to be 7, 3, 5, then you have to again check. If object is at angle bisector, number of images will be m minus 1. And if object is not at angle bisector, number of images will be m. Sir, please make this understand. I'll show you the questions. This will be crystal and clear. First question you have, two mirrors are inclined at an angle of theta is equal to 30 degrees. So what is the value of theta? That is 30 degrees. An object is placed making 10 degree with m. Guys, see, you have got mirror m1, you have got mirror m2. This is m1, this is m2. It says that object is somewhere around over here. This is the object. Okay. This is making 10 degrees over here. It is making 10 degrees over here. Object is making 10 degrees with m1. Object is making 10 degrees with m1. And how much is this angle? This is theta. That is 30 degrees. We have to check, find the total number of images. Guys, see. To find the total number of images, what do we do first? We find m. Let's find m. So I can say m will be 360 divided by theta. That is 360 divided by 30. This and this goes, 3 12s are. So m comes out to be 12. Now m is even. If m is even, we say number of images. Guys. If m is even, number of images is m minus 1. Number of images is m minus 1. So that is 12 minus 1, that is 11. Done. Number of images is 11. Okay. Next, take a look over here. We have two mirrors. Angle between the two mirrors is, first they are saying 60. First they are saying theta is equal to 60 degrees. We have to find the number of images. Guys, see. First case, theta is equal to 60 degrees. Let's find m. So m will be 360 divided by 60. This and this will cancel. 6 are. M is 6. And this is even. If m is even, we say number of images will be m minus 1. So n will be 6 minus 1, that is 5. Okay, it is 5. Next, second, theta is equal to 72. Theta is equal to 72 degrees. And object is at 40 degrees from m1. It says that object is making how much? 40 degrees from m1. Guys, object is making 72 degrees. Okay, 40 degrees. Guys, see, in this particular case, m will be 360 divided by, we say, sir, 72. It comes out to be equal to 5. And this is odd. 5 is odd. Now, there are two cases when the value of m is odd. If m is odd, then you check Object is at angle bisector. Number of images will be m minus 1. Object is not at angle bisector. Number of images will be m. Guys, see, angle bisector means if this is the angle 60 degrees. Angle bisector of 60 degrees exact means 30 degrees. Object is at 30 degrees. That is the angle bisector. If I say, sir, it is 10 degrees, so that is not the angle bisector. Here, it is not bisecting the angle exactly. Okay, 30, 30. So, in this particular case, what is the half of 72? That is not 40. Okay, so 36 is the half of 72. So, we say in this particular case, this number of images will be here. Object is not at angle bisector. Okay, so in this case, number of images will be what? We say when it comes to not, object is not at angle bisector, number of images will be m only. So that is m and that is 5 only. Okay, third one, if I just write over here, third one, we say theta is given as 72 degrees. Okay, so m in this case will be 360 divided by 72, that is 5, and that is odd. And here it is saying object is at 36 degrees from m1. Object is at 36 degrees. So 36 is half of 72, that is angle bisector. And object is at angle bisector. So in this case, number of images n will be m minus 1. So that is 4. Okay. And last one you have, if theta is equal to 80. Okay. If theta is equal to 80. So let's find the value of m. So m in this case will come out to be 360 divided by 80. It comes out to be, I guess, 4.5. Whenever you have something like this, you directly say answer is 4. Number of images is 4. Number of images is 4. If it is in points, so number of images will be 4. Okay. Now guys, take a look exactly over here. If you have not liked the session, and I would want you guys to smash the like button as soon as possible, because liking the session is extremely mandatory. See guys, spherical mirrors. Spherical mirrors. Sir, what does a spherical mirror mean? Till now we were talking about the plane mirrors. Let's now discuss the spherical mirrors. See guys, let's suppose you take a sphere over here. This is a complete sphere. Okay. And I would want you guys to cut the sphere over here something like this. Now when you cut the sphere, it will be something, this part of the sphere will be something like this. Okay, bowl. You are cutting a bowl from the sphere. Okay. And my dear friends, this inner side of the bowl, this is called the concave side. Okay. This is called the concave side. And this outer side will be called convex side. Outer side is called convex side. Inner side is concave side. Outer side is convex side. We'll take the break exactly after 3 hours, after the completion of 3 hours. Means we'll be taking the break around 8 o'clock, 8 or 8:10. Okay. So this is basically the convex and concave side. Now guys, if you do the polishing from the outer side, okay, and then we say a reflection takes place from the inner side. This is the reflecting surface. This is the concave surface, or this is, we say, reflecting surface. A reflecting surface. And this is the polished surface. Guys, see, if the reflection takes place, if the reflection takes place from concave side, it is called concave mirror. Guys, if you polish from the convex side and reflection takes place from the concave side, means it is a concave mirror. Simple definition of concave mirror. So it depends from which side reflection is taking place. So reflection is taking place from concave side, it is a concave mirror. Okay. Next, when it comes to the convex, if you polish from the inner side, this is the polished surface. Polished surface. And this is the reflecting surface. Reflecting surface. So in this particular case, if the reflection takes place, from convex side, convex side is the outer side, it is called convex mirror. It is called convex mirror. Now guys, I won't be making from now onwards the complete bowl over here, just this curved surface over here only. Okay. Now tell me, which mirror is this? Is this concave mirror or convex mirror? Is this concave or convex? In this particular case, we say reflection is taking place from the concave side. So this is a concave mirror, because convex side over here is, we say, polished. Convex side is polished. Okay. Now guys, what I want you guys to do is, you draw a line over here, something like this. Okay. Which is cutting this mirror exactly from the center. This is called the principal axis. From now onwards, if there is a line which is cutting the mirror exactly from the center, that is called the principal axis. Okay. The point where it is cutting, that is called the pole. Pole of the mirror. That is called the pole of the mirror. Okay. And my dear friends, if you complete this circle over here, it becomes complete sphere. And this sphere will obviously have some center. So that is called the center of curvature. Center of curvature is that point. If you complete this and make it a whole sphere, whatever be the center of that sphere, that will be the center of curvature of this. And we know, if you complete this, if you make a complete sphere, don't you think that from here to here, this is the radius? And here we call it radius of curvature. From center of curvature till the mirror, this line, this is called the radius of curvature. This is called the radius of curvature. Okay. And my dear friends, listen to me very carefully. Listen to me very carefully. Between center of curvature and between this pole, you have got the focus. You have got the focus at the center. And when it comes to the focus, guys, this from here to here is R. This is also R. How much is this? R by 2. This is R by 2. So what is the value of this focus, focal length from here? That is R by 2. This is focus is R by 2. Okay. This is the focus and this is called the focal length. Okay. That is R by 2. Is this clear? Is this clear? Okay. Now, I would want you to remember one thing. Guys, see, Let's suppose there is a light ray which is parallel to principal axis. There is a light ray which is parallel to principal axis. This light ray is parallel to principal axis. Sir, where does this light ray come from? Let's suppose there is the object. From that object, light ray is coming, incident. We say after reflection, it passes through. After reflection, it passes through focus. If there is a light ray which is parallel to principal axis, after reflection, it passes through focus. Remember it over here. If there is a light ray which is parallel to principal axis, after light ray, it is passing through focus. Okay. Now, my dear friends, as of now, I made a concave mirror over here. And this line I call as principal axis. This point is called center of curvature. From center of curvature till here, this distance is radius of curvature. Sir, this is focus. This is pole. This will be focal length, and focal length is half of the r/2. Okay, that is r/2 simply. And if the light ray is parallel to principal axis, falling on concave mirror, after reflection, it has to pass through focus. Yes. So this is the detail in this one. Now let's move on to the ray tracing. Guys, see. What does a ray tracing actually mean? Let's suppose you take over here concave mirror in this particular case. You take concave mirror. Okay. This is the principal axis. This is the focal point. This is the focus. And this is the center of curvature. And this will be the pole. Guys, I told you, if the light ray is parallel to principal axis, see this light ray is parallel to principal axis. After reflection, it has to pass through focus. That is what is mentioned over here. If the incident ray is parallel to principal axis, then the reflected ray passes through the focus. That is what I'm saying. From now onwards, if you take a curved mirror, spherical mirror, light ray is parallel to principal axis. After reflection, it will pass through focus. Okay. Now guys, see. Here, which mirror is this? Concave mirror. Sir, which mirror is this? This is convex mirror. Why? Because reflection takes place from convex side. And this is concave mirror. In case of concave mirror, you defined it something like this. In case of convex mirror, you are defining it something like this. See, guys? Sure. If the light ray is parallel to principal axis, in this, but guys, when it comes to the convex mirror, if this is the convex mirror, don't say, sir, its focus will be from this side. No. You complete the sphere from this side. So focus will be here, center of curvature will be here, radius of curvature will be this. All of these lie from this side. Okay, from the curved side. Okay. Now guys, tell me one thing. If the light ray, this is the incident ray. If the incident ray is parallel to principal axis, okay, we say after reflection, my dear friends, it will be reflected something like this. Okay, because we say this is a converging mirror. It will converge and passes through focus, and this will diverge. So after reflection, it will diverge because this is a convex. It will diverge after reflection. Now guys, I would want you to understand this. I would want you guys to focus exactly over here. I know guys, it will be very difficult for you to write the notes, okay, make the notes. But if there are some legends out there, they would definitely make. But it is a bit difficult because this chapter, it's a very big chapter. So, and if I start drawing this over here in the class itself, then it will take me 3 days, 4 days to complete this chapter in one go. It's not like other chapters, because making these diagrams is very difficult in the class in a less amount of time. Okay. Now guys, see. So we say Here light ray will be diverged. Now in this particular case, if you extend this reflected ray, it will pass through focus. In this case, if an incident ray is parallel to principal axis, then after reflection, it appears to pass through the focus. It is not actually passing through the focus. It appears to pass through the focus. I have told you the meaning of that. It looks like it is passing through the focus. In case of what? Convex mirror. In this case, image is formed at the focus. Let's talk about this later on. Okay. Here it appears to pass through the focus. It is not and when it comes to this case, here it is actually passing through the focus. Here it appears to pass through the focus. It looks like it is passing from the focus. Next, if the incident ray is passing through the center of curvature, guys, this is a concave mirror. This is a light ray coming something like this, passing through the center of curvature. Light ray is passing through the center of curvature. Then will be reflected through the center of curvature only. Guys, if this is a light ray, it is passing through the center of curvature, it will make 90 degrees over here. Because you might have seen one thing. If this is a circle, so this radius always makes 90 degree with this surface. So if it is at 90 degrees, so it will be reflected back along the same path. It will be reflected back. Remember this, if the light is parallel to principal axis, it will pass through focus. If the light is passing through center of curvature, it will be reflected along the same path through the center of curvature. Next, let's talk about, this is which mirror? This is concave mirror. I'll be writing over here, concave mirror. Concave mirror. Let's talk about in case of convex mirror. This is the convex mirror. Let's talk about convex mirror. Guys, see, when it comes to the convex mirror, this is the convex mirror in this particular case. Okay. See, I say the light ray is falling at an angle of 90. Here, like here light ray is falling at an angle of 90. Here also at a 90. We say if light ray touches the sphere, touches the mirror at an angle of 90 degrees, it will be reflected along the same path. But what is the difference in this particular case? This is the center of curvature. We say in case of convex mirror, it appears to pass through the center of curvature. In previous case, in case of concave, it is actually passing, reflected ray is actually passing through the center of curvature. Here, reflected ray appears to pass through the center of curvature, or incident ray appears to pass through the center of curvature. Okay. Reflected ray leaves from the, okay, forget about these 2 points. We'll talk about this later. So as of now, here, in this case, it appears that ray is coming from point C, or the center of curvature. Guys, give me the signal till over here. Is this crystalline clear? Is this crystalline clear? Everyone means everyone. Next. Great. If a parallel beam of light are falling and making theta with the principal axis. Guys, see. Now in this particular case, this is the third case of ray tracing. If there are light rays falling on this mirror, which are parallel, these are the parallel beam of light rays, making angle theta with the principal axis. Okay. They will converge all at this is what we call the focal plane. Now see guys, we say the light rays are falling parallelly. They will be reflected something like this. And let's place a sheet over here, the plane, sheet, cardboard, whatever you mean. We say all of these will converge. They will meet at a particular point. So they will meet on the focal plane. This is called the focal plane. They will meet on the focal plane. Okay. Guys. If this is theta Angle of incidence, we know angle of reflection will also be theta in this case. Yes. Now tell me one thing. I would want you guys to tell me one thing. See, guys. We say here, the rays will meet at focal plane. Now, if somebody wants you to find this distance, at what distance from this principal axis? See, guys, take a look at this triangle. Take a look at this triangle. Okay. So this is focus. This is focus. So from this point to this point. Okay. From this point to this point, this is F, focal length. This angle is theta. Let's suppose we have to find this Y. We have to find the value of this Y. Guys, see, don't you think that in this particular case, we can find tan theta? Tan theta is perpendicular by base. That is Y divided by F. So Y will be equal to F tan theta. And guys, remember here, theta is very small. We say theta is very small. If theta is very small, then tan theta, value of tan theta is almost equal to theta. So Y is equal to F into theta. That's why it is mentioned over here. This distance will be actually F into theta. This distance will be F into theta. Whatever this angle is and whatever is the focal length over here. So directly we'll be remembering, if the parallel beam of light rays are falling or incident on the concave mirror, we say they will converge on the focal plane. At what distance from the principal axis? F into theta. Next, in case of convex mirror, this is in case of, and in case of concave mirror, guys, these light rays are actually meeting. In reality, they are meeting. But when it comes to the concave mirror, guys, see, here, I would want you to focus. We say these are the parallel beam of light rays falling. These are the parallel beam of light rays falling. Now, guys, after reflection, this will be the reflected ray. Now, these are divergent rays because we know convex mirror will diverge these rays. Concave will converge. That's why over here, this mirror is converging them. What about this concave? This is diverging them. In case of diverging mirror, like here, my dear friends, we say here also it was diverging. Here also it was diverging. Here also it will diverge. So this light ray will go something like this. This light ray will go something like this. So they are diverging from each other. But if you extend these reflected rays, they appear to meet at the focal plane. We say in this case, here reflected rays appears to meet at focal plane. Reflected rays appears to meet at focal plane. Okay. And guys, this is a convex mirror. The focus of convex mirror will be from this side, and this is the focal plane in this case. Focal plane. This is the focal plane. Okay. Now, guys, this distance is F, and this angle is theta. Like previously, this is theta, this is theta, this is theta. And how much will be this distance? This will be F theta, like previously we discussed. Okay. So ray tracing is done. Now let's talk about the image formation. Guys, give me the signal in the chat. Is this crystalline clear till over here? Everyone means everyone. Tell me. And smash the like button if you have not liked this session yet. Tell me, guys. I'll give you the break exactly at 8 o'clock, okay? We need to finish this. We need to finish this. What are you guys doing? Break, 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 break. Okay? See, guys, image formation. Now, guys, we will have to take convex mirror, we will have to take concave mirror, and we'll have to form the images. Like previously, when we took the plane mirror, this was the object, this was the image. Now, here also, we will make the image in case of convex and concave mirror, but the cases will be different. Lot of cases we have to discuss. See, guys. First case is, in case of concave mirror, let's talk about concave mirror first. In case of concave mirror, if object is beyond 2f, if object is placed beyond 2f, see guys, see guys, see guys. Let's suppose, my dear friends, over here, let me take it over here. Yeah. See guys, this is the concave mirror. Okay. This is the principal axis. Yes, sir. This is the focus. This is the pole. And this is 2f. Sir, what is 2f? 2f means center of curvature. This is r by 2. R by 2 total is r. So this is, if the object is placed beyond 2f, if you place an object beyond 2f, beyond center of curvature. Now, how image will be formed? Please look at this very carefully. How image will be formed? This is the object. This is the object. I'll be mentioning over here. This is the object. Okay. Now, guys, we know incident rays will leave from the object. This is the incident ray. One ray I'll make parallel. Okay. We know if the light ray is parallel to principal axis, it passes through the focus. Recently, we studied in ray tracing. Okay. Now, another light ray, let's suppose it is going, it is passing, it is hitting the pole over here. Okay. And then it is reflecting, something like this. Now, guys, this is incident ray. This is incident ray. This one is reflected ray. This one is reflected ray. The point where reflected rays meet, image will be formed. The point where reflected rays meet, image will be formed. This is the image. Guys, tell me one thing. Please tell me one thing over here. See. If in case of the concave mirror, if the object is placed beyond 2f, tell me, where is the image formed? Image is formed between f and 2f. See, image is formed between f and 2f. Image is formed between f and 2f. Okay. Now, guys, image will be real. What is real image? Real image is that image where reflected rays are actually meeting. See, in this case, reflected rays are actually meeting. It does not appear to meet. So that's why we say real image is real. Image is real. It is not virtual image. Real image will be inverted. Guys. Inverted means if this is direction is something like this, standing. This is upside down. Inverted means upside down. So if this is the object, if this is the image, this will be upside down. This is the, we say inverted image. Then we say diminished. Diminished means size of the image is less than the size of the object. Size of the image is less than the size of the object. Okay. Smaller, I'll just write over here. Smaller than the object. Okay. And this is upside down. Upside down. So from now onwards, you'll remember that in case of concave mirror, if object is beyond 2f, image will be formed between f and 2f. It will be real. We say inverted and diminished. Next. Guys, take a look over here. Take a look over here. If object is placed between f and 2f. Now, previously it was beyond 2f. Now let's place it between f and 2f. This is f and this is 2f. Okay. This is the object. This is the object. I'll write over here. This is the object. Okay. Now guys, tell me one thing in this case. We say incident ray will leave from the object. This is parallel to principal axis and it will pass through the focus. Another light ray hits the pole and it will basically be reflected something like this. The point where reflected rays meet, the point where reflected rays meet, my dear friends, that will be the image. So this is the image in this particular case. This is the image over here. Okay. Now tell me, where is the image formed? Sir, image is formed beyond 2f. Image is formed beyond 2f. It will be real. Guys, reflected rays are actually meeting. So image is real, not the virtual. Okay. Okay. Now. Inverted. What does inverted mean? Guys, this is, we say, something like this, and this is upside down. That is inverted. Magnified. What is diminished? Diminished means the size of the image is less than the size of the object. But when it comes to my dear friends, magnified, image is bigger than the object. Magnified means bigger than the object. This is bigger than the object. Bigger than the object. Next case, if the object is between focus and pole, see guys, this is the concave mirror, this is pole, and this is focus. Now we'll place the object over here. One ray is parallel to principal axis, it will pass through the focus. We know if the light ray is parallel to principal axis, it will pass through the focus. Okay. Second, if this light ray hits the pole, it will go something like this. Now these two light rays will diverge in this particular case. Okay. Now, if you extend this, so they will meet at this point. Now here in this case, these two light rays appear to meet. They are not actually meeting. These two light rays appear to meet. The point where the light rays appear to meet, virtual image will be formed. So I can say its image is formed as virtual. Its image is formed as erect. Erect means which is something like this. It is not inverted. It is not upside down. It is erect. Okay. Magnified, you see, size of the image is bigger than the size of the object. Size of the image is bigger than the size of the object. This is image. This is object. Okay. And this image can be formed between 0 to infinity anywhere. Between pole to infinity anywhere this can be formed. Now, image formation in case of concave mirror is done. First case was if the object is beyond 2f. Second case was if the object is between f and 2f. Third case is if the object is between focus and pole, f and pole. Now, let's talk about convex mirror. Image formation in case of convex mirror. Image formation in case of convex mirror. Guys, first one, take a look exactly over here. If the object is placed near to the mirror, guys, see. When it comes to the convex mirror, it is polished from this side, okay, from the inner side, and reflection takes place from the outer side. And when it comes to the center of curvature, when it comes to the pole, that is from this side, from the inner side. So you cannot say, sir, pole is here, center of curvature is here. So in this case, we discuss only two cases: when the object is near to the mirror, when the object is far from the mirror. Previously, we had three specific cases, sir, between center, beyond center of curvature, between focus and center of curvature, between focus and pole. But here there is no focus from this side, there is no pole from this side, there is no center of curvature from this side. So that's why we have only two cases in this particular case: if the object is near to the mirror, if the object is far from the mirror. See guys, first case is object is near to the mirror. I would want you to focus. Light ray goes parallel to the principal axis. It will be reflected something like this. If the light ray is parallel to principal axis, in case of convex mirror, it appears to pass through focus. Already discussed. It appears to pass through focus. If the light ray is basically going something like this, okay, if the light ray, another light ray, I am saying, sir, it is going such that it is making the angle 90 degrees, it will be reflected along the same path. I hope you remember the ray tracing. I hope you remember the ray tracing. If the light ray in case of convex mirror, if the light ray in case of convex mirror is making 90 degrees, it will be reflected along the same path. Another one, in case of convex mirror, if the light ray is parallel to principal axis, it appears to pass through focus. Same logic I am using over here. Same logic I am using over here. Okay. First light ray is parallel to principal axis, so we say it appears to pass through focus. Another light ray is through center of curvature, it will be reflected along the same path, but it appears to pass through center of curvature. Now it extend this. In this case, the point where reflected rays meet, here reflected rays appear to meet. In this case, reflected rays appear to meet. So the image formed here will be virtual. Image formed here will be virtual. Okay, guys, see the details. See the details. We say image formed is virtual because the reflected rays are not actually meeting. They appear to meet here at this point. Image formed is virtual. Image will be erect. It is not upside down. I'll just write over here. This is image, and this is object. It is mentioned. Okay. It is erect. It is diminished. Size of the image is smaller than the size of the object. That's why we say it is diminished. Okay. And it will be between pole and focus. This is focus. This is pole and this is focus. It will be formed between pole and focus. Guys, sir, are we supposed to remember these? Yes, you have to remember these, all of these cases, because they will be directly asking you the question, if the object is placed near to the convex mirror, where the image will be formed. Is the image diminished, or is the image, we say, magnified? Is it erect or is it inverted? They will be asking the question something like this. Next, if the object is placed at infinity, object is at very far distance, infinity. Always remember, if the object is at infinity, then we say from infinity parallel light rays come. If the object is at infinity, we say parallel light rays come. So this light ray is falling, okay? It is along the center of curvature. Second light ray is falling such that it is along with the pole. So we say it will be parallel after reflection. Sir, what is this? See. You have studied previously. If this is the, let's suppose this is the mirror over here, okay? This is the pole over here, or this is the focus over here. Light ray is parallel to principal axis, it passes through the pole. It passes through the focus. You can say it something like this also. If the light ray is passing through the focus, after reflection, it becomes parallel to principal axis. You can say it something like this also. It's one and the same thing. Similarly, in this case, if a light ray appears to pass through focus, after reflection, it becomes parallel to principal axis. Sure, light ray appears to pass through center of curvature. It will be reflected along the same path. Now, guys, this is the reflected ray. This is the reflected ray. This is the incident ray. This is the incident ray and this is the reflected ray only. So extend this reflected ray. Extend this reflected ray. Extend this reflected ray. The point where they meet, image will be formed. So this image is clearly at focus. Image formed is virtual because reflected rays appear to meet. They are not actually meeting. Reflected rays appear to meet. So we say image formed is virtual. Okay. Image formed is erect. Okay. It is erect and is very small as compared. See. Object is at infinity. As compared to that object, this image is very small. So if object is placed at infinity, image formed will be virtual, erect, and it will be diminished very small, and it is formed at focus. It is formed at focus. It is formed at focus. Guys, give me the signal in the chats. How many of you understood this properly? I would want you guys to tell me in the chats how many of you understood this. This was the image formation in case of the spherical mirrors. This was the image formation in case of the spherical mirrors. Okay. Now, guys, an important formula that is the mirror formula. That is the mirror formula. See guys. I would want you guys to understand one thing. See, let's suppose I have got over here a mirror. Let's suppose I'm taking a mirror over here. Okay. And this is polished from this side. This is polished from this side. And this is the principal axis that I'm taking exactly over here. This is the principal axis that I'm taking exactly over here. Okay. Now, my dear friends, if I place the object over here, this is the pole, this is pole. If I place the object over here, this is the object. Distance of the object from the pole, we call this as u. We mentioned this as u. Okay. Let's suppose the image is formed. For example, I am saying image is formed over here. Let's suppose this is the image. Okay. We say distance of the image from the pole, from this mirror, it is v. Okay. And focal length of this is, let's suppose, f. Focal length of this is, let's suppose, f. Okay. Now, my dear friends, if you have to find in a question, sir, how to find this u. If v is given, focus is given, find u. If u is given, f is given, find v. For that, we have the formula that's called the mirror formula. Okay. So we say this formula helps us. This formula helps us to find the position of object, image, and focal length. This formula helps us to find the position of the object where the object is, position of the image where the image is formed, and focal length. Or you can also say it is the relation between, we say position of the object, position of the image, and focal length. That is, what is the formula? 1 by v plus 1 by u is equal to 1 by f. 1 by v plus 1 by u is equal to 1 by f. And one more thing, what is u? U is the position of the object, v is the position of the image, f is the focal length over here. F is the focal length over here. Okay. Now, guys, sign conventions in this case is very important. See. Let's suppose I have got a mirror over here. This is the mirror that I'm taking in this particular case. This is the mirror that I'm taking. Okay. Okay, this is the mirror that I'm taking. And in this particular case, guys, we know reflection takes place from this side. So obviously, I will place the object from this side. This is the object. I will place the object from this side. Okay, I'll place the object from this side. My dear friends, and we know incident rays always leave from the object. This is the incident rays. Incident rays always leave from the object. From now onwards, I would say, guys, it is mentioned over here. Take that direction as positive in which incident ray is moving along the principal axis. Guys, tell me one thing here. This is the direction of incident rays. So you have to take that direction as positive. So this will be positive side. This will be negative side. Take that direction as positive in which incident rays are moving. This will be positive side. This will be negative side. Okay. Let's suppose I'll make it something like this. I have got a mirror over here. Okay. And this mirror is polished something like this. This mirror is polished something like this. This is the principal axis. And if it is polished from this side, obviously reflection takes place from the inner side. Let's suppose I'll place the object over here. This is the object. Now, what is the direction of incident rays? Sir, direction of incident rays will be this, because incident ray always leave from the object, falls onto the reflecting surface. In this case, guys, the direction of incident ray is considered as positive. So this will be positive side. This will be negative side. Okay. And from the upper side, see, here along the horizontal direction, this is positive, this is negative. In this case, this is positive, this is negative. And in the vertical direction, we take this as positive, and we take this as negative, lower side as negative. Okay. Guys, one more thing. Let's suppose I have got convex mirror over here. Okay, I have got convex mirror over here. So this is the convex mirror. This is the principal axis. Now, guys, in this particular case, we will place the object from this side. And we say incident rays, direction of incident rays will be this. This is the object. This will be the positive side, and this will be the negative side. Now, tell me one thing. Guys, focal length of this mirror will be from this side, okay? Somewhere around over here. So we say focal length of this will be negative. Why? Because focus of this is from the negative side. Just 2 minutes, I'll finish this and we'll take the break. Focus of this will be negative. And this is object. We say position of the object is also negative in this particular case because object is placed from this side. So what about the image? Image we will see later on. If the image is formed from this side, that will be also negative. If the image is formed from this side, that is positive. Here, guys, focal length of this mirror is from this side, somewhere around over here. So focus length will be negative. Why? Because that is from negative side. And U is also negative. That is position of the object. Here in this particular case, guys, focus of this is from this side. Somewhere around over here will be focus. And in this case, focus will be positive. Why? Because it is from positive side. So whenever you use the mirror formula, you have to use the sign conventions also. Okay. And we say when it comes to U, position of the image, sir, that is negative in this case. Why? Because that is from this side, negative side. Okay. Yes. So let's take a break. Break will be till 8:50. Yeah? Check. So guys, we are back. Okay, let's start the journey. So let the people come and join and we'll start once again. Okay. Okay guys, let's now basically move and we have this question exactly over here. So we discussed the mirror formula previously. Okay, we discussed the mirror formula. On this mirror formula only, we have got this question. We are supposed to find the location of the image. Means we are supposed to find value of V. Okay, where the image will be formed. Where the image will be formed. In this particular case. Okay. Now guys. See. First and the foremost thing is, I would want you guys to tell me one thing. What is that? See, guys, this is the object over here. If this is the object, this will be the direction of incident rays. Why? Because incident rays always leave from the object. So this will be the positive side and this will be the negative side. Okay. Focus of this will be from this side. So I can clearly say focal length will be minus 10 centimeters. Because focal length of this is given as 10. So it will be minus 10. And object is from this side. So position of the object is minus 30 centimeters. We are supposed to find the value of V. Guys, can we use, we say as. What is the mirror formula that we recently studied? 1 by V is equal to 1 by V plus 1 by U is equal to 1 by F. So can I use the same formula over here? We say as 1 by V plus 1 by U is equal to, we say 1 by F. Now guys, take it over there. So 1 by V will come out to be 1 by F minus, we say 1 by U. Do the cross multiplication. In this particular case. Do the cross multiplication, guys. So if we do the cross, so we say 1 by V will come out to be. So this is U minus F upon U into F. Okay. Now do the reciprocal. So we say V will come out to be U into F upon U minus F. Guys, from now onwards, whenever we have to find the position of the image, we will be using this equation directly over here. Again and again, I'll not do the same thing. So I'll be directly using V is equal to U into F upon U minus F. Now tell me, what is the value of V? We say V in this case will be, sir, U. What is the value of U? That is minus 30 over here. Okay. Multiplied by what is focal length in this case? That is minus 10. Then we say, what is U? That is minus 30. We say then minus into minus is plus. We say, sir, 10 over here. Okay. Now tell me guys, in this particular case, how much will be this? This will be 300. Okay. Divided by minus 30 plus 10 will come out to be in this particular case. That is 20 over here. Okay. And that will be simply V will come out to be, and this is minus 20 because this is minus. So that will be minus 15 over here. Okay. Okay. Is this crystalline clear? Because this 0 and this 0 will cancel. 30 divided by 2 is minus 15. So minus 15 centimeters over here. Okay. Now, my dear friends, what does minus 15 centimeters say over here? Guys. From this side, it is negative side. This is positive side. Means if it is minus 50, this is minus 30. Guys, this is minus 30. So minus 15 will be around over here. So this will be the position of the image. So this is V is equal to minus 15. So position of the image will be from this side. So this is the real image in this particular case. Okay. Let's move on to the next one. Let's suppose you have got this image. Let's suppose you have got this. Find the location of the image. Tell me the answer of this particular question. Tell me the answer of this particular question, guys. See, in this particular case, guys, we say this is the object. So incident rays will be in this direction. The incident rays always leave from the object. So this will be the positive side. This will be the positive side. And this will be the negative side. This will be the negative side. Clearly you can see this u will be minus 20 centimeters because this is from negative side. And focus of this is on the right side. Focal length in this particular case is given as, that is, plus 20 centimeters. Focus is given as plus 20 centimeters. What we are supposed to do? Focus is positive because it is from the right side. We are supposed to find V. How to find V? That is u into f upon u minus f. Directly I'll be using. So V will come out to be, what is the value of u? U is minus 20 and this is plus 20 upon u minus f. That is minus 20 minus focal length is, we say, sir, 20. So this will be 20 to 20 is 400 minus 400 divided by 20 is minus 40. So this and this will cancel, this and this 10s are. So it will be 10. So V is coming out to be, we say, sir, plus 10 centimeter. Okay. This is from the negative, this is the negative side. Plus 10 means image will be made from this side. Okay. So here incident rays will reflect. So we say image in this case will be virtual and that will be from this side. That will be from this side, positive side. I hope this is crystal and clear. I hope this is crystal and clear. Now guys, next thing I need to discuss over here. Magnification. Magnification. What does magnification mean? Guys. It is defined as the height of the object upon height of the image. Sir, what is that? Magnification means size of the image compared to the size of the object, or it tells us, it defines the size of image compared to size of the object. Compared to the size of the object. Magnification defines the size of the image compared to the size of the object. Compared to the size of the object. Okay. How bigger the image is as compared to the object, that is the magnification. Like we used to say, sir, image is magnified means image is bigger than the object. Image is diminished, we say image is smaller than the object. That is magnified and diminished. So that's how we define magnification. Now, if somebody asks you, how do we exactly find the magnification, value of magnification? Magnification, M, it is height of the image divided by height of the object. If you have the object, if you have the image, whatever is the height of image divided by height of object is the magnification. Sir, is there any other formula for the magnification? We say yes. Magnification is also equal to minus V divided by U. This is the magnification in terms of position of the object divided by position of the image divided by position of the object. Next, in terms of F and U, focal length and position of the object, we say F upon F minus U. This is also magnification. Okay. We have this also, M is equal to F minus V divided by, we say, F. This is in terms of focus and we say position of the object. Okay. Now guys, listen to me very carefully. Let's suppose we are given a question over here. In the question, they have asked find the position of the image, height of the image and magnification. Guys, the very first thing that I want you guys to understand is, we say This is the object which is placed over here. And clearly I can see this is the direction of the incident rays. So this will be the positive side, okay? And this will be the negative side. This is the positive side and this is the negative side, okay? Now tell me guys, we say position of the image, that will be minus 15 centimeters. Focal length of this is from this side, negative side. Radius of curvature is 20. What will be the focal length? Focal length is always r by 2. So how much is r? That is 20 by 2. So it will be 10 and it is minus 10 centimeters. Focal length in this case will be minus 10 centimeters. Okay, because it is r by 2. It is minus 10 centimeters. Okay. Yes. Now, my dear friends, I would want you guys to tell me in this particular case one thing. See, when it comes to the position of the image, we say as position of the image will be u into f upon u minus f. U into f upon u minus f. So I would say v is equal to, what is the value of u? U in this case is minus 15. What is the value of f? F is the focal length over here. Focal length is minus 10, okay, divided by u minus f. What is the value of u? That is minus 15 minus 10. That will be plus 10 over here. Okay. Now guys, v in this particular case will come out to be, tell me, this is 150 over here. 150 divided by this 5 over here in this particular case. So can I say this will be 15 and 10 is 150 and minus into minus is plus. And minus 15 and this will be over here. Simply that is minus 5. Minus 15 plus 10 is minus 5. 5 ones are, 5 threes are, 5 zeros are. So V comes out to be minus 30 centimeter over here. This is the position of the image. This is the position of the image. Okay. So this is the negative side. This is positive side. So image will be from this side only. That is minus 30. This is, guys, this is minus 15. So image will be beyond this. Image will be beyond this. Somewhere around over here. Minus 50, minus 30. Now guys, one more thing I just want to find. Magnification. We say as. When it comes to the magnification, I would use this formula. What is the formula of magnification? F upon F minus U. Okay, whatever the formula you want to use, you can. F upon F minus U in this particular case. Now tell me guys, what is the value of F? Focal length is minus 10 upon F minus U. F is minus 10. Then we say minus, and this is plus 15. Plus we say, sir, 15 over here. Okay. Because U is minus 15, minus into minus is plus. Now tell me guys, in this particular case, magnification will come out to be minus 2. Because plus, this will be minus 5, this will be plus 5. 10 by 5 is 2. That will be minus 2 because its sign is negative. Magnification is this. Now guys, one more formula we recently studied. Magnification is height of image divided by height of object. So can I say also magnification is height of image divided by height of object. So I can say this height of image will be magnification into height of object. Now tell me, magnification came out to be minus 2. And what is the height of object? That is 1 mm. So this will be 1 mm over here. So this will be minus 2 mm. So this is the magnification that we got exactly over here. Okay. This is the height of the image that we got exactly over here. All the three things we calculated. Okay. Yes. Is this crystalline clear? Is this crystalline clear? Is this crystalline clear, guys? Huh? Guys, see, one more thing I just want to mention over here. What is that? See, We say if magnification is negative, always remember, if magnification is negative, we say if magnification is negative, then image is inverted. Okay, what is inverted? Inverted means upside down. Inverted means upside down. Okay, now my dear friends, if magnification is negative, we say image is upside down. We say if magnification is positive, then image is erect. Then in that particular case, image will be erect. It is not upside down. Okay. Also, I would want you guys to remember this also. What is that? What is that? See, we say if magnitude of magnification is greater than 1, then image is magnified / enlarged. If magnification came out to be greater than 1, mod of m, like in this particular case, guys, here magnification came out to be negative. What does that mean? The image which is formed will be inverted upside down. And if you check mod of m is greater than 1, because it is 2 over here. Magnitude of this will be +2. Then in that case, we say image will be magnified. Image will be magnified. Image will be magnified. If magnitude of 1 is greater, then image will be magnified. And we say if mod of m is less than 1, then in that case, always remember, image is diminished. Okay, image is diminished. Keep that thing in your mind. Keep that thing in your mind. Okay. Okay. Great. Guys, duration will go around, it will go till 2 a.m. It will go till 2 a.m. Huh? That will be the duration. Because I'll have to teach everything. If you want me to skip something, that's okay for me also. Huh? I'll skip some topics. We'll sleep. We'll have a good sleep. Then we'll see in the NEET examination. Huh? That'll be okay. Huh? Now, take a look. An object is placed at a distance of 40 centimeter in front of the concave mirror of focal length this. You have got a concave mirror over here. And it says that focal length of the concave mirror is given as, it is 20. So I'll write -20 over here. Why? Because it says object is placed in front of the concave mirror. So this will be the direction of incident rays. So this will be the positive side and this will be the negative side. So focal length in this case is -20. Okay. And object distance U is given as -40 centimeter. You guys are supposed to find this is very simple. You guys are supposed to find what? The position of the image. Simply V is equal to U into F upon U minus F. Okay. Just put up the values and get the value of V. It is simple. It is simple. Now guys, let's talk about longitudinal magnification. Sir, previous one was, this is what we call the transverse magnification. This magnification is also called the transverse magnification. We say also called transverse magnification. Now let's talk about longitudinal magnification. Guys, see. When it comes to the longitudinal magnification, we say object is placed parallelly on the principal axis. Previously, if this was the mirror, guys, if this is the mirror, let's suppose if this is the mirror, this is the principal axis, you were placing the object something like this, perpendicularly. Right now, this is the mirror. Okay, you are placing the object something like this, parallelly on the principal axis, Okay, so in this particular case, I would want you guys to understand this one. This is the object. We say, sir, AB is the object over here. Now, my dear friends, in this particular case, I would want you to understand. We say, if you place an object something like this, we say from this end till over here, guys, distance of this point, because object is this long. What is the distance of this point? One end of the object till this mirror, it is called UA. And distance from another end, it is basically UB. And what is the size of the object, sir? That will be UA minus UB, that will be this size. So if you place the object something like this parallel to principal axis, here we find the longitudinal magnification. Previously, if you place it something like this, we find the transverse magnification. In this case, we find longitudinal. Now, guys, if you place the object something like this, and let's suppose its image will be formed, I'll create the image over here. Let's suppose its image is formed over here. We say this image is A dash, B dash. This object is AB. Now, distance of one end of the image from the mirror, it is VA. Distance of another end of the mirror, it is VB. What is the size? That is, sir, VB minus VA, this. Okay. Now, in this case, we will have to check how much image has magnified longitudinally. Sir, how much this has become bigger longitudinally? How do we find the longitudinal magnification? This is the longitudinal magnification. VB minus VA divided by UB minus UA. VB minus VA divided by UB minus UA. This is B, this is A. Okay. Let's call this as A. Let's call this as B. Okay. So this will be over here VB minus VA, and this will be UB minus UA. What is this? This is the size. The size of this object longitudinally. Okay. This image divided by size of this object longitudinally. This is how we find the longitudinal magnification. Now, guys. This is when the size of the object is finite. What does that mean? That means here this object is having a good size, finite size. Now, my dear friends, in this particular case, if I say, if the size of the object is very small, guys, if this object over here is extremely small, can I say its size will be du? Yes. We say, guys, its image will be formed over here. Its size will be what? dv. Here you can consider this as delta v, size is bigger, finite. Here its size is bigger, finite. Delta v, dv, delta v and delta u. In this particular case, when the object is very small and is placed longitudinally, we say this will be dv, this will be over here, this will be du, and this will be dv. Now, in this case, magnification longitudinal will be, guys, same like the previous one. Size of the image divided by size of the object. Size of the image divided by size of object. But here it will be dv, it will be du. Small size. And one more thing also, relation between, we say longitudinal magnification and transverse magnification. So that is magnification longitudinal is equal to minus m square transversal. So transverse magnification square and put the negative over here will be equal to magnification longitudinal. So basically, my dear friends, in this particular case, this is the relation. But if you know the transverse magnification, you can find the longitudinal magnification. Now, guys, let's take a look at this question. An object of 0.1 mm, I would want you guys to give me the answer in the chats. At 15 centimeter from the concave mirror, focus is 10 centimeter. Find the longitudinal magnification. Guys, see, it is saying that an object of 0.1 mm, height of the object is given as 0.1 mm. Okay. At 15 centimeter from the concave mirror. Guys, in case of concave mirror, it is at 15 centimeters. So can I say this will be minus 15? Because when it comes to the concave mirror, we take it negative 15. Focus is at 10 centimeters. So focus of the concave mirror also take we as minus 10 centimeters. Okay. Find the longitudinal magnification. Guys, see. We say as. When it comes to the longitudinal magnification, it is minus m square transversal. Here. Focus is given. Focal length is given. We say position of the object is given. You can find the transverse magnification. With that, you can find the longitudinal magnification. Now, I can say magnification longitudinal will be minus. How to find transverse magnification? Guys, if you remember the formula of transverse magnification, sir, that is f upon f minus u. F upon f minus u. So I can say this will be f upon f minus u and it is whole square. This is the formula of transverse magnification. You see, f upon f minus u. Okay. Now, guys, tell me one thing. This longitudinal magnification will be minus. What is the value of f in this particular case? F is minus 10 divided by, what is the value of f? That is minus 10. Okay. Then minus u. That is minus into minus is plus 15. This is plus 15. Okay. Guys, tell me one thing. This is minus 10 plus 5. So that will be minus 2 and it is whole square. So magnification longitudinal will be minus, it will be 2 whole square, minus 2 whole square. So minus 2 whole square is 4. So magnification longitudinal will be minus 4. Longitudinal magnification is minus 4. Even my dear friends, you can find in this particular case, size of the object or size of the image also. We say as this magnification longitudinal, it is dv divided by du. Recently you saw this formula. Guys, can I say this dv will be equal to magnification longitudinal multiplied by, we say, du? Yes. So how much is this? Minus 4. So dv is equal to, this is minus 4 into, this is 0.1 mm. So how much will be that? That is 0.4 mm. Okay. Is this clear? Please tell me in the chats, everyone. Is this crystalline clear, guys? Okay. So this is what? This is the size of the image. dv is the size of image. So mention it over here. Where? Okay, it is mentioned. Let the object, size of the object be du, size of the image is dv. Okay. Let's move on to this one. Let's move on to this one. See guys, velocity of image, velocity of image. Guys, see, we say when object and mirror are moving along the principal axis. When object and mirror are moving along the principal axis, I would want you guys to focus exactly over here. See guys, let's suppose you have got the mirror in this particular case. If you remember the previous case, guys, tell me one thing. Let's suppose you have got this mirror over here. Previously, I said, in case of the plane mirror, if you have the plane mirror, this was the object which was moving with some velocity. This was the mirror. We said velocity of the mirror is something. And here image was formed. Sir, this image had some velocity. We calculated all the cases, velocity of the image, if object is moving perpendicularly, parallelly, everything we discussed. So that was in the case of plane mirrors. But right now, you don't have the plane mirror, but you have the spherical mirror over here. You have the spherical mirror. We say when object and mirror are moving along the principal axis, this object is moving something like this along principal axis, and mirror is also moving along principal axis. Okay. Sir, we know this spherical mirror will form the image of the object. Yes. If object is moving, image will be also moving. Okay. So my dear friends, in this particular case, if somebody asks you to find the velocity of the image, we say here, velocity of the image with respect to the mirror will be, that is minus m square. We say velocity of object with respect to mirror. So this is the velocity of the object with respect to the mirror in this particular case. Guys, if I say this is the mirror over here, in front of the mirror you place the object, we know its image will be formed. Yes, sir. If object is moving, image will be moving. If this has velocity, image will have velocity. So what is the velocity of the image? So that is velocity of image with respect to the mirror. That is minus m square. M is the magnification. Velocity of object with respect to the mirror. Velocity of object with respect to the mirror. Okay. Now guys, tell me one thing. We say in 99% cases, mirror would be at rest. I have discussed this previously. Mirror would be at rest. Next. Guys, if mirror is at rest, what is the velocity of the mirror? That is 0. Now, could you please tell me how can we write this equation? Velocity of image with respect to mirror. Sir, this will be velocity of image minus velocity of mirror is equal to minus m square velocity of object minus velocity of mirror. This is how we write it. Velocity of image minus velocity of mirror minus velocity of object minus velocity of mirror. Now, if this is 0, so vi minus 0 will be vi minus m square. This will be 0. So this will be the velocity of the image. Guys. So we say this is the velocity of image with respect to ground. Okay. Because right now mirror is at rest. And in this case, this is the velocity of the image with respect to the mirror. This is the velocity of the image with respect to mirror. And if you consider velocity of the mirror as 0, in that case, this comes out to be something like this. So we say this is the velocity of the image with respect to ground, where m is the magnification. Please give me the signal in the chats. And one more thing. Can I write, recently we studied magnification is V by U. Okay. magnification is V by U. Magnification is V divided by U, or dV by du. Okay, so you can say V by U, and it is magnification square over here. Is magnification square over here. So you can put V square by U square. Okay. 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 So we say this is basically the velocity of image. Negative sign indicates that with respect to the mirror, the object, if object is, let's suppose, moving in this direction, we say image will be moving opposite to that. That's why you have got the negative sign in this case. Okay, velocity of image is opposite to the velocity of the object. That's why you have got the negative sign. Okay. Okay. And velocity of the image is greater than the velocity of the object. Why? Because let's suppose velocity of the object is something 10 and something is multiplied to this. So we say it will be greater. Guys, please tell me in the chats, is this clear? You have the mirror. In front of the mirror, you have object. Object is moving with some certain velocity. Its image will be moving. This is the velocity of the image with respect to mirror. This is the velocity of the image with respect to ground if this is 0. Okay. And then you have got this exactly over here. Tell me the answer of this particular question. Okay. Guys. Okay. Tell me the answer of this question. What is the answer to this question? Magnification trans longitudinal, we say it is negative because when you differentiate, see, when you have the magnification longitudinal and from that, if you derive this equation, you will have to differentiate at some point. Like 1 by V plus 1 by U, if you take that V in the numerator, so the negative sign comes over there in differentiation. That's why we get the negative sign in the formula. The velocity of the image with respect to the ground in the figure is, guys, see. How to find the velocity of the image with respect to the ground? This is the velocity. This is the velocity. Velocity of image with respect to ground is Vi is equal to minus m square into V naught. Guys, tell me one thing. We say as velocity of image with respect to the ground is minus m square into velocity of the object. This is the velocity of the image. This is the velocity of the object. Okay. Now, guys, in this particular case, this is the object over here. This is the object over here. Object has the velocity of 5 meters per second. Okay. And here, this is the distance of the object from the mirror. So when object was at this point, its velocity is 5 meters per second. So we say this is U. And this will be the direction of incident rays. This we consider as positive. This side we consider as negative. Because the direction of incident rays is considered to be positive, direction opposite will be negative. So can I say in this particular case, focus will be from this side, U is from this side. So we say U is equal to minus 20 and focus is equal to, we say, minus 30. Okay. Okay. Tell me, guys, what is the answer? You have to first find the magnification in this particular case. Then you have to multiply directly over here. Okay. Tell me. Guys, when it comes to the magnification in this particular case, how do you find the magnification? F and U are given. F upon F minus U. What is the value of F? That is minus 30 over here, divided by F minus U. F is given as minus 30 plus we say 20 over here. Minus into minus is plus. So that will be 10. So this is minus 30 divided by minus 10. This and this goes. So magnification in this particular case will come out to be 3. Okay? Plus 3. If magnification comes out to be 3, so velocity of the image in this particular case will be simply, that is minus m square. So we say this will be 3 square. Velocity of the object, that is 5. So 3 square is 9. 9 into 5 is 45. So minus 45 meter per second. Velocity of the image is minus 45 meter per second. See, velocity of object is this. Velocity of image is greater than the velocity of the object. Tell me the answer of this question. A point object is moving on the principal axis of a concave mirror of focal length 24 centimeter. Okay. In this case, you guys are supposed to find out velocity of the image. Tell me, guys. Velocity of the image. Guys, a point object is moving on the principal axis of a concave mirror of focal length, we say 24 centimeter. This is a concave mirror. Okay. This is the principal axis. This is the principal axis. Yes. An object is moving with a velocity of the object is given as 9 centimeter per second. 9 centimeter per second. Okay. Okay. And focal length of this is given as, guys, we know this side will be positive. This side will be negative. So focal length in this case is given as 24 centimeter. So it will be minus 24 centimeter. Minus 24 centimeter. Okay. And when it comes to the distance of the object, U is given as minus 60 centimeters. Because when it is at distance 60 centimeters from the mirror, when object is at 60 centimeters from the mirror. Now guys, when it comes to the velocity of the image, we recently saw it is minus m square into velocity of object. So velocity of the, let's find the magnification first. Magnification will be F upon F minus U. So magnification will be, what is the value of F? That is minus 24 upon, what is the value of F? Minus 24, we say plus 60. Plus 60. Okay. So this comes out to be minus 2 by 3. Now guys, velocity of the image will be, that is minus 2 by 3 whole square, magnification square, that is minus 2 by 3 whole square, into velocity of the object, that is 9 centimeter per second. So velocity of the image will be minus into minus is plus, 2 square is 4 by 9, 4 by 9 into 9, and this minus this and this will cancel. Velocity of the image is minus 4 centimeter per second in this particular case. Okay. Now guys, we say over here, I would want you guys to listen. See, in this particular case, it is 4 centimeter per second and it is negative. Which option? This option or this option? Guys. This velocity towards the mirror, you take positive. Okay. And when it comes to minus, so it will be away from the mirror. Positive is towards the mirror, negative is away from the mirror. As simple as that. As simple as that. Okay. Okay, this is a good question. A car is fitted with a convex side view mirror of focal length 20 centimeter. This is a car. Let's suppose this is a car over here. It has a convex side view mirror. This is car. It has a convex side view mirror of focal length 20 centimeter. Let's suppose there is a big car over here. It has a mirror, side view mirror of focal length 20 centimeter. Okay. And let's suppose this is the car A. Car A. Car A has this mirror. A second car 2.8 meter behind. There is another car 2.8 meter behind. This is car B. Car B. And how much is this behind? This is 2.8 meter behind. Means 280 centimeters. 2.8 meter means 2.80 centimeters. Behind, the first car is overtaking the first car at a relative speed of 15 meter per second. Guys, it says that, guys, listen. This is the, this is first car. First car has the side mirror. If I see in the side mirror, there is a car behind. So now for this mirror, that car is an object. Behind the car which is behind is an object. And this is a convex mirror. This is a convex mirror of car A. This will behave like an object for this mirror. Yes. And this is at what distance? U is equal to 280 centimeters. And it says velocity of, relative velocity speed of this car with respect to this car means velocity of object with respect to the mirror. It is given as 15 meter per second. I hope you are getting me. Like I am driving a car, it has got a convex side view mirror. I'm looking into the side view mirror, there is a car behind. Now that car for this mirror will behave like an object. Yes, sir. How far is that? That is 280 centimeters behind. So this car, when you are seeing the velocity of the car, its velocity is 15 meter per second. Velocity of car B with respect to car A. That's what it is saying. Behind, the first car is overtaking the first car is overtaking the first car at a relative speed of 15 meter per second. Okay. Okay. This car its meaning is, it is not the correct English mentioned over here. The velocity of this car with respect to this is 15 meter per second. The speed of the image of the second car as seen in the mirror of the first one will be, you guys are supposed to tell me, guys, see. You guys are supposed to tell me, if this is the mirror, inside, behind this mirror, you have got the object, that is second car behind. So that is the object for this mirror. This mirror will create its image. This mirror will create its image. That image will have the velocity. We have to find the velocity of the image in this case. To find the velocity of image. Okay? To find the velocity of the image in this particular case. The speed of the image of the second car, okay, of the second car as seen from the first car with respect to the mirror. As seen from the first car. This is the meaning of the question. Okay? Guys, once again, the same thing I need to use over here. Guys, velocity of the image with respect to mirror is minus m square. Velocity of the image, velocity of the object with respect to the mirror. Direct formula. This main formula. This one. Velocity of the image with respect to the mirror is equal to minus m square velocity of object with respect to the mirror. Okay. Simple, simple, simple. Just you have to find the magnification first, then multiply it with the velocity of the image, and you will get the answer in that particular case. Okay, just simple. Tell me, what is the answer over here? Okay, guys, tell me. See, focal length is given, u is given. We say focal length is minus 20. No, it is plus 20. This is the object. So this will be the positive side. This will be the negative side. In this particular case, focal length will be plus 20. U will be minus 280. Now tell me, guys, how to find the magnification f upon f minus u. Magnification is, what is the value of f? 20 upon, we say 20 minus u. Minus into minus is plus 280. That will be 20 by 300. This and this will 115. So that will be 1 by 15. Magnification came out to be 1 by 15. Now velocity of the image with respect to the mirror, velocity of the image with respect to the mirror is equal to minus 1 by 15 whole square multiplied by this 15, because velocity of the object with respect to the mirror, it is 15. It is 15. Okay. 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 So what is the minus 1 by? Is this clear? Is this clear? Great. Now, guys, let's move on to the power of the mirror. This is a small concept, simple concept. See, guys, when it comes to the power of the mirror, we say power of the mirror is defined as, I hope this is visible. I hope this is visible. Power of the mirror. Yes. Power of the mirror is defined as the ability to converge or diverge the light rays. Like you have studied previously, I have told you, if this is the convex mirror, let's suppose, okay, we say this is the light ray which is falling something like this, it will be diverged something like this. And I'm saying this is the concave mirror. Let's suppose this is the light ray, it will be converged. Okay. How much ability the mirror has to diverge, how much ability the mirror has to converge the light rays, that is called the power of the mirror. The ability of a mirror to converge or diverge the light rays, that is called the power of the mirror. Okay. Now, my dear friends, when it comes to the power of the mirror, how can we find it? It is 1 minus 1 upon focal length in meters. Let's suppose if I say you have got a convex mirror, concave mirror over here, its focal length is 20. How much will be its power? Sir, how to find power? Minus 1 upon f, if f is in meters. If focal length is in centimeters, then we write 100 upon focal length in centimeters. Okay, just we have an example over here. We have an example over here. Guys, see, it says that find the power of a concave mirror of focal length 20 centimeter. This is a concave mirror. Okay, this is a concave mirror. And guys, we know if we place the object from this side where reflection takes place, this is the positive side, this is the negative side. And here focus will be from negative side. So focal length of this will be -20. Let's find out its power. We say power in this particular case will be, this is -20 centimeter, will be -100 upon focal length in centimeters. Power will be simply -100 upon focal length over here is -20. This and this will cancel, minus and minus, 2 5s are. Power will be 5 diopter. We measure the power in diopter, so 5 diopter, 5D. Similarly, if they ask us, find the power of a convex mirror of focal length 25 centimeter. Let's suppose this is the convex mirror. This is the convex mirror. Okay. And we place the object over here because reflection takes place from this side. So this will be the positive side. This will be the negative side. Now its focus will be from the positive side. And here focal length is +25. And if we find the power over here, that is -100 upon F. Power is -100 divided by 25. So that is -4 diopter. The power is -4 diopter. Next we have Newton's formula for mirrors. Newton's formula for mirrors. Guys, see. When it comes to the Newton's formula for mirrors, what is this formula? Simply. It is xi into xo is equal to f square. Xi multiplied by xo into f square. What is xi? Xi is the distance of image from the focus. Guys. Previously, when it comes to the mirror formula, what do you say? Mirror formula is 1 by v plus 1 by u is equal to 1 by f. Sir, what is this? Let's suppose you have got this mirror over here, convex mirror. Okay. You are placing the object over here. This is the object. Then you used to say, sir, this object is at what distance? U distance from the mirror, from the pole. You were calculating the distance from the pole in this particular case. Okay. But when it comes to the Newton's formula for the mirrors, Newton's mirror formula, what does it say? If you have a mirror over here, let's suppose you have a concave mirror. Okay. And my dear friends, this is the focus, let's suppose. This is the pole, let's suppose. And I am placing the object over here. Okay. What is the distance of the object from the focus? That is what we call XO. That is what we call XO. Distance of the object from the focus. Here we measure the distance from the object, from the focus. And what is xi? Let's suppose image is formed over here. This is the image. Sir, what is the distance of this image from the focus? That is xi. In this case, we measure the distance of the image and object from the focus, not from the pole. So that's what it is saying. Xi into xo is equal to f square, where f is the focal length of the mirror. It is also the relation between distance of the image and object from the focus. From the focus. Like the question is, an object is placed at 10 centimeters from the concave mirror, from the focus of concave mirror. This is a concave mirror. Okay. It says that, let's suppose this is the focus, this is the pole. Okay. Object is placed over here. Object is placed over here. This is the object. It says that xi in this particular case is given as 10 centimeters. Okay. of a concave mirror. And image is at distance 40 centimeters from the focus. So x, okay, this is xo, and xi is 40 centimeters. Find the focal length. We are supposed to find the focal length in this particular case. Can you find the focal length in this particular case? Tell me. Guys, we say use xi into xo is equal to f square. Directly use the Newton's formula. What is xi? That is 10. What is xo? That is 40 is equal to f square. So this will be 400 is equal to f square. Take this over there. F will come out to be root of 400. So focal length will come out to be 20 centimeter. So 20 centimeter is the focal length. Now we have successfully completed the reflection portion. Okay, reflection portion is a bit bigger. Now we have to finish the refraction portion. It will not take us much time. Refraction doesn't take much longer. Okay. Now see guys. First we need to understand over here properties of light. See guys. Sir, when it comes to the properties of light, first thing, speed of light in any medium. Sir, what is the speed of light in vacuum or air? We say 3 into 10 raised power 8 meter per second. Okay, this is the speed of light in air and vacuum. Sir, if you have to find the speed of light in any medium, you'll say speed of light in any medium. Medium can be water, glass, something else, okay? It will be simply V is equal to C divided by mu. This is how you can find the speed of light in any medium. Where C is the speed of light in vacuum, this C is speed of light in vacuum, 3 in 10 raised power 8. Mu is the refractive index of that medium. Mu is the refractive index of that medium. Sir, what is this refractive index? Guys, see. Refractive index gives us an idea about how optically denser the medium is. More is optically denser, optical density, slower will be the light in that medium. What I'm trying to say is that, let's suppose if I say this is a medium over here, okay, this is another medium over here. These are the two mediums. Guys, understand very carefully. We say this is medium M1, okay, this is medium M2, this is M1, this is M2. I'm saying light is entering from here to here, medium 1. What is, let's suppose mu of this is large, this is optically denser, okay, and mu of this is less. My dear friends, clearly you can see in this particular case, speed of light is inversely proportional to mu. If the medium is optically denser, it will be difficult for the light to move in that medium. Speed of light in that medium will be less. Why? Because if mu is large, speed of light will be less. So if this is a denser medium, speed will be less. If this is a rarer medium, speed will be more. So basically, refractive index gives you an idea how much is the speed of light in that medium. If it is optically denser medium, speed will be less. Rarer medium, lighter medium, speed will be less. Speed will be more. Speed will be more. Okay. Next point. Value of refractive index. Guys. We say for vacuum or air, We say mu vacuum, mu air is 1. From now onwards, you'll be remembering that value of refractive index for air is 1. And for any other medium, we say it is greater or equal to 1. Okay. Now, guys, there is one more formula, that is V is equal to F into lambda. F is the frequency, lambda is the wavelength. This is also applicable for the light. This is also the speed of light. By this formula also you can find the speed of light. Like in this case, you can find the speed of light and by using this formula. This formula also can be used to find the speed of light, where V is the speed of light, F is the frequency, lambda is the wavelength. Lambda is the wavelength. Okay. Now, guys, tell me one thing. Tell me one thing. See. You say V is equal to C divided by lambda. Sorry. V is equal to C divided by mu. Then you said V is equal to F into lambda. From this, if this is equal to this is equal, from this and this, so we can say C divided by mu is equal to F into lambda. Guys, tell me one thing. See. Here, speed of light is constant. This frequency, I have told you in modern physics, if you have a particular source, one source, given source. In case of one source, we say frequency is also constant. We say CF is constant for a given source. Speed of light in air is constant. Frequency for a given source is constant. So can I not say lambda is inversely proportional to mu? Yes. Lambda is inversely proportional to mu. So wavelength is inversely proportional to mu. So if refractive index of a medium is large, so wavelength will be less in that particular case. Guys, we say speed of light is inversely proportional to mu. Okay? And lambda is also inversely proportional to mu. So can we say V is directly proportional to lambda and V is inversely proportional to mu, Remember this point. Okay? Remember this point. This is what we have discussed. Okay, done. This point is also done. Okay. Now, guys, listen to me very carefully. See, let's suppose you have got a light. This is the incident light. Now, this is a surface. This is a reflecting surface. From the upper side, you have got medium 1. From the lower side, you have got medium 2. Cool? Yes, sir. Guys, tell me one thing. If you have this medium, we say it will have refractive index mu1. If you have this medium, it will have refractive index mu2. This will have, for different mediums, refractive index is different. So this will have one refractive index, this will have another refractive index. Guys, recently I told you, V is directly proportional to lambda, is inversely proportional to mu. If refractive index increases, speed will decrease. Okay. Now, my dear friends, or if refractive index changes, we say speed will change and wavelength will change. Guys, tell me one thing. If this is the incident light, this is the incident ray. We say it falls onto the surface. Okay. If it goes in the same medium, if it is reflected in the same medium, we say the phenomena is called the reflection, already discussed. Let's suppose the speed of the light was here in this upper medium, it was V. Wavelength is lambda. Frequency is F. Now tell me, guys, if it is reflected in the same medium, what do you think about the velocity? Sir, if the medium is same, mu is same, we say V will be same, velocity is same. If refractive index is same, lambda will be same. Okay, no change. Sir, frequency is already constant. All these things will remain the same. But sir, if light goes from one medium to another medium, Okay, let's suppose light is entering this medium. What will happen to velocity? Here velocity is v, here velocity will be v2. Why? Because medium changed. If refractive index changed, we say velocity will be changed. Velocity will change. Sir, lambda is also proportional to what? We say mu, inversely proportional. So lambda will also change, but frequency remains constant. So always remember, my dear friends, frequency depends upon the source. This I have told you in the modern physics. If you have a light source, if you have a given source, like this is a light source over here. From the light source, light ray is coming. So now if this light ray goes in this medium, it goes in water, it goes in air, it goes in some other medium, its frequency will always remain the same. Frequency does not depend upon the distance from the source or the medium. I have discussed over there. Frequency always remains. Once the light leaves the source, its frequency is constant. Now, we say, sure, in case of the reflection, my dear friends, we say these things remain same, velocity and wavelength will change. Now see, when light is reflected in the same medium, it suffers no change in frequency. There is no change in frequency. Speed, no change in speed, velocity remains same. Wavelength, no change in wavelength, wavelength remains same. But if light is refracted in another medium, let me write it. So, if light, just a second, guys. See, if light is refracted, if light is refracted in another medium, its velocity and speed changes. Its velocity and speed changes, but its velocity and speed changes, but frequency remains the same. Frequency remains the same. Now comes the law of refraction. Now comes the law of refraction. Okay. Now we need to discuss the law of refraction. What is the law of refraction, my dear friends, in this particular case? See, what is refraction? Refraction simply means if a light goes from one medium to another medium, it is called the refraction. We say, if light goes from one medium to another medium, it is called refraction. Okay. Okay. Now, my dear friends, let's suppose this is the surface over here. This is the medium one from the upper side. This is medium one from the lower side. So this is the light which falls onto the surface. This is the normal. So we say it is, this is, let's suppose this is the rarer medium. This is the rarer medium. Rarer medium. Okay. This is the rarer medium and this is the denser medium. So denser means which is optically denser, in which speed of light is less. That is what we call the denser medium. Now guys, in this particular case, we say light is falling. Okay. So it is going from rarer medium to denser medium, from rarer to denser. Okay. Yes. This is the normal. So this is the refraction of light. This is the bending of light. So one more point you also remember over here. When light enters from rarer to denser, when light enters from rarer to denser, when light enters from rarer to denser, it is bent. It is bent towards the normal. It is bent towards the normal. It is bent towards the normal. Okay. It is bent towards the normal. Okay. Now guys, see, this is the rarer medium, denser medium. It is bent towards the normal. Guys, this is called the angle of incidence. This is called the angle of reflection. In case of reflection, angle of reflection was this. Okay. So angle of incidence is equal to angle of refraction. Okay. Now guys, incident ray, refracted ray and normal all lie in the same plane. Incident ray, refracted ray and normal all lie in the same plane. First law. Guys, see. If this is angle of incidence, this is angle of refraction. This was the original path of angle of incident ray. Okay. Guys, listen to me very carefully. This is R. If this is I, how much will be this? How much will be this? This will be also I. This is I. This is also I. This is R. How much will be this angle? This will be I minus R. This is the deviation. Deviation in this case will be I minus R. Guys, this is I. This whole angle would be I. Whole angle minus this angle R. This will be I minus R. Okay. Sir, what is the second law over here? Second law of refraction is Snell's law. Here we don't say angle I is equal to angle R. No. In this particular case, we say directly remember this is the Snell's law. What does Snell's law say? Mu I into sine I is equal to mu R into sine R. I will tell you what is this. I will tell you what is this. We say this mu I is the refractive index. A refractive index of that medium. This mu I is the refractive index of that medium where incident rays are present. Okay. First point. Second point I'll just mention over here. Mu R is the refractive index of that medium where refracted rays are present. Okay, like in this case, this is the incident ray. This is the incident ray. So I call this mu1 as mu I. Mu I is the refractive index of that medium in which incident rays are present. And we call this as mu R. Mu R is the refractive index of that medium in which refracted rays are present. So this will be. Now what does Snell's law say? Mu I into sine I will be equal to mu r into sine r. Mu I is the refractive index of this medium into sine of this angle I will be equal to mu r into sine of r. Okay. Now, one more thing I just want to tell you. We say, as guys, we recently studied V is equal to C divided by mu. Can I say mu is equal to C divided by V? Yes. So can I say from this equation, instead of mu I can write speed of light into velocity of light in that medium. So I can write C divided by V1. Let's suppose velocity of light in this medium is V1. Here it is, wavelength is lambda 1. And in this medium it is V2, lambda 2. So can I say this is C by V1? Then I'll write sine of I is equal to, instead of mu r, I can write C divided by V2 and then I'll write sine of r. This C and C will cancel. So I can write over here this Snell's law, sine I divided by V1. This is the sine of angle of incidence divided by velocity of light in that medium 1. Okay. Will be equal to sine of r divided by, we say, V2. Guys, one more formula we studied also. V is equal to F lambda. F is constant. V is directly proportional to lambda. So you can put this in a box. Now, this is the Snell's law in terms of speed of light. This is the Snell's law in terms of speed of light. Now guys, V is directly proportional to lambda. Instead of this V, I can write lambda 1 over here. So I can say also V is directly proportional to lambda. So I'll write sine of I divided by lambda 1. Lambda 1 is the wavelength of the light in this medium. That is lambda 1. Okay. Will be equals to sine of r divided by lambda 2. Lambda 2 is the wavelength of the light in the medium 2, in the denser medium. I hope this is crystalline clear. This is also the Snell's law. This is also the Snell's law, and this is also the Snell's law. This is in terms of refractive index, in terms of speed of light, in terms of wavelength, Okay. Yes. Okay. Cool. Okay. Now guys, let's discuss this first. Then afterwards, we'll move on to the questions. We'll have to solve the questions on the Snell's law. I'll show you that. First, we'll discuss this. Let's first discuss this. Now guys, take a look. Apparent depth and apparent height. Guys, see. Let's suppose this is over here a big tub of water. This is a big tub of water. Okay. And you are, this is you. Okay, observer. And inside this tub of water, what you have placed is an object or a stone, or this is a swimming pool. How many of you have understood this? How many of you have experienced this? Not understood, experienced this. There is a, guys. We say there is a stone inside the water. If you are looking at that stone from the top, it feels like if the stone is over here, it feels like the stone is placed over here. It feels like the stone is not at this much depth, Let's suppose it is, if it is, let's suppose 2 meters. It doesn't feel like the stone is at 2 meters. It will feel like stone is just at 0.5 meters. How many of you have experienced this? And when you put inside the bucket, inside the tub, when you put your hand inside the bucket, inside the tub, you feel like no, stone is actually at this depth. Stone is actually at this depth. But when you are looking from the top, it feels like it is at this apparent depth. It is not at the actual depth. It is at apparent depth. Have you ever experienced this? Yes. Now, why does that happen actually? See. And that is what we call the apparent depth and apparent height. This is the observer. So, with respect to the observer, he feels that object is present at the apparent depth. So, I'll just mention over here. Observer feels. Observer feels object is present at the apparent depth. Okay, not the actual depth. And if somebody asks you, yes, bottom looks near. And if somebody asks you, how to find, why does it actually happen? See, guys, this is the object. We know light rays will, incident ray will leave from the object. This is the incident ray. And if this is water, so this will be denser medium. And this is rarer medium. This is denser medium, this is rarer medium. If light goes from rarer to denser, guys, if light goes from rarer to denser, it is bent towards the normal. This is the normal over here. If light goes from denser to rarer, it is bent away from the normal. Always remember. Now here, this is the incident light ray. This is the normal. When it goes from denser to rarer, it is bent away from the normal. This is the normal. Sorry, this is the light ray. It is bent away from the normal. Okay. Now, guys, this is the incident ray. This is the refracted ray. If you extend this refracted ray, it will meet at this point. The point where refracted rays meet or reflected rays meet, that is called the image. The point where reflected rays meet in case of reflection or refracted rays meet in case of refraction, that is called the image. So this observer was basically looking at the image of the object. Observer was not looking at the object. In reality, object is present at the depth D only, but its image is formed at this depth. So observer was looking at its image. So this is called the apparent depth. This is called the apparent depth. So we say this apparent depth D dash will be simply, that is D. D is the actual depth divided by mu I by mu R. Guys, what is mu I? Mu I is the refractive index of that medium where incident rays are present. Where is the incident rays present? This here. This is the incident ray. This is the refracted ray. Let me mention over here. This is the incident ray. And this is the refracted ray. So this will be mu I. This will be mu R. Okay. Okay. Now guys. In this particular case, see, this formula is valid for the virtual objects also. Let's see, what is the virtual object? See. This is a light ray coming something like this. This is a light ray coming something like this. Okay. We say this is rarer medium, this is denser medium. So when the light goes from rarer to denser, okay, in this particular case, okay, or simply don't say rarer, denser. This is rarer, okay, mu r, and this is mu I, refractive index of this medium, this one. Now guys, when this light ray goes from this medium to this medium, okay, we say it is bent. If this is the normal, it is bent towards the normal from rarer to denser. So my dear friends, this is the incident ray, this is the incident ray. After refraction, we say these two rays will meet over here. The point, guys, see. This is the incident ray. This is also the incident ray. This is refracted ray. So the point where refracted rays meet, image is formed. So image is formed at this point. Okay. Now guys, in this particular case, if you see, if you extend this incident ray, it will meet over here. If you extend this incident ray, it will meet over here. The point where incident rays appear to meet, that is called the virtual object. This will be virtual object. Because incident rays are not actually meeting. This is the real image. And in the previous case, this one is the virtual image. Okay, and this one was the real object. So for real object, this formula is valid, and for virtual object also this formula is valid. See guys, in this case, virtual object is at what depth? This depth is d. And image will be formed. This real image will be formed at depth d dash. Here also, if somebody asks you, find this d dash, so this d dash will be d upon mu I minus mu I by mu r. So this is valid for virtual objects also. This is valid for that also. Then the object is larger for virtual. What larger? Okay, guys, in this particular case, this is what we call this is the image. We actually have to find the distance of the image. That's why we take this d dash for this one. For object, the distance is d. Here also for object, the distance is d. And image is over here, d dash. But image is virtual. And here image is real. That is d dash. Okay. Now let's take a look. Okay. This is called the fish tank problem. Very famous problem. Fish tank problem. Find the apparent depth of fish with respect to the bird and apparent height of bird with respect to the fish. Guys, see. You have got a tank over here. Okay. And in this tank, you have the water filled. And refractive index of this is given as 4/3. This is the fish over here. And fish is at what depth? 24 centimeters. Okay. Guys, fish is at 24 centimeters depth. And this is the bird. Find the apparent depth of fish with respect to bird. Guys, we say apparent depth of fish. If you have to find the apparent depth of fish, means fish is the object and bird is observer. Okay. So we say bird is observer and fish is object. Guys, how do if the bird is looking at the fish from the upper side, so this bird would be able to see the fish at the apparent depth, not at the actual depth. At what depth? We say, sir, that depth d dash will be d upon mu I by mu r. Now guys, can I say this d dash simply will be d means actual depth of the fish. What is the actual depth of fish? That is 24 centimeter. Divided by mu I. Mu I is the refractive index of that medium where incident rays are present. Guys, if this is the object, refractive incident rays will leave from the object. So in this case, mu I is 4 by 3 divided by mu R is this air. Mu R is this air, that is 1. Okay, so for this, we say mu I is 4 by 3. We say mu R is 1. Okay, now how much is this in this particular case? So this will be 18 centimeters. Okay, so 4 by 3. So now this will be 24 divided by 4 into, we say 3. 4 ones are, 4 6s are, 6 3s are, we say 18 centimeters. That's what I was saying. This bird will see the fish at 18 centimeter depth, but in reality it is at 24 centimeters. Okay, next. We say apparent height of bird. Guys, now you have to find the apparent height of bird. Okay, apparent height of bird. In this particular case, when it comes to the apparent height of bird over here, you are no. Somebody is saying, sir, will it not be 36 plus this? You are finding the depth only, not this height. This is the height. Depth will be below the water. Depth will be from the top layer of the water and then you go down. You have to find this is the depth. This is the depth. Now see. Apparent height of bird. Guys, in this particular case, you are supposed to find the height of the bird. So when it comes to the bird, we say, sure, fish is the observer. Fish is observer. And we say bird in this particular case is object. Bird in this case is object. Now guys, what is the actual height of bird? That is 36. From here to here, from the top layer of the water till the bird, it is 36. Now what is the apparent height? According to this, what is the height? We say, sir, apparent height h dash is equal to h upon mu I by mu r. Same formula. And what is h over here? H is 36. Mu I. Refractive index of that medium where incident rays are present. If this is the object, so incident rays from the object. So right now it is 1. Mu I is 1. And mu R is this medium, refractive index of this medium, that is 4 by 3. So if you take in the numerator, it becomes h dash is equal to 36 into 4 by 3. 3 ones are, 3 12s are. 12 into 4 is h dash is equal to 48. H dash is equal to 48 centimeters. Is this clear, guys? Tell me in the chats. Guys, give me the signal in the chats. Is this clear? Now see, guys. Refraction through parallel slab. Guys, see. You might have heard about the glass slab. You might have seen the slab in your schools. Okay. You have got a slab over here. This is a glass slab. And its width is T. Okay. And its refractive index is mu m. Because this slab is made up of some material, glass or something like that. Its refractive index is mu m. Surrounding has the refractive index mu s. Okay. Now, my dear friends, Let's suppose this is the incident ray which falls exactly on the slab. This is the incident ray which falls on the slab. Okay. So this incident ray falls on the slab. Okay. My dear friends, this is, we say over here, rarer medium because this is air. This is denser medium. So this is rarer. This is denser. When light goes from rarer to denser, it is bent towards the normal. This will be the refracted ray. It is bent towards the normal. This is the angle of refraction. Angle of incidence, angle of refraction. Okay, then the light ray goes something like this. When it comes out of the slab once again, now it goes from denser to rarer because this is denser to rarer. When light goes from denser to rarer, it is bent away from the normal. It is bent away from the normal. Okay, guys, this is angle of incidence, this is angle of refraction. And if this is I, this is I also, total. This is the original path. Okay. Now. Guys, listen to me very carefully. Here, when this light ray falls onto this surface, then again it is bent. Another refraction takes place here. First refraction, second refraction. And this is the normal over here. This is the angle of incidence for the second surface. This is what we call the angle of refraction for this surface, for the second surface. Or you also call it the angle of emergence, angle of emergence. Okay. Angle of incidence, angle of refraction. Angle of incidence for second refraction. Angle of refraction for second refraction. I hope you got it. Now guys, what I'm trying to say is that this is the incident ray. It is bent something like this, then again bent. This was the original path of the incident ray. This is the final ray. This is the original ray. Final ray, original ray. We say this distance between these two is what we call the shift. How much the ray has shifted from the original path. Okay. How much the ray has shifted from the original path. Original path is called shift. Is called shift. How much the ray has shifted from its original path is called the shift. And if somebody asks you to find the shift, you'll say this shift is T divided by cos of R sine of I minus R. T is the width of the slab. R is the angle of refraction. Okay. Sine of I minus R. I is the angle of incidence. R is the angle of refraction. Simple words. This is the shift. This is the shift. How much the ray has shifted from its original path. Like you have the question over here. Find the lateral shift of ray of light while it passes through the parallel glass slab of thickness 10 centimeter. Thickness of the slab is given, T is given as 10 centimeter. The angle of incidence is 60 degrees. And angle of refraction, R, is given as 45 degrees. You are supposed to find the shift. Guys, when it comes to the shift, what is the formula that you saw? T upon cos of R minus T upon cos of R, then we say sine of I minus R. Sine of I minus R. Now say, what is this? This is 10 centimeter upon cos of 45, cos R 45. Then we say sine of 60 minus 45. Solve it and you'll get the answer. Okay. Okay. Now, in this particular case, no, angle of refraction and angle of incidence are not same. See. In this particular case, this angle and this angle is same. This angle and this angle is same. Refraction on the first surface, refraction on the second surface. Here angle of refraction, here angle of incidence, these two are same. But this angle of incidence and this angle of refraction cannot be the same. No. Because the light ray is bent. This is the angle of incidence, this is the angle of incidence. Now guys, look at this particular diagram. You have got the slab over here. Width of the slab is T. Okay. We say refractive index of this medium is mu m. Surface has the refractive index mu s. Surface has refractive index mu s. What I want you guys to do is, let's suppose you have an object over here. Let's suppose you have an object over here. Guys, understand very carefully. And you have the observer over here. Observer is looking at this object. Guys, understand this. This is a beautiful thing. It's an incident ray will leave from this object something like this. Okay. We say it will enter the slab. It is bent. This is the rarer medium. This is the denser medium. Okay. So this ray will bend something like this. Again, it will leave. Again, it is bent. When light goes from one medium to another medium, it is bent. Again, it goes from this medium to this medium, it is again bent. Now, guys, this is the final ray. If you extend this refracted ray, final ray, the point where it meets, this is what we call the image. This is what we call the image. So this is the image. This is the image. Now, if there is a person sitting over here, this is the observer. So through the glass slab, he won't be able to see the object at this position. He will see the object at this position. So it looks like object has shifted. Object has shifted from its original position. Now, if you remove the slab from here, then he will directly be able to see the object at this point. Once you put the slab, so now it looks like the object has shifted. It is like this fish tank problem. It is like the fish tank problem or this apparent depth. Observer is over here. So observer feels object is here, but in reality object is at this depth. Similarly, in this particular case, observer feels object is here, but in reality object is over here. This is the image of the object. So this is what we call the shift of the observer due to the slab. If you place the slab over here, then only this shift happens. If you remove the slab, we say shift will not be there. We say, sir, this will be incident ray. Again, this will be refracted, extend this, so this will be this. And how much is this shift over here? Guys, how much is this shift over here? How much is this shift over here? P upon 1 minus 1 by relative, mu relative. And what is this mu relative? This is the relative refractive index. How to find it? Refractive index of the medium, of this medium, divided by refractive index of the surrounding. Mu m by mu s. This is how we find it. Now, one more point you need to remember over here. If the shift comes out to be positive, if the value of shift is positive, it indicates that shift is in the direction of the incident rays. If shift is positive, means shift is in the direction of incident rays. And if shift is negative, shift will be opposite to the direction of incident rays. Then shift is opposite to the direction of incident rays, means this image would be somewhere around over here, opposite to the direction of incident. I hope this is clear. Now see, shift of virtual object. Is this real object or the virtual object? Guys, is this real object or virtual object? This is over here, real object. This is the virtual image. Real object, virtual image. Because refracted rays appear to meet. Incident rays actually meet. Okay? This is the real object. Real. And this is the virtual image. Now, let's talk about the shift of virtual object. See guys? See guys? Let's suppose object is very far. These are the incident rays. These are the incident rays. This is the incident ray. This is the incident ray. This is the refractive index of the medium. This is the refractive index of surrounding. We say light enters, it will be bent. Light enters, it will be bent. Okay? Okay. Then my dear friends, again it will be bent, again it will be bent. Second refraction. So it will meet over here. Tell me one thing. We say these are the refracted rays meeting. So this is what we call the image. O dash is image. And this image is real image. Why? Because refracted rays are actually meeting. These are the refracted rays. Okay. And in this particular case, if you check over here, this is the virtual image. Refracted rays appear to meet. And this is the incident ray. This is the incident ray. Guys, extend this incident ray. The point where these incident rays appear to meet, this is called the virtual object. That's why I was saying this is the virtual object. Virtual object. Now, don't you think that in this particular case, guys, it feels like the virtual object has shifted? So if let's suppose you are placing the observer over here. So with respect to the observer, guys, we say virtual object is here, but image is formed exactly over here. So this is the shift of the virtual object because of the slab. Why? If you remove the slab over here, we said these light rays will meet over here. So this observer will directly see, sir, this object is here. If you place the slab, light rays will deviate and they will meet over here. That's why we said this is the shift. In this case also, we find the shift something like that only. E into 1 minus 1 by mu relative. If shift is positive, image has moved forward. Okay. Something like this. If shift is negative, then image would have made behind O. Image would have made behind O, not in the forward direction. Please give me the signal in the chats. I hope I am not confusing you. Please give me the signal in the chats. Come on, guys. Come on. See, we have the question over here. Locate the final image. Locate the final image. Means we have to find the shift over here. Because of the slab, we say these light rays are deviated, so it has shifted. Okay. So this is the virtual object. This is its image. Okay. So we say object has kind of shifted according to the observer, because observer is able to see the image. So here, if I say shift is T into 1 minus 1 by mu relative. So T into 1 minus 1 by, how to find mu relative? Mu m by mu s. T into 1 minus 1 mu m by mu s. Now guys, What is the value of T over here? Value of T is width of the slab, that is 3 centimeters. 1 minus 1 by refractive index of the medium, that is 3 by 2. Refractive index of surrounding, this is air. So for air, we say refractive index is 1. So it will be 1 only. Okay, now we can write it 3 into 1 minus 2 by 3. Now 3 into 1 is the 3 minus 2 by 3. So it will be 3 into 1 by 3. This and this will cancel. So it will be 1 centimeter. So object has shifted by 1 centimeter in this particular case directly. Okay. Now guys, see, this is the critical angle. Just a second, yes, we'll get the break exactly at 11:30. At 11:30, we'll take the break. Just a second, I'll come. Now guys, see. Now guys, see. Critical angle and total internal reflection. Guys, see. Let's suppose this is a surface over here. Okay. And this is the rarer medium. This is the denser medium. Okay, this is mu r and this is mu d. This is light. This is the incident ray. This is the incident ray. I am saying this is the incident ray. We say incident ray goes from a denser medium to rarer medium. This is the refracted ray. When the incident ray goes from rarer to denser, from denser to rarer, it is bent away from the normal. It is bent away from the normal. Okay. Okay. So when light goes from rarer to denser, it is bent away from the normal. From the normal. Yes. Now guys, if you increase this angle of incidence, don't you think that angle of refraction will also increase? Yes. Because at this angle I, you are getting, let's suppose at 30 degree, you are getting, let's suppose 50 degrees. Now, if you make this 40 degrees, this will again increase. Yes. So I would say on increasing angle I, angle R will also increase. Okay. And my dear friends, we say as you keep on increasing this angle I, we say angle R will increase. At certain value of angle of I, let's suppose you keep on increasing, this is increasing. At some value of angle I, we say this angle R is making 90 degree with the normal. Okay, we say I'll just write the same point. At certain value of I, angle R will make 90 degree with normal. Okay, that value of angle of I is called critical angle. We say that value of I is called critical angle. That value of angle of incidence is called critical angle. Okay, at which we say angle R becomes 90. So that value of angle of I is called critical angle when angle R is 90 degrees. What I'm trying to say is that, let's suppose this is the denser medium, this rarer medium. Light goes from denser to rarer. It is bent away from the normal. As you keep on increasing angle of incidence, this angle of refraction will also increase. At certain value of angle of incidence, this becomes normal to this. It makes 90 degrees. We say that angle of I is called the critical angle. So this is called theta C. We show it with theta C, critical angle. Okay. Yes, sir. Now guys, when it comes to the critical angle, in this particular case, if I say use the Snell's law, what does Snell's law say? Mu I sin I will be equals to mu R sine of R. Now tell me guys, mu I, refractive index of that medium where incident rays are present. This is the incident ray. This is the refracted ray. Now tell me, what is the refractive index of this medium? Sir, it is mu D. Okay, let's call this as mu D, mu denser, because refractive index of this medium is mu D, mu denser. Okay. Where is it? Okay, denser to rarer. Yes, denser to rarer. Sometimes I make mistakes from denser to rarer. Now guys, so we say mu D into sine of, what is this angle? That is theta C, will be equal to mu R, mu rarer, okay, into sine of R. What is the angle R? That is 90. Sine 90 is 1. So here sine of theta C will be equal to mu R divided by mu D. This is the value of sine of theta C. Directly I have mentioned it over here. Mu D into sine of theta C. Mu D into sine of I or sine of theta C is equal to mu R into sine of 90. Mu R into sine of 90. Sine 90 is 1. Sine theta C will be mu D, mu R minus mu D. So this is the value of critical angle. So critical angle is that angle at which refracted ray makes 90 degree with the normal. Okay. So theta C is that angle of incidence at which refracted ray makes 90 degree with the normal. Okay. Now guys, since you keep on increasing the value of angle of incidence at theta C, we say it was making 90 degree with the normal. Now if angle of incidence became greater than theta C, if you further increase the value of angle of incidence, we say, then we say, guys, at theta c, this was the refracted ray making 90. But if you increase the value of theta, this angle of incidence greater than theta c, then we say total internal reflection will take place. If theta is greater than, I is greater than theta c, then total internal reflection will take place. What is total internal reflection? Total internal reflection is light is basic strike. So with this, it will be reflected in the same medium, in the denser medium only. This is the total internal reflection. Okay. So total in TI, this is what we call the TIR. Okay. So we say this is when light is reflected in the same medium. And when this happens, when angle of incidence is greater than, critical angle. Let's take a look at this question. The light falls on the surface, something like this, okay, to find its critical angle. Guys, see, you have got this over here, mu is equal to √2. We say this is the refractive index of this medium. This is the refractive index of this medium. Okay. Light goes from denser to rarer. You guys are supposed to find the value of critical angle. This is the refracted ray. This is the incident ray. Guys. When it comes to the, we say sine of theta c, critical angle. What is the formula that we got after using the Snell's law? Sine of theta c is mu r by mu d. Mu r by mu d. I'll write over here, this is mu r divided by mu d. Refractive index of the rarer medium, that is 1. So I'll write sine of theta c is equal to 1. Refractive index of denser medium, that is √2, 1 by √2. When is the value of sine as 1 by √2? 45. So theta c is equal to 45 degrees. Okay. Sine 45 is 1 by √2, na? Why are you saying 30 degrees? Okay. If the critical angle for total internal reflection from medium to vacuum is 30 degrees. From medium to vacuum. Guys, it says that this is vacuum, means it's a rarer medium. This is a medium. It says that a light goes from, okay, medium to vacuum. This is the normal. This is theta c. A light goes from medium to vacuum. Okay. And it says that in this case, critical angle came out to be 30 degrees. So theta c is 30 degrees. Then the velocity of light in the medium will be, okay, guys, see. We say as, if you have to find the velocity of light in any medium, velocity of any light in any medium is c divided by mu. Velocity of light in speed in air divided by refractive index of that medium. Okay. Now, first you have to find the value of refractive index of this medium. Then only you can find the velocity of light in this medium. Let's find refractive index. Guys, see. We say as sine of theta c will be equals to mu r by mu d. We recently studied refractive index of rarer divided by refractive index of denser. Now I can write sine of 30. Sine of theta c is sine 30 is equal to mu r, that is 1. What is the value of mu d? That is, we have to find out refractive index of this medium. What is this? Sine 30 is 1 by 2 is equal to 1 by mu. Means mu will come out to be 2. Refractive index of this medium is 2. Now tell me, sir, velocity of light in any medium, that is c. What is the value of c? 3 into 10 raised power 8 divided by mu is 2. 3 by 2 is 1.5. So it is 1.5 into 10 raised power 8 meter per second. This is the velocity of light in that medium. This is the velocity of light in that medium. Okay, this is done. Same question. Okay, now see. The wavelength of the light in two liquids X and Y is 3500 angstrom and 7000 angstrom. Guys, see. This is liquid 1. This is X. Okay. And here wavelength of light lambda 1 is 3500 angstrom. Okay. And here wavelength of the light is 7000 angstrom. Okay, this is Y. This is Y. Now, my dear friends, in this particular case, the critical angle will be, you guys are supposed to find the critical angle. Guys, tell me one thing. See. Tell me one thing. If I say, we say as. We say use Snell's law. Use Snell's law. The wavelength of the light in two liquids X and Y is 35. Okay, then the critical angle is. Use Snell's law. My dear friends, what I'm trying to say is that in this particular case, we say light goes from one medium to another medium. If you use the Snell's law, what does Snell's law say? Sine of theta 1. Okay. Or we say sine of I divided by we say lambda 1 will be equals to sine of R divided by lambda 2. If light is going from one medium to another medium, okay, so we have studied the Snell's law in terms of wavelength, in terms of we say refractive index. This is the Snell's law in terms of wavelength, sine I divided by lambda 1, sine R divided by lambda 2. Now, if the scenario is for the critical angle over here, can I say for critical angle means if critical angle is taking place in this particular case, so can I say angle of incidence should be equal to theta c? Angle of incidence should be equal to theta c. And angle of reflection, we say then angle of incidence should be equal to theta c. Angle of refraction should be equal to, we say, sir, 90 degrees. We say, guys, in this particular case, theta I should be equal to theta c, R should be equal to 90. Now tell me, and I can write over here sine of theta c divided by, okay, lambda 1, take this as 3500 angstrom is equal to, we say, sine of R, that is sine of 90 divided by, we say, 7000 angstrom. 3500 ones are 3500 twos are. Sine 90 is 1. So sine of theta c came out to be 1 by 2. When is the value of sine as 1 by 2? Sir, when theta is 90 degrees. Sorry, when theta is 30 degrees. Theta is. Okay. The frequency, this is your homework. I have shown you enough number of questions in this. Circle of illuminance. What is the circle of illuminance? Is this clear, guys? Tell me in the chats. Is this clear? Smash the like button if you have not liked this session yet. See guys, what is this circle of illuminance all about? I would want you guys to focus exactly over here. If we place a light source inside water, the light rays coming from it will create a circle. See guys, let's suppose this is the surface, and below the surface this is water, this is water, this is water, and this is air from the upper side, this is air from the upper side, this is air, and this is water. Tell me one thing guys, if you place an object, okay, or if you place a light source over here, if you place a light source and you switch on this light source, you do this experiment at your home, we say light rays will leave something like this. So now they are going from denser medium, water, denser medium to rarer medium. So they will bend away from the normal. They will bend away from the normal. Like this, this is, let's suppose if this is creating critical angle, this will be the refracted ray. This will be the refracted ray because it's at critical angle. Here, this is another ray which is bent away from the normal. So means this is water. Inside water, you have placed the light source. We say light rays will leave from this. Okay, they will bend away from the normal. Now, here it is bent. Another light ray, another light ray, another light ray. If you join all of these points, it will form a circle. That circle is called the circle of illuminance. You do it at your home. You switch on the light source inside the water. It will form a circular shaped structure. Okay, it will form a circular shaped structure. Okay. So we say that is what we call the circle of illuminance. So how does it happen? We say light rays, these incident light rays are refracted. This is refracted. This is refracted, refracted. Join these points, it forms the circle of illuminance. If they ask us to find, they will not ask, but still, there is only one thing that we discuss over here, area of this circle of illuminance. That is pi d square. Okay. What is d? D is the depth at which you have placed the light source. Pi d square. Mu r. What is mu r? Mu r is the refractive index of that medium where refracted rays are present. Upon, we say mu d minus mu r, or you can say this is refractive index of rarer medium, refractive index of denser medium minus refractive index of, and this whole square. Pi d is the depth at which it is present. Mu r refractive index of rarer medium, refractive index of denser medium. Okay. So I would say in this particular case where d is the depth at which source is placed. Okay. Okay. Mu r is the refractive index of rarer medium. Mu d is the refractive index of denser medium. Okay. Okay. With this, we have completed our refraction portion. Now we have the prism. We need to understand the refraction in case of the prism also. Then dispersion. So I guess we need to take a break, guys. Huh? Let's take a break. Let me say 35. Session duration will be till 2 to 3 a.m. Huh? We have to complete the whole chapter, that's why. Check. Okay, guys, let's start once again. Let's move on to the prism. Now, when it comes to the prism, a lot of you might have seen the prism in your schools. This is prism. Okay, this is the prism, something like this, of the triangular shape. Okay. Now, my dear friends, when it comes to the prism, we say it is made up of, this is a triangular shape. This is the face of the prism. Okay, this front face of the prism that I have made over here. What we are going to see is that we say this is what we call the angle of prism. A means the apex angle or the angle of the prism. Let's suppose there is a light ray which is incident on this prism. Okay, and here it is air. So this is a rarer medium and this is a denser medium because this is the prism. Okay, prism has got the refractive index mu. Prism has got the refractive index mu. Now, my dear friends, in this particular case, we say light ray goes from rarer medium to the denser medium. Okay, light ray goes from rarer medium to the denser medium over here. From rarer to denser medium. And if we draw a normal in this particular case, this will be the angle of incidence. And when light goes from rarer to denser, it is bent towards the normal. So it will be bent towards the normal. Okay. So guys, this is what we call the angle of refraction. R1 is the angle of refraction. I is the angle of incidence. Okay. R1 is the angle of refraction on the surface one. Then this light ray further goes over here. We say another refraction will take place from denser medium to rarer medium. This is the second refraction. Refraction on second surface. This is the first surface. And for the second surface, this is the we say incident ray that we have over here. Okay. Now, my dear friends, we say this is the angle of incidence for the second surface, and we say this is the angle of refraction for the second surface. So in case of the prism, we say two refractions take place on the first surface, on the second surface. Angle of incidence, angle of refraction. Angle of incidence on the second surface, angle of refraction on the second surface. Okay. Now guys, I is the angle of incidence. R1 is the angle of refraction, R2 is the angle of incidence on the second surface, and this E is called the angle of emergence. This E is called the angle of emergence. So when it comes to the prism, we say two refractions take place. Okay. Now guys, further we say, if let's suppose there was no prism present over here, we said this incident ray would have gone straight, something like this. Now final ray is this. This was the path of the original ray. This is what we call the deviation. So angle between the original ray and the final ray, this is what we call the deviation. This is what we call the deviation. Okay. Yes. And if somebody asks you how much is this deviation, you say this is I plus E minus A. I is the angle of incidence, E is the angle of emergence, A is the apex angle or the angle of prism. This is how we find the deviation. And this A, angle of prism, is also equal to R1 plus R2. What is R1? R1 is the angle of refraction for first surface. R2 is angle of incidence for second surface. Okay. Now guys, you can use the Snell's law on the first surface. Why? Because wherever the refraction takes place, you can use the Snell's law. Tell me one thing. If we use the Snell's law over here in this refraction, what do we say? Mu I sin I is equal to mu R sin R. This is how we use the refraction. This is how we use the Snell's law. Now guys, sine, in this particular case, let's suppose this is air and this has got the refractive index mu. This is the denser medium. So for air, this is 1, and then I'll write sine of I is equal to, this will be mu, then I say sine of R1. This is the Snell's law on the first surface that is mentioned over here. We say refractive index of air into sine of I is equal to refractive index of prism multiplied by sine R. This is how we can use the Snell's law on surface 1. Similarly, on the surface 2, we can use the Snell's law. On the surface 2, we can use the Snell's law. Guys, on this surface 2, this is the incident ray, this is the reflected ray, refracted ray. Can I say here, I would say mu I into sine of I is equal to mu R into sine of R. Guys, tell me, what is mu I over here? Mu I is the refractive index of this medium, that is mu, and I'll write sine of I. Okay, will be equals to mu R, that is air. So this is 1, and I'll write sine of what is R, and this is E. And instead of this I would write over here R1, sorry, R2. This angle of incidence, mu. This angle of reflection, and this mu. All of this is mentioned exactly over here. You can see that is, you can see over here in this particular case, on the second surface, mu into sine of R2 is equal to mu air into sine of E. This is the Snell's law on the second surface. Now guys, you have the question exactly over here. Find R1, R2, E and deviation. R1, R2, E and deviation. These are the things you guys are supposed to find out. Angle of prism in this particular case is given as 75 degrees. Refractive index of the prism is √2. Angle of incidence is 45 degrees. Okay. Guys. We say this is the light ray. We say it is bent something like this. Then it is bent something like this. We say this will be the angle of emergence. This is R2. This will be R1 over here. Now you guys tell me one thing. I would want you guys to tell me one thing in this particular case. Guys, see. Let's first find the value of R1. We say use Snell's law on S1, on surface 1. So what will you say? Mu I into sine I. What is mu I? That is 1. Refractive index of air is 1. Into sine I, sine 45. Sine of 45. Mu I sine I is equal to mu R. What is mu R? That is √2 sine R. So that is sine of R1. Refractive index of this medium. Sine 45 is 1 by √2 is equal to √2 into sine of R1. So sine of R1 will be equal to √2 into √2 is 2. So 1 by 2. When is the value of sine as 1 by 2? When R1 will be equals to 30 degree. Because here you can write instead of 1 by 2 sine 30 and this will cancel. Sine will cancel. R1 will be 30 degrees. Yes, sir. Now guys, since you got the value of R1, we say as A will be equals to R1 plus we say sir R2. Apex angle we know sir, this is 75 degrees. 75 degrees. Okay. R1 you got 30 minus this will be 30 will be equal to R2. 75 minus 30 is 45. Okay. So R2 will come out to be 45 degrees. Yes. So you got the value of R1, R2. Let's find the angle of emergence. Guys. We say use Snell's law on surface 2. Use Snell's law on surface 2. Guys, when it comes to the Snell's law on surface 2, what is that? That is mu I sin I. This is the incident ray for the surface 2. Mu I, that is root 2 sine of I. Sine of angle of incidence over here is R2 is equal to. Then we say refractive index of air, that is 1. Then we say sine of E. Sine of E. Mu I sine I, mu R sine R. Now, what is the value of R2 over here? That is 45. So this will be root 2 sine of 45 is equal to sine of E. Sine 45 is 1 by root 2. So this root 2 into 1 by root 2 is equal to sine of E. So this and this will cancel. Sine E is 1. So E will come out to be 90 degrees. E comes out to be 90 degrees. Simple calculation I am doing. Now you have to find deviation. Guys, deviation is, what is the formula for deviation? I plus E minus A. I can simply say I plus E minus A. Deviation is, what is the value of I? 45 plus, what is the value of E? That is 90 minus 75. So deviation comes out to be 60. Is this clear? Is this clear? Deviation comes out to be 60. Okay. Great. Now guys, there is an interesting fact which I would like to show you over here. There is an interesting fact which I would like to show you over here. Guys, see. This is the question which we recently solved. When angle of incidence in this question is 45 degrees, okay? And this angle was 75 degrees, apex angle. Here also this angle is 75 degrees. We got the value of, guys, understand, angle of incidence is 45 degrees. We got the angle of emergence as 90 degrees. See, angle of emergence 90 degrees. And we got the deviation as 60 degrees. We got the deviation as 60 degrees. Deviation as 60, this. Now, my dear friends, see. We say what happens over here is something like this. This is the angle of emergence, which is 90 degrees. Now, interchange these two. Put angle of incidence as 90 degrees. Angle of incidence as, here angle of incidence is 45. And emergence is 90. Just interchange these two. Put angle of incidence 90. In that particular case, we say, this comes out to be, E comes out to be 45 degrees. In this particular case, E comes out to be equal to 45 degrees. So if you are interchanging this and this, means initially this was 45 degrees. Now, and angle of emergence is 90 degrees. Do one thing. Keep this as 90 degrees. Apex angle 75. Emergence will come out to be 45. And deviation will be same. So can I not say at two different values of I, deviation can be same. Like when I is 45, deviation is 60. When I is 90, deviation is 60. Deviation comes out to be same. Now, using the same logic, I will plot the graph between this deviation versus angle of incidence, and this graph comes out to be something like this. Guys, this is the angle of incidence. Let's suppose I take this point over here. Guys, don't you think in this particular case, you see, deviation at this point is, see, when you check this angle and this angle, we say, let's suppose at this angle, I is equal to 45 degrees. Okay. And here, value of E is equal to 90 degrees. And when you keep this I as 45 degrees, okay, let's keep this as I as 90 degrees, okay, E comes out to be equal to 45 degrees. We say deviation here is 60 degrees, deviation here is 60 degrees. Means what I'm trying to say is that when the value of I is 45, deviation is 60. Okay, let me mention the deviation over here. So deviation in this case is 60 degrees. So means at two different angles, deviation is same. Deviation, that's why graph came out to be something like this. When I is 45, deviation is 60. When I is 90, deviation is 60. So here E is 90, E is 45. Guys, is this graph clear? Is this graph clear? And from this graph, see, you can clearly see over here, this is the lowest point. This is called the minimum deviation. We say for minimum deviation, guys, we say angle of incidence will be equal to the angle of emergence. For minimum deviation, angle of incidence is equal to the angle of emergence. When angle of incidence becomes equal to the angle of emergence, deviation will be minimum. And we say R1 is equal to R2. For minimum deviation, angle of incidence is angle of emergence, R1 is equal to R2 is equal to R. If that happens, my dear friends, tell me one thing. We say apex angle A is equal to R1 plus R2. Both are R. A is equal to R plus R, that is 2R. This will be 2R. So can I not say R will be A divided by 2? Yes. And deviation is 2E minus A. So here you can write 2I minus A. Okay. So basically, this is the graph between deviation versus I. So at two different angles, deviation can be same. And at minimum deviation, we say angle of incidence will be equal to angle of emergence. If there is a prism in which angle of incidence came out to be equal to the angle of emergence, then understand one thing. We say angle of I is equal to angle of R, R1 is equal to R2 in that particular case. And this is refractive. If somebody asks you to find the refractive index of the prism, by this formula you can find the refractive index of the prism. Mu is equal to sine of A plus minimum deviation by 2. What is A? A is basically angle of prism. A is basically angle of prism. This is minimum deviation by 2, sine of A by 2. I'll show you the question on this one also. If 60 degree prism has, it says that you have got a prism over here. 60 degree prism means you have got the prism, its apex angle is given as 60. So A in this case is given as 60 degrees. You have got a prism, apex angle is 60. And refractive index of this is given as √2. Angle of incidence for minimum deviation will be, you guys are supposed to find out what is the angle of incidence in this particular case. Guys, see. If it is saying minimum deviation, we say for minimum deviation. For minimum deviation. Guys, can I not say R is equal to A by 2? And what is this R? This R is the angle of refraction. Okay. So I can say this R is equal to A by 2. That is 60 by 2. That is 30 degrees. Now, my dear friends, this is the normal that you have over here. This will be 30 degrees. Okay. In this case, this is I, this is angle of refraction over here. Now tell me one thing, use Snell's law. We say use Snell's law. What does Snell's law say? Mu I into sine I is equal to mu R into sine R. What is mu I? Refractive index of that medium where incident rays are present. This is air. So here this is 1. Sine of I we have to find out is equal to mu R, refractive index of the medium, root 2. Sine R, that is sine of 30 degrees. So I can write over here sine I is equal to root 2. Sine 30 is 1 by 2. So it will become root 2 by 2. Now multiply with root 2 and divide with root 2. Rationalize it. Root 2 into root 2 is 2. This 2 will cancel with this one. So sine of I will be equal to 1 by root 2. When is the value of sine I as 1 by root 2? When I is 45 degrees. Because sine 45 is 1 by root 2. Okay. Sine 45 is 1 by root 2. Sine 45 is 1 by root 2. So here minimum deviation was given. I used this because I recently told you in case of minimum deviation, I is equal to E, R1 is equal to R2 is equal to R. So R is equal to A by 2. This thing you need to keep in your mind. If the angle of minimum deviation is 60 degree for an equilateral prism. So here minimum deviation is given as 60 degrees. In case of a prism, minimum deviation is given as 60 degrees. For an equilateral prism means in which apex angle is 60. Equilateral means in which angle is 60 degrees. Now, can I say in this particular case, I will be, here, guys, R will be equals to A divided by 2, that is 30 degrees. Angle of refraction is 30 degrees. Then the refractive index of the material is, you guys are supposed to find the refractive index in this particular case. Okay, guys, when they ask you to find the refractive index, we said directly use this formula. Directly use this formula. Because this will help us to find the refractive index. Mu is equal to, I'll just write it. Mu is equal to sine of A plus minimum deviation by 2. We say as mu is equal to sine of A plus S minimum divided by 2 whole divided by sine of A by 2. Sine of A by 2. Now guys, I'll write sine of, what is the apex angle over here? That is 60. 60. Okay. And then we say plus, what is the minimum deviation? That is also 60 divided by 2 upon, we say this is sine of A by 2, that is 60 by 2. So how much it will be? So mu will come out to be sine 120 by 2 is sine 60. This is sine of 60 divided by sine of 30. So this is a root 3 by 2. Sine 30 is 1 by 2. Now take this in the numerator. So it will be a root 3 by 2 into, we said 2 by 1. This and this will cancel. So it will be root 3. So refractive index in this case came out to be root 3. Root 3 is the correct answer. Okay. What about this one? A monochromatic light is incident at a certain angle on an equilateral triangle prism. Suffers minimum deviation. Once again, you have got an equilateral triangle prism. You have got an equilateral triangle prism. So means angle A is 60 degrees. And it is talking about the minimum deviation. Guys. So R is equal to A by 2. That is 30 degrees. If the refractive index of the prism, mu is given as root 3. The angle of incidence is, now they have asked the angle of incidence. Guys, this is the prism. And in this particular case, light is entering the prism. Light is entering the prism. This is the light which is entering the prism over here. Okay. And then it gets deviated something like this. Then it comes out. Now guys, let's draw the normal exactly on the surface. So we say this will be the angle of incidence and this is the angle of reflection. Apply the Snell's law on the surface 1. We say mu I sin I is equal to mu r sin r. What is the value of mu I? This is air. So this will be 1. Then I'll write sine of I is equal to mu r. That is root 3. Refract index of this prism. Because this is the incident ray, this is the refracted ray. Sine r. Sine of 30. I'll write over here sine of I is equal to root 3. Sine 30 is 1 by 2. Root 3 by 2. When is the value of sine as root 3 by 2? I'll write sine I is equal to sine of 60. Because sine 60 is root 3 by 2. Sine will cancel. I will come out to be 60 degrees. Angle of incidence is 60 degrees. Dispersion of light. Dispersion of light. Now guys, see, it is the process of splitting of white light into 7 different colors. It is the process of splitting of white light into 7 different colors. Like, let's suppose you have a white light over here falling on the prism, Whenever white light falls onto the prism, it is split into 7 different colors. This one is the violet, indigo, blue, green, yellow, orange, red. Like we write it something like this. This is V, I, B, G, Y, O, R. So when the white light passes through the prism, it is split into 7 different colors. This phenomena is called the dispersion of light. Splitting of white light into 7 different colors. Now guys, let's suppose this is the white light exactly over here. I would want you to focus in this case. This is the white light exactly over here. Okay. And here, this is the surface. I'll write this is the surface. Okay, and this is normal. Don't get confused. This is not the surface, something like this. It is the surface. This is the normal. This is the vertical surface right now. We say from this side it is air, from this side it is the medium. Now light is entering from air to we say medium. From air to we say medium. Light is entering from air to medium. Okay. Now my dear friends, when light enters from air to medium, okay, we say here this white light is splitted into 7 different colors. Like over here, we say this first one is violet, okay, and then you have blue. Violet, where is indigo? Indigo is missing. Indigo, plain indigo. So this is violet, indigo, blue, green, yellow, orange, red. VIBGYOR. Okay. Okay. Now guys, see, let's now move on to this particular slide and understand this point over here. See. Let's understand this dispersion through prism. Let's suppose this is the white light. It is entering the prism. It's entering the prism. And now it is splitted over here. This is the first color, that is violet. This is the violet that we have over here. Okay. This is a red, last color. And this is yellow. I will take only 3 colors now. Okay. I'll not split it in all 7 colors. I'll take 3 only. Okay. So I know rest of the colors will be in between these only. Okay. Because we say the lowest one is violet. The highest one is a red. Cool. Now guys, we say this is the violet, this is the yellow, this is the red. This is the original path of the incident ray. This is the original path of the incident ray. Now, if I ask you how much violet has deviated from its path, you'll say, sir, this is the deviation of violet. Okay, delta V. This is the deviation of yellow, delta Y. This is the deviation of red. How much red is deviated from the original path. So delta Y is the deviation of the yellow light. Delta V is the deviation of violet. Delta R is the deviation of red. If somebody asks you how to find the deviation, this deviation will be mu V minus 1 into A. Mu V minus 1 into A. Sir, what is this mu V? Mu V is the refractive index of violet. Sir, what is this? Now I'll tell you. Guys, see. Here, when this white light enters this prism will offer different refractive index to different colors. Okay. So we say here, refractive index for this will be different, for this different. You say, sir, this will have common refractive index. Yes, but to different colors, it will offer different refractive index. Okay. So we say this prism will basically offer different refractive index for different colors over here. That's what I'm trying to say over here. This deviation of the violet is mu V minus 1 into A. A is the angle of prism. This is the deviation of violet minus 1 into angle of prism. Okay. So this is the refractive index of violet minus 1 into prism. Similarly, deviation of red is refractive index of red minus 1 into prism. Red will have different refractive index. Now, my dear friends, what is this theta? Theta is the angle between this R and this V. And how can you find this deviation of V? This angle minus this angle. Whole minus this will be given as this. Delta V minus delta R. Now, if you put the value of delta V as this one, delta R as this one, and solo, this will come out to be value of theta. Mu V, refractive index of V, minus refractive index of red into angle of prism. This will be the value of theta in this particular case. Okay. Now, guys, next, one more thing we discuss over here, that is mean deviation. Sir, what is mean deviation? See. We say mean deviation is a mean refractive index minus 1 into angle of prism. Sir, what is this mean refractive index? See. When it comes to the mean refractive index, it is refractive index of violet plus refractive index of red divided by, we say, 2. Refractive index of violet plus refractive index of red divided by 2. And this is mean deviation over here. Okay? Mean deviation over here. So mean deviation is refractive index of violet plus refractive index of red divided by 2. Also, we call it the refractive index of yellow. Sorry. Okay. So basically, this is what we call the mean deviation. This is what we call the mean refractive index. Then you have the dispersive power. Then you have the dispersive power. What is this dispersive power all about? Dispersive power over here is this omega. And we say it is theta divided by mean deviation. Sir, what does dispersive power actually mean? Dispersive power says how much a material is able to disperse the light. Like if a material is able, what is the capability of a material to disperse the light? More is the capability, more will be the dispersive power. Like guys, I hope you are not confused in this. When it comes to the dispersion in case of a prism, we say these are the colors. Like we say deviation of this red is SR, delta R, delta Y, delta V. This is the deviation, how you can find the deviation. This is the refractive index over here. Okay. Then we discuss the mean deviation also, dispersive power also. And my dear friends, when it comes to the dispersive power, you say it is theta divided by mean deviation. Theta is this. Theta is this. Okay. Divided by mean deviation. Mean deviation is this. How you can find the mean deviation. And what is theta? Value of theta you have mentioned over here, mu v minus mu r into a. Mu v minus mu r into a. Mean deviation is mu mean minus 1 into a. A and a will cancel. So this will come out to be mu v minus mu r divided by mu mean minus 1. This will be the dispersive power that you can say. This will be the dispersive power that you can say in this particular case. Okay. I hope this is crystal and clear. I hope this is crystal and clear. Guys, give me the signal in the chats. Is this crystal and clear to each and every single student? Tell me. Tell me. Also, one more formula I would want you guys to remember. Also, we say mean deviation we can find. That is deviation of violet plus deviation of red divided by 2. With the help of this formula, you can also find this. Okay. Deviation of violet, deviation of red divided by 2. You can find with the help of this formula also, with the help of this formula also. Great. Now guys, see. Compare the dispersive powers of two prisms. Okay. If one of them deviates violet and red by 10 degree and 6 degree. Let's talk about the prism 1. Guys, let's suppose we have the prism 1. In this prism 1, we say deviation of violet and red rays are this guys, this is the prism. It is able to disperse or deviate this violet by how much? 10 degree. Means deviation of violet is given as 10 degrees. Deviation of red is given as 6 degrees. Okay. We have to find its dispersive power. Guys, first of all, tell me one thing. Can you find the value of mean deviation? Sir, mean deviation will be SV delta V plus delta R divided by 2. So that will be 10 plus 6 is 16 by 2. 16 by 2, that is 8. So mean deviation came out to be 8. Okay. And also I can find the value of theta. Also I can find the value of theta. Guys, tell me how to find the theta. Theta will be simply, sure. What is the original formula of theta? Yes, deviation of violet minus deviation of red. Deviation of violet minus deviation of red. So theta will be, deviation of violet is 10 minus 6, that is 4 degrees. So you got the mean deviation, you got the theta. Now how can you find this dispersive power for this prism? That is theta divided by mean deviation, because this is the original formula. So dispersive power for this theta is how much? That is 4 degree divided by 8 degrees. So omega 1 will come out to be, that is 0.5. Okay. Dispersive power. Now guys, and the second prism can deviate. Let's talk about the prism 2. Prism 2. In second prism, we say deviation of violet is 8 degrees. We say deviation of red is 4.5 degrees. Deviation of violet is 8 degrees. Deviation of red is 4.5 degrees. And when it comes to the mean deviation, so we say mean deviation is simply SV plus SR by 2. SV plus SR, that is 8 plus 4.5, 12.5 divided by 2, 6.25. And when it comes to the theta, SV minus SR, that is 8 minus 4.5, that is 3.5. And when it comes to the omega 2, dispersive power of second, that will be how much? Where is this? Theta by mean deviation. So that will be 3.5 divided by 6.25. 3.5 divided by 6.25. Am I clear with this, guys? Yes, 0.56. So this will be 0.56. So this is the dispersive power of the second prism. This is the dispersive power of the first prism. As simple as that. Guys, I hope you are not confused with the prism. Prism is a material which is dispersing the light rays, splitting the white light into 7 different colors. Like here. This is how you can find the deviation of the violet. How much violet got deviated from the original path. Deviation of red. Similarly, for other colors also you can find it. Like for blue, deviation of blue will be mu b minus 1 into a. This is theta angle. Then we discuss mean deviation. Then we discuss dispersive power, and that's it. Now guys, take a look. Take a look over here. See, refraction at spherical surfaces. Guys, till now we were talking about the refraction at plane surfaces. Like all of these. The refraction at, this is the plane surface. Light goes from one medium to another medium. This is the plane surface. Here, plane surface. Every problem we solved, the refraction is plane surface. Here, plane surface, another plane surface. Okay. Here, this is a plane surface. Light is going from one medium to another. So this was basically the refraction at plane surfaces. But when it comes to the refraction at spherical surfaces, that is what we need to discuss now. Okay. Guys, see. Let's suppose you have got a curved surface over here, curved surface. From this side, you have got one medium. From this side, you have got another medium. Okay. This is medium 1. Medium 1. From this side, it is medium 2. Medium 2. And this is the spherical surface. Now, guys, I am saying object is over here. Light ray will leave from the object. It will enter into the another medium. Can I call this as refraction? Yes, sir. But this refraction is taking place at spherical surface, curved surface. So that's why we call it the refraction at spherical surfaces. Okay. Guys, see. We say from here, from the object, incident rays will leave. This is the incident ray. Let's suppose this is the incident ray. And this one will be the refracted ray. Refracted ray. The point where refracted rays fall or meet, image will be formed. Image will be formed. Yes, sir. Now, guys, in this case also, sir, what is the position of this object? That is U. Here also we discuss as U. Position of the object. Sir, what is the position of the image from the surface? That is V. Yes, sir. Now, the direction of incident ray is this towards right. The direction of incident ray we always consider as positive because I have discussed this previously. Same sign conventions here. So this will be the positive side. This will be the negative side. Refractive index of this medium is mu I, rarer medium. Refractive index of this medium is mu R, denser medium. Yes, sir. Yes, sir. Okay. Now, my dear friends, in this particular case, like over there, we have the mirror formula 1 by V plus 1 by U is equal to 1 by F. This helps us to find the position of object, position of image. Similarly, here also we have the formula, which helps us to find the position of the object, position of the image, position of the image, position of the object, or we say radius of curvature. Okay. So we say here we have the formula, here we have the relation between V, U and R. In case of mirror formula, it is V, U and F. So what is that formula? Mu R by V, refractive index of that medium where refracted rays are present, minus mu I by U, refractive index of that medium where incident rays are present, is equal to mu R minus mu I divided by R. Mu R is the refractive index of that medium where refracted rays are present. This mu I divided by R. This is the formula that we use over here to find the position of image, position of object, or radius of curvature. Also, magnification. How much image has magnified, how much bigger the image has become. V divided by mu R. Okay. Position of image divided by mu R upon U divided by mu I. Okay. Also, velocity of image with respect to spherical surface. What is the velocity of the mirror? What is the velocity of image with respect to the spherical surface? Velocity of image with respect to the spherical surface. If I say object is moving in this case, we say image will be also moving. So how to find the velocity of the image? You say V square by U square, position of image by position of object, square. Mu I by mu R, refractive index of that medium where incident rays are present, refractive index of that medium where refracted rays are present, into velocity of object with respect to the surface. This is how we find the velocity of the object image in this particular case. Guys, is this slide crystalline clear? Is this slide crystalline clear? I would want you guys to tell me. Tell me, guys. Is this crystalline clear? Now, guys, see, let's suppose you have a curved surface over here. Okay. Let's talk about the sign conventions. This is the object. And we have studied previously, this is the direction of the incident rays. We always take direction of incident rays as positive. This will be positive and this will be the negative side. This will be the negative side. So here we said this is the position of the image, that is u, and u will be negative. Radius of curvature in this case will be positive because radius of curvature will be from this side, positive side. Radius of this surface will be from this side. Okay, like join this with radius of curvature. Here, this side will be positive, this side will be negative. Okay, in this case, position of the image will be negative because the image is over here. Radius of curvature is also negative because this surface has radius of curvature from this side. Okay. Let's talk about this surface. Given the spherical surface of radius of curvature 20 centimeters. Okay, cool. Mu I is 2, mu R is 3. Find the position and size of the image. You guys are supposed to find the position and size of image. This is the spherical surface. Spherical surface. Object is placed at u is equal to 15 centimeters. Guys, this is the direction of incident rays because this is the object. This side is positive, this side is negative. Clearly, I can say in this case, u is minus 15 centimeters. Make sure you follow the sign conventions properly. So, u is minus 15. Okay. Yes, yes, yes. U is minus 15. What about radius of curvature? Radius of curvature will be from this side. So radius of curvature will be plus 20 centimeters. Now guys, what is the formula we are supposed to use? As, see, this formula. Mu I divided by V minus mu I divided by U is equal to, I'll be using this, mu R by V as mu R divided by V minus mu I divided by U is equal to mu R minus mu I divided by V, say sir, this R. Okay. Now, what is the value of mu R? Guys, mu R is that medium where refracted rays are present. This is the incident ray here. Refracted rays are here. So this will be 3 divided by mu 2 is mu R. 3 divided by V. V we have to find position of the image minus mu I. This refractive index of this medium 2 divided by U. U is minus 15. So it will become plus 15 over here. Is equal to. So I can say over here, this will be 3 minus 2 divided by radius of curvature is over here. That is 20. Radius of curvature is over here 20. Solve this, V will come out to be minus 36. V comes out to be equal to minus 36 over here. Okay. Now guys, listen to me very, very, very carefully. What I'm trying to say, in this particular case, let's find the, and what is this minus 36? What does it mean? What does it mean? Guys, it means that if the object is at minus 15, because this is negative side, image will be somewhere around over here. I will show you. something like this. See, this is the object. Okay, incident rays will leave from the object. Incident rays will leave from the object. Okay, then something like this. Now, if you extend this, and if you extend this, the point where these meet, this will be the image. And this V will be equal to -36. U is equal to -15. So these are the incident rays. These are the refracted rays. Refracted rays. So refracted rays appear to meet. So this is the virtual image. I hope you got the proper feel of this question. I hope you got the proper feel of this question. This is the virtual image in this case. Okay. Okay. Now, guys, let's move on to the lens. Let's move on to the lens. See, guys, when it comes to the lens, guys, I would want you guys to understand one thing over here. When it comes to the lens, we say a lens is made up of two surfaces at which refraction takes place. See, guys, you have got one surface over here. Okay, so this is one surface. Refraction can take place at this surface also. Like let's suppose you have got a surface over here. This is the principal axis. Light ray is coming and it is getting deviated, something like this. So this is the refraction. Okay, this is the refraction. Now, my dear friends, if I say at one surface refraction can take place, at another surface also refraction can take place. So when these two surfaces combine, they will form the lens. They will form the lens. A lens is made up of two surfaces. A lens is that material in which two surfaces are present. At which refraction can take place. Okay? Like you have mirrors. In case of the mirrors, you were saying, sir, reflection is taking place on one surface. Then we spoke about the refraction. Sir, this is a spherical surface. Light goes from one medium to another. This is the refraction at one surface. If you have another surface joined, this becomes lens. Two surfaces. A lens is made up of two surfaces at which refraction takes place. There are two types of lenses. Convex lens and concave lens. Guys, see, if we take this curved spherical part, curved part, I have told you this outer portion is called the convex side. And this inner portion is called the concave side. Outer side is called convex, inner is called concave. Now guys, listen. I can say, if you join this with this one, now if there is a person who is looking at this lens over here, he would be able to see its concave side or convex side. Sir, obviously concave, convex side. the person would be able to see its convex side only. Convex, convex from both the sides. So we call this as biconvex lens. If the observer is able to see its convex side from both the sides, then this is the convex lens. And we call it biconvex lens. Why bi? Because from here this is convex, from here, from both the sides it's convex. Radius of curvature of this is R1, radius of curvature of this is R2. Next, there are three types of convex lens. This is called biconvex. This is called plano-convex. Guys, from one end it is plane, from another end it is convex. If you look from this side it is plane, if you look from this side it is convex. That's why plano-convex lens. And here it has got radius R2. Whenever you have the plane surface, always remember its radius of curvature is infinity. For plane surface, we consider radius of curvature as infinity. Okay. Now, then you have, take a look at this, guys. If there is a person looking at this is the convex side. If there is a person looking at this from this side, this is the concave side. So this is what we call the concavo-convex lens. Because here, convex side is present, also concave side is present also. Concavo-convex lens. This is called concavo-convex lens. This is plano-convex lens. Biconvex lens. And here you say, this has got radius of curvature R2, R1. Here R2 is less than R1. Next, we have concave lenses. See, guys, you see this is the inner side of the spherical portion. That is called the concave side. This is also concave side. That's why we call it biconcave lens. If you look from this side, it's concave. If you look from this side, it's concave. And if you look from this side, it is concave. If you look from this side, it is plane. So plano-concave lens. Plano-concave lens. Previous one was plano-convex lens. Radius of this is R2, radius of this is infinity. And this one, from this side it is concave, from this side it is convex. So we call it convexo-concave lens. Convexo-concave lens. Because from this side it is convex, from concave, from this side it is convex. And here R2 is less than R1. Is this clear? So these were the types of lenses that we have. Is this clear? Tell me, guys. Now, guys, first focus. Let's discuss first focus. Let's define first focus over here. See, it is that point on the optical axis through which, if light ray passes, becomes parallel to principal axis after refraction. See, guys, let's suppose I'm taking over here biconvex lens. Okay, this is biconvex lens. Now, guys, I would want you to understand one thing. Let's suppose light rays leave from this focus. Light rays leave from this focus. We say after refraction, it becomes parallel to principal axis. After refraction, it becomes parallel to principal axis. Then we call this focus as first focus. It is that point on the optical axis. This is what we call the optical axis. Like over there, it was having, in case of the mirrors, it was having the principal axis. Here we have optical axis. It is that point on the optical axis through which if light ray passes, that point through which if light ray passes becomes parallel to principal axis, then becomes parallel to principal axis after refraction. So if from now onwards you'll remember, if the light rays pass through any point and then become parallel to principal axis after refraction, means that point you can consider as first focus. That point you can consider as first focus. Okay. Now in case of biconvex, that is biconvex, biconcave. This is biconcave. Biconcave lens. Tell me guys, when it comes to the biconcave, we say, let's suppose light rays come something like this, okay? Okay. This is the converging lens, this is the diverging lens. So these are the light rays which are coming. Now, after refraction, they become parallel to principal axis. If the light rays are coming something like this, after refraction, they become parallel to principal axis. Now, if you extend these, we say here, these light rays appear to meet at focus. Here, light rays actually meet at focus. Here, light rays appear to meet at focus. So we say in this particular case, if light rays appear to meet at focus or light rays meet at focus in reality, then it is called the first focus. So this will be the first focus of biconcave. This will be the first focus of biconvex. Okay, biconcave and biconvex. Now see, it looks like these light rays leave from the focus only. It looks like, but in reality it is not. Okay. Now, principal focus for this, it will be negative, because the direction of this is incident rays. This will be positive side, this will be negative side. So this is negative. Sure, direction of incident ray is this, so this will be positive side. So this focus will be positive. Principal focus of convex lens is positive, negative, and this is positive. Next, second focus. If a light rays are already parallel, then after refraction, it passes through the second focus. If you have the lens over here, and if the light rays are already parallel to principal axis, we say after refraction, they will pass through that point, which is called the second focus. What is the difference between this and this? You see over here, in this case, if the light rays are passing through a point, then becomes parallel, that point is called the principal axis. Here, principal focus or the first focus. In this case, if the light rays are already parallel to optical axis, then they will pass through the point focus. That is what we call the second focus. Now see, if the light rays are already parallel, so this is the diverging lens, it will diverge. These light rays will be diverged. Now if you extend these, they will meet at a point that is called the second focus. In this case, refracted rays appear to meet at this point. In this case, refracted rays are actually meeting at this point. And when it comes to the principal focus, in case of principal focus, incident rays appear to meet at principal focus. Sorry, incident rays actually meet at principal focus in case of biconvex. Incident rays appear to meet at principal focus in case of biconcave. Refracted rays actually meet at the second focus in case of biconvex. Refracted rays appear to meet at second focus in case of biconcave. I hope there is no doubt in this. There is no doubt in this. And you can clearly see over here, here focus is positive, here focus is negative. Second focus for concave is negative, second focus for convex is positive. Guys, is this first focus and second focus clear? Is this first focus and second focus clear? Great. Now we have the lens maker's formula. Lens maker's formula. Like you have the mirror formula over there. In case of the mirrors, here you have the lens maker's formula. Okay. Guys, see. Similarly, here we have lens maker's formula, which helps us to find the focal length of the lens, position of the object, position of the image. Guys, tell me one thing. When it comes to the mirror formula, you say 1 by f is equal to 1 by v plus 1 by u. Okay. This was the formula which helped you to find velocity, position of the object, position of the image, focal length of the mirror. Similarly, in case of the lens, if you want to find the position of the image, the position of the object, or the focal length, then this is the formula. See guys, here we say 1 by v minus 1 by u is equal to mu L by mu S. Let's suppose I am saying I have got the lens over here. This is the lens. This is the optical axis. Okay. Refract index of this lens is mu L. Surrounding has mu S. Okay. This is the object. So this is U. This is the image. This is V. And a radius of curvature of this is, let's suppose, R1. Radius of curvature of this is, let's suppose, R2. Now see. We say 1 by V minus 1 by U is equal to mu L by mu S. Refractive index of lens divided by refractive index of surrounding. Minus 1 into 1 by R1 minus 1 by R2. This is the lens maker's formula, or we can write it like this. 1 by F. Over here it is not plus, it is minus. Keep that thing in case of the lens, it is minus over here. 1 by F is equal to mu L by mu S. Refractive index of the lens divided by refractive index of the surrounding. Minus 1. Minus 1. Then we say 1 by R1 minus 1 by R2. Okay. So you can also say these two are also equal. 1 by V minus 1 by U is equal to 1 by F. This is called the lens maker's formula. And with this formula, you can find the position of the object, position of the image, focal length also. Next, magnification in case of the lens. If you want to see how big the image has become, so magnification formula is simply V divided by U in terms of position of image, position of object. F upon F plus U in case of the focal length and position of the object. F minus V upon F in case of the focal length and position of the image. These are the formulas. Also, velocity of the image also you can find here. Guys, perpendicular component of the velocity of the image, like over there. Perpendicular component of the velocity of the image. Like this is the lens over here. This is the lens. Okay. I'm saying this is the object which is moving something like this. Object is moving something like this. Parallel component, perpendicular component. Or guys, let's suppose this is the object which is moving something like this. This is theta. This will be the perpendicular component. This is velocity of object. This will be the parallel component. And how we can find the perpendicular and parallel component? Velocity of image with respect to the lens. This is lens. Lens will have velocity VL. Velocity of image. This is the object over here. Its image will be over here. Velocity of image with respect to the lenses. V square minus U square. Position of the object divided by position of the image by position of object into velocity of object with respect to lens. This the parallel component. When it comes to the perpendicular, velocity of image with respect to the lens is equal to m magnification velocity of object with respect to the lens. So these are the two formulas by which you can find perpendicular component and parallel component. Okay? Okay? Now, one more thing. Sign conventions will be exactly similar. Direction of incident rays is taken as positive. If the magnification came out to be negative, image is inverted. Already discussed, same things. I'm repeating the things over here. Over there it was mirrors, here it is lens. If magnification is positive, image is erect. If magnitude of magnification is greater than 1, image is magnified, enlarged, bigger. If magnitude of m is less than 1, image is diminished, smaller. Guys, is this clear? Please, I would want you guys to give me the signal in the chats. Everyone, whosoever is watching, because at this point of time, you need to tell me this. Is this clear? There are so many formulas in this one. Tell me. Come on, solve this question. I have put up the question on the screen. Calculate the focal length and calculate the focal length and power of lens. Calculate the focal length and power of lens. Guys, see, you have got a lens over here. A refractive index of the lens mu L is 3/2 and refractive index of air is given as 1. Okay. Radius of curvature of this surface is 30. Radius of curvature of this surface is 60. This is the direction of incident rays. This side will be positive. This side will be negative. We have to find the focal length. First and the foremost thing over here is, whenever you have to find the focal length in case of the lens, I recently told you the formulas. This formula will help us to find the focal length. This formula helps us to find the position of the image, position of the object. Okay, we'll use this formula. 1/f, we say as 1/f is equal to mu L, refractive index of lens divided by refractive index of surrounding minus 1. Then we say 1/r1 minus 1/r2. Okay, 1/r1 minus we say 1/r2. Cool. Now let's write the sign conventions. Guys, tell me one thing. See, this is radius of curvature of this surface will be from this side. R2 will be from this side because this is the curved nature. It's from this side. So I can say R2 will be negative. R1, radius of curvature of this surface will be from this side. So I can say R1 is plus 30. And I can say R2 in this case will be minus 60. What else? Now, 1 upon focal length will be Mu L by mu S, refract index of this is 3 by 2. Divided by mu S, refract index of air surrounding is 1. Minus 1. 1 by R1. R1 is 30, 1 by 30. Minus 1 by minus 60, that becomes 1 by plus 60. Okay. Solve this, F comes out to be equal to 40. 40 centimeter. Focal length of this is 40 centimeter. Okay. Yes. Yes. Now, guys, in this particular case, focal length of this is 40 centimeter. See, I say, when it comes to the power, now, guys, how do we define power? Power is minus 100 upon F. So power is minus 100 divided by, we say, 40 in this particular case. Okay. This is how we define power actually. Okay. Okay. And my dear friends, here in this particular case, I would want you guys to ignore this negative sign. So directly write this is 100 divided by F, because we'll find the magnitude only. So 100 divided by 40. This and this will cancel. So power is 10 by 4 diopter. Power is 10 by 4 diopter. Okay. The radius of curvature of a convex face of the plano-concave lens is 15 centimeter. And refractive index of the material is plano-convex, it is saying. Plano-convex. And refractive index of the material is 1.4. Means refractive index of the lens is 1.4. Then the power of the lens in diopter is, can you guys solve this question? Tell me. Plano-convex, it is saying. How do we make the plano-convex? Guys, this is plano-convex. This is plano-convex. Okay. And we know for this, suppose this is R2, this is infinity, and this is R1 over here. The radius of curvature of a convex face of a plano-concave convex is 15 centimeter. This is 15 centimeter in this particular case. And refractive index of the material is 1.4. Refractive index in this case is given as 1.4. Okay. Now, can you solve this, guys? Simply in this particular case, what you are supposed, you have to find the power. So first find the focal length. 1 by F is equal to mu L by mu S minus 1. Then 1 divided by R1 minus 1 divided by R2. Simply. Mu L in this particular case is 1.4. So mu L is 1.4. Mu S surrounding is given as 1 because this is air. Okay. 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 So find the focal length first. Then power will be simply. That is 100 divided by F. Check how much is coming out to be. Like it is exactly like this question. Before this question, you will have to understand the cutting of lens. Yes, 2.66 diopter is correct. That's correct. Okay. Yes. Now, guys, lens cutting. My dear friends, let's suppose you have over here a lens, okay, and you are cutting this lens something like this, parallel to principal axis, cutting the lens parallel to principal axis. Okay, you want to cut this, cut this, cut this. So after cutting, this is the first piece, this is the second piece, third piece, fourth piece. Okay, I'm saying that if you cut the lens parallel to principal axis, what will happen to the focal length of all these pieces? Guys, see, if you take this piece, sir, if I want to make bigger piece from this one, okay, if I want to make it a whole, so we say focal length in this case will remain the same. Okay, if this width is same, focal length will remain the same. So what I'm trying to say is that if the cutting of lens is done parallel to principal axis, focal length of all these parts remain the same. We say here F remains the same. Directly, whatever is the focal length of the original lens, same will be for all these parts. Now, if you cut the lens along perpendicular to the principal axis, okay, cut perpendicular to principal axis, cut perpendicular to principal axis. Okay, now guys, if you cut this perpendicular to the principal axis, something like this, okay, if I say its focal length was f dash, we say if you cut, it will become 2 times of f dash for this, 2 times of f dash for this. And if you cut it parallel to the principal axis, focal length remains same. Here we say it becomes twice. In this case, it becomes twice. Okay, if you cut, it becomes twice. We say here focal length of individual parts, the focal length of individual parts are doubled. Next we have combination of lens. Like you have this lens, this lens, this lens. If you join 2, 3 lens, this has focal length f1, f2, f3. You make a single lens in this particular case, which is having the focal length f equivalent. It is like, I don't know if you have experienced this. You go to this eyewear clinic, okay, eye doctor, whatever we call it, and that doctor basically, if there is a student or if there is a person who is having the problem in his eyes, okay, in seeing things, so he goes to the doctor, and then the doctor over there asks him to read the letters or the alphabets present on the wall. Then he wears the glasses over there and he starts reading. Then he says, sir, I am not able to read. Then he puts another lens, okay, second lens in front of this previous lens. Then says, read. Sir, I am not able to read. Then put the third lens. So he puts multiple lenses in front of his eyes and then says, yes, now I am able to read, sir. Yes, this is A, this is X, Y, Z, and so on. So that is this one. So he is putting different combination of lenses, and then at last he gives you a single lens, one lens. He gives you one lens. which has the focal length equal to the focal length of all of these, which has the equivalent focal length, so that you are able to see the things clearly. So that's why we do the combination of lens. So you join different lenses, so they have got different focal length, and this will be the equivalent focal length. In this case, we say how to find the focal length of this one length, this equivalent 1 upon f equivalent is equal to 1 by f1 plus 1 by f2 plus 1 by f3. This is how we find the equivalent focal length if the lengths are something like this. And even if you can find, if you want to find the power, in this case, power will be power of this plus power of this plus power of this. So up to n. If there are n lenses, so power will be up to n. Okay. If the two lenses are at the separation d, let's suppose you have got this lens, its focal length is f1. You have got this lens, its focal length is f2. And the separation between the two is d. If you want to find, guys, if you want to find the equivalent focal length in this particular case of both of these, find the net equivalent focal length. 1 by f equivalent is 1 by f1 plus 1 by f2 minus d upon f1, f2. D is the separation between the two. This is how we find the focal length, net focal length, when the separation between the lenses is there. If separation is not there, then the previous case. Then we say coating of lenses. Like you have a lens, you are coloring it over here. You are doing the coating, coloring. This part is also coated. This part is also coated. Okay, this is a lens, this upper part coated. Then this. In this case, we say the image formed will have low intensity. Like the image formed because of this, like if you place an object over here, it will form its image. This image will have low intensity, low brightness. It will not be clear. Image will not be clear. Low visibility, low brightness, low intensity. Don't say no zebra pattern is formed over here. Okay, different patterns are not formed. Image will be formed, but with less intensity, less brightness. Coating of lenses. Now, if a lens has different refractive index and different parts, like a lens is made up of different refract. This lens is made up of different materials. This material has mu1, mu2, mu3, mu4. In this particular case, it is made up of different materials, so it will have 4 different images. It will create 4 different images. This will create the separate image, separate image, separate image, separate image. We don't have to go much depth in these cases, just remember it. Number of images will be equal to the number of refractive indexes. If there are 5 materials present in this, so 5 images will be created. Okay. And images will be made at 4 different locations. Like first image here, second here, third here, fourth here. 4 different locations, images will be made at different locations. Okay. Now guys, you have this question over here. Would you be able to solve this particular question? Tell me. Here we have 2 lenses with the radius of curvature given as 10, 10, 10. Okay. This has 10, this has 10, this has 10. Find the focal length of the system. You have to find the net focal length of the system. First, you need to find the individual focal length, then you can find the net focal length. See guys, how do you solve this? We say break the lens in 2 parts. This one and this one. See. This is the first portion of the lens, biconvex. Okay, this is the biconvex lens. This is the biconvex lens. Biconvex lens. Okay. Now guys, this R1 is 10. R2 in this case is 10. Refractive index is 1.5 over here. This is air, this is air. And guys, we say object will be over here. This will be the direction of incident rays. So this side is positive, this side is negative. Let's find the focal length of this particular lens over here. Let's find the focal length of this. How do we find the focal length of this? 1 by f1 is equal to mu L divided by mu S minus 1. Then we say 1 by R1 minus 1 by R2 in this particular case. Clearly, R2 will be negative, R1 will be positive, because R2, it is radius of curvature is from this side. R2 in this case will be negative, and R1 in this case will be positive. Okay. Okay, now guys, I can say 1 upon f1 will be equals to mu L. Refractive index of this medium is 1.5. 1.5 is 3 by 2. Divided by mu S. Mu S is 1. Mu S is 1. Minus we say 1. 1 by R1. R1 is 10. R2 is minus 10. R2 is minus 10. I told you, radius of curvature of this is minus 10. Minus into minus is plus. Plus 1 by 10. So it will become 2 by 10. Okay. So this focal length f1 will come out to be 10 centimeters. So focal length of this lens is 10 centimeters. Okay, yes. Okay. Then when it comes to the next one is this lens. This lens biconcave. Biconcave. This has got R3 as 10, and this one was which one? This was R1, R2. This is also 10. Now in this particular case, guys, see, this is the positive side, this is the negative side. In this case, R2 will be minus 10, and here R3 will be plus 10, because this is from positive side, this is from negative side. Now use 1 by f2 is equal to mu L by mu S. What is the refractive index of this lens? That is 2. Mu L is 2. So 2 divided by 1. 2 divided by 1 minus 1. Mu L by mu S minus 1. 1 by R1. 1 by, here R1 is this, minus 10, minus 1 by R2 minus 10. Okay. Okay. How much it is coming out to be? Minus 5. Yes. So I can say in this particular case, f2 will come out to be minus 5 centimeters. You got the value of f2, you got the value of f1. Refractive index of this lens, refractive index of this lens. Now these two lenses are placed. How to find equivalent? Now I can write 1 upon f equivalent, 1 by f1 plus 1 by f2. 1 upon f equivalent is equal to 1 by 10 minus 1 by 5, because second one is minus 5. Okay. F equivalent will be equal to how much? Minus 10. So F equivalent in this case will be equal to minus 10 centimeters. Is this clear, guys? Is this clear to each and every single student? Let's talk about the ray diagram. See, guys, a ray diagram. Let's talk about the ray diagram. Guys, the very first thing over here is, if you remember, in case of the mirrors also we discussed the ray diagrams. Let's suppose we have the lens over here. Okay. Yes, this is the lens. And my dear friends, if the light ray is parallel to principal axis, guys, remember this. If the light ray is parallel to principal axis, this yellow one, after refraction, it passes through the focus. If a ray is parallel to principal axis, then it passes through the focus. Direct. Okay. If a light ray is passing through focus, it becomes parallel to principal axis after reflection. If it passes through focus, it becomes parallel to principal axis, or we say optical axis after refraction. Done. Third one. If a light ray is passing through optical center, this is called the optical center. Like in case of the mirrors, we used to call this as pole. Here it is called the optical center. Optical center. If the light ray is passing through the optical center, it will directly pass through the optical center. Three things I told you in case of ray diagram. If the light ray is parallel to principal axis, after reflection, it passes through the focus. If the light ray is passing through focus after refraction, it becomes parallel to principal axis. If the light ray is passing through the optical center, it will move through the optical center directly. Now, convex lens or the converging lens. Okay. Guys, image formation we are talking about. Like over there, I told you. This is the lens, let's suppose. Which one? Convex lens you have. Convex lens. Guys, understand one thing very carefully. If this is a lens, okay, it will have focus from, because it has two surfaces. This surface, it has focus, it has center of curvature. This surface will also have focus, it will have center of curvature 2f from both the sides, Yes. Now guys, in this case, if object is placed beyond 2f, if we place the object beyond 2f, light ray will leave something like this parallel to principal axis. We say it passes through the focus. This is the first focus over here. Another light ray passes through the optical center. We say then they will meet over here. The point where refracted rays meet, this is the incident ray. This is the refracted ray. The point where refracted rays meet, image will be formed. Now, don't you think that in this case, image is formed between f and 2f? Images, if object is beyond 2f, image is formed between f and 2f, Image is real. Guys, these refracted rays are actually meeting, so image is real. Image is inverted, upside down. Image is diminished. Small as compared to the object. Okay. Second one, object is between f and 2f. If you place the object between f and 2f, light ray is parallel to principal axis. After refraction, it passes through the focus. Another light ray passes through the pole. Okay. Passes through the optical center and they meet over here. In this case, image is formed beyond 2f. If object is between f and 2f, image is formed beyond 2f. Image will be real. Real means where refracted rays are actually meeting. Image is real, inverted and magnified. Inverted upside down, magnified will be bigger. It is bigger than the object. Third one. If object is between optical center and pole, we say first light ray will go something like this, it will go. Second light ray will pass through the optical center. And we know this parallel light ray, it passes through the focus over here. Now guys, these two light rays are diverging, they cannot meet from this side. If you extend this, the point where they meet, the point where these refracted rays appear to meet, image will be formed. Now I can clearly say in this particular case, guys, image formed is virtual. Why? Because the refracted rays are not actually meeting, they appear to meet. This is virtual. Image will be erect, it is not upside down. And image is magnified, it is bigger. Image can be formed from focus to infinity anywhere. From focus to infinity, anywhere image can be formed. This is the case 3. Diverging lens. Okay. Concave lens, this one. This lens. Concave lens. Let's suppose this is the concave lens. This is the axis of the concave lens, basically. Like this axis, center axis. Now, object placed close to the lens. Object placed close to the lens. Here we discuss 2 cases. Object placed close to the lens. Okay. Light ray will leave, it will be diverged. Another light ray passes through the optical center, it will pass directly. Now extend this light ray, and this light ray is also, this refracted ray is also extended. The point where these meet, image will be formed. Okay. In this particular case, guys, I would want you guys to understand one thing. Image formed will be virtual. Okay. Image formed will be, because you are extending this, you are extending this. Refracted rays appear to meet over here. Image formed will be virtual. Image will be diminished, smaller than the object. Between optical center and focus. Guys, this is optical center, this is focus. Image will be between these two. Next, object placed at infinity. If you place the object at infinity, my dear friends, okay, if you place the object at infinity, in that case, parallel light rays fall. If the light rays fall something like this, okay, parallel light rays, we say it becomes parallel to principal axis. Like, why, sir? Because this light ray is along the focus. It feels like the light ray is coming from the focus. That's why it is becoming parallel to principal axis. This is through optical center. Okay. Now extend this and extend this refracted ray. The point where they meet, image will be formed. And here, image is virtual, erect. Why virtual? Because light rays appear to meet. Erect, not upside down, diminished. It will be smaller. It will be smaller than the object. It will be smaller than the object. Is this clear? Is this clear? Is this clear, guys? Now we have the final portion of the ray optics, and before that we need to take the break. Break is much needed right now. Break is much needed. Break till 1:25 is already the time. 1:33. Okay. AM. Check. Now guys, let's move on to the microscope. Let's move on to the microscope. See guys, when it comes to the microscope, sir, what is a microscope? Guys, we use microscope in order to see small things large, so that we can see very small things in a magnified view. Okay? So we say the work of a simple microscope is to magnify the things, to make us see very small things large. Okay? Yes. Okay? To make us see small things large. This is the work of the microscope. If we want to see an object with our normal eyes, it should be placed at least 25 centimeters from your eyes. If I say I need to see this object with my normal eyes, so at least it should be placed at 25 centimeters from my eyes. Then I would be able to see it clearly. If you bring it close, it will be difficult for me to see. That's what is mentioned. And this is called, we say, least distance of distinct vision. Least distance of distinct vision means the minimum distance at which we can see an object with our normal eyes. Okay. So right now we are discussing the simple microscope. Guys, what is a simple microscope? Simple microscope is just the lens. Then sir, what is that microscope that we have seen in the schools, okay, which have got the multiple lenses over there? That is called the compound microscope. We'll study that also. But when it comes to the simple microscope, it is just the lens. It is just the lens. Like, have you ever seen, guys, that circular shaped lens, something like this? Have you ever seen that circular shaped lens, something like this? Okay, you want, if something is written on the paper which is very small, then you use this lens so that it magnifies that whatever is mentioned on the paper. Please tell me in the chats. Have you ever seen that? Have you ever experienced that? If there is something which is mentioned on the paper and is very small, you want to read that out, you use that lens, okay, and then that whatever is mentioned over there, it becomes bigger. So that is the simple microscope. That's just the lens, This is the lens, okay. Now guys, if I say you have to see the object in a magnified view, you want to magnify the small object with this simple microscope, what will you do? You will basically place a lens over here, and this is your eye, okay? This is your eye, this is the lens, and this is the object which you want to see, okay? And in this particular case, this is the object. Between the object and the eye, you place the lens. As simple as that. Now, my dear friends, we say this lens will make the image at infinity, means at very large distance. It will make the image at distance d, least distance of distinct vision. First, I'm saying, sir, if I want to see whatever is mentioned over here, if I want to see with the help of this lens, but it should look like it is at very far distance. So that is what we call the image at distance d, image at infinity. So my dear friends, we place the lens in between the object. This is the height of the object, okay, and between the eye. So now guys, this is the lens over here. I would want you to understand. So if you place the object at focus, means you place the object, this paper you placed at that distance so that it becomes, it is present at the focus. Then we say light rays will leave from this object. First light ray is parallel and it passes through something like this, passes through the focus. Okay. And then we say another light ray will go something like this. We say these light rays will meet at infinity. These light rays will meet at infinity. So we say in this particular case, image will be made at infinity. Or simply you say, if you want to magnify the image at distance d with the help of simple microscope, magnification will be this. This is the magnification. So I'll just write over here. This is the magnification at infinity due to a simple microscope. Okay. And magnification is d by f. What is d? D is the least distance of distinct vision and f is the focus. Next, image made by the simple microscope at distance d. Now guys, I would want you to understand. This is the eye. This is the object that you have placed over here. You want to make the image of this object at distance d. See guys, you place the object exactly over here between the optical center and the focus. So this is the lens. This is the object you are placing over here. It should be between the focus of this lens and the optical center. We say light ray will leave something like this. Another light ray goes something like this. Now extend this, extend this. The point where refracted rays appear to meet, that will be the image. That will be the image. And this image is formed at least distance of distinct vision, that is d. Image formed by the simple microscope at d. If you want the image should be made at d, you should place this object between focus and optical center. If you want image should be made at infinity with the help of simple microscope, you should place the object at focus. We say these light rays will become parallel after refraction. They will never meet, they meet at infinity. That's why this image is made at infinity. And here in this case, image is made at distance d. It is a virtual image, but it is made at distance d. And in this case, magnification will be 1 plus d by f. D is this. Here in this case, you see magnification is large as compared to this, because here only it is d by f. Here it is more magnified, 1 plus d by f. So at distance d, magnification is more. Magnification is more. Okay. Next is compound microscope. Sir, compound microscope is that microscope which we see in our schools, which we use in our schools. Okay, that my guy, I want to see this, I want to see that. Yes. Now guys, when it comes to the compound microscope, it is made up of two lenses. This is called objective lens. This lens is called eyepiece lens. When it comes to the compound microscope, we say it is made up of two lenses. First one is objective. Second one is eyepiece. Objective, eyepiece. Objective, eyepiece. Okay. Now guys, this is the object which is placed. This is the object which is placed exactly over here in front of the objective. Because if you want to see something, you have to place it in front of the objective. Okay. Now guys, see. My dear friends, we say incident ray. This is the object placed over here. And this object is placed at UO. This is the position of the object. Okay. Now guys, we say incident ray will leave from the object. another ray will leave. After refraction, we say they will meet exactly at this point. So this H dash is the image due to objective. I would say H dash is the image due to objective lens. H dash is the image due to objective lens. Okay, yes, yes. And this is the image due to objective lens, so this will be the position of the image due to objective lens. Position of the image due to objective lens. Now guys, one thing I just want to tell you over here. This H dash will now behave like the object for eyepiece. No doubt it is the image of this, but it behaves like an object for eyepiece. And H dash behaves like an object for eyepiece. It behaves like an object for eyepiece. Okay. Okay. Yes. Now, guys, what is the work of this? Its work is to magnify the object. It will magnify it. See, this H dash is bigger. Now, this eyepiece, this compound microscope is better than simple microscope. This eyepiece will again magnify it. It will magnify it more. Eyepiece will magnify it more. So this is H dash, this is H. Eyepiece will magnify it more. So we say now light rays will leave from this object. One pass through optical center, another will be something like this. Now these light rays will go parallel. We say if you extend, you're also parallel. So we say image will be made at infinity. So this is that case of microscope, compound microscope, in which image is made at infinity. Like here, in case of simple microscope, image is made at infinity, final image is made at distance d. Here, final image is made at infinity. We say, and final image is made at infinity. Okay. Okay. Yes. Okay. And this FE is the focal length of eyepiece. Now guys, if you ask me, what is the magnification in this case? Sir, compound microscope, here in this case, we say, first this lens will magnify the object, that is, it becomes, it will create the H dash image. Then this will magnify the object. This will magnify it. Two magnifications will take place. If two magnifications take place, can I say total magnification will be magnification due to objective lens multiplied by magnification due to eyepiece. Here we say multiplied by. So magnification of objective, magnification of eyepiece. Guys, see, magnification of objective. Objective is a normal lens. Objective is a simple lens, simple microscope. And what is the we say magnification due to a simple microscope? We have seen previously magnification due to a lens. Magnification due to a lens, it is simply that is V divided by U. This is the formula of magnification. Previously we have discussed due to a lens, magnification is V divided by U. Okay, as simple as that, due to a normal lens. This is the magnification. See, magnification in case of the lens, V divided by U. So this objective is a normal lens used in the compound microscope. So because of this, magnification will be simply what? V divided by U. It will be simply V divided by U. And why is it mentioned over here V naught by U naught? So because this is position of the objective, because this is the magnification of objective. So position of the image due to objective, position of the object from the objective, that's why, multiplied by magnification of eyepiece. And eyepiece is simply d divided by f. Guys, this lens over here, when the image is made at infinity, because of this simple microscope lens, this is d divided by f. Magnification is d divided by f. So you simply say v0 by u0 into d divided by f. This is the magnification when image is at infinity. And one more thing also we discuss over here, that is the tube length, v0 plus fe. What is tube length? Tube length means distance between the objective and eyepiece. Guys, from here to here, this is the position of the image, that is v0. And from here to here, and this image is produced at focal length of eyepiece. So from here to here, this is the focal length of eyepiece. So we say this fe and this v0, we say this will be the tube length. This will be the gap between the two. This will be the gap between the two. Okay, distance between objective and eyepiece. Case 2. Now here also, image is made at final image. If you want the final image to be made at distance d, previous case image was made at infinity. Now guys, see, this is objective, this is eyepiece. You place the object over here, incident ray will leave and it will pass through focus. Another ray will leave, it will pass through optical center, it meets over here. This will be the image form. This is the image formed because of the objective. This is the position of the object. This is the position of the image because of the objective. Okay. Now guys, in the previous case, you take a look over here. Sir, this image was made at focus. If image is made at focus, the light rays will leave from that point which is at focus. The light rays, if the light rays passes through the focus, after refraction, we say they become parallel. After refraction, they become parallel. Okay. So in this particular case, the image here will be this. Okay. In this case, this will be the image. And we say over here, this light ray will go something like this. Another light ray will go something like this. Okay. Another light ray will go something like this. In this particular case, these two, now guys, first this objective will magnify this image. Then this image will behave like an object for this. And light ray will go something like this, light ray goes something like this. Okay, divergent. Now, my dear friends, in this particular case, we say if you extend this, we say these two light rays appear to meet at this point. Now see, this is the magnification of, this is the final image made at distance d. This is the final image made at distance d, least distance of distinct vision. And you can clearly see in this particular case, this H dash is the final image, where H double dash is the final image. H double dash is the final image that we have exactly over here. Okay. H double dash is the final image. And my dear friends, in this particular case, like previously I told you here, image is made at the focus. In this particular case, image is not made at the focal length. This is a bit longer over here. Okay, this is a bit longer over here. This. Okay. So I say that's why after refraction, the light rays are divergent. If it was at focus, then after refraction, it becomes parallel. So if they become divergent, we extend these. So this will be the final image. So final image is made at distance d. And if you check over here, what is the final magnification in this case? So we say total magnification will be magnification due to objective, magnification due to eyepiece. Now guys, magnification is the objective, that's a normal lens, V0 by U0, same. Magnification due to eyepiece. Guys, see, eyepiece is the simple microscope. Eyepiece is the simple microscope. In case of simple microscope, if image is made at D, how much is the magnification? 1 plus D by F. 1 plus D by F. Same over here, I would say, sir, because of eyepiece, it is 1 plus D by F. And you check in this one, If it is made at infinity, then it is D by F. Here, if it is made at distance D, then it is 1 plus D by F. 1 plus D by F. Guys, in this case, only two things you guys are supposed to remember. Only two things. What is that? What is that? In case of compound microscope, this is the object in front of the objective. We say first image will be exactly created at the focus. Then only when the second refraction takes place, light becomes parallel. Rays become parallel. So that's why they will meet at infinity. So we say final image is made at infinity. And magnification in this case will be simply V0 by U0, D by F. D is the least distance of distinct vision. F is the focal length of eyepiece, focal length of eyepiece over here. V0 by U0. V0 is the position of the image from the objective. Mention over here where V0 is position of first image H dash from the objective. Okay, and where U0 is position of the object, simple position of the object, and FE is the focal length of eyepiece. Similarly, in this case, V0 is the position of the object from the objective. U0 is the position of the object. D is the least distance of distinct vision. F is FE. This is the focal length of eyepiece. Okay, because this is the magnification of eyepiece, so this will be the focal length of eyepiece. Okay, cool. Let's suppose you have this question. A compound microscope has an eyepiece of focal length 10 centimeter. So focal length of eyepiece is given as 10 centimeter. And an objective of focal length of objective is 4 centimeter. Calculate the magnification if an object is kept at a distance of 5 centimeter. If an object is kept at a distance of 5 centimeter from the objective, calculate the magnification if an object is kept at a distance of 5 centimeter. So we say U is given as 5 centimeter over here. U is given as 5 centimeter over here from the objective, so that the final image is formed at distance D. Final image at D. Final image at D. Guys, in case of compound microscope, it is saying that final image is formed at D. If final image is formed at D, what is the magnification? If final image is formed at D, net magnification is this. V0 by U0, 1 plus D divided by FE. So we say in that case, magnification will be V0 divided by U0, 1 plus D divided by FE. What is V naught? V naught we have to calculate. That is the position of the first image. U naught is given over here. You have to first find the position of the first image in this particular case. Can you solve this question? Can you solve this question? Guys, in case of the lens, we say as we know. As we know. Let's suppose this is the lens over here. This is the lens over here. Okay? And this is the optical axis. Okay? And this is what? This is objective. This is objective. And guys, if this is the objective, this will be the object placed at U is equal to 5 centimeters. And this is positive side. This will be negative side. Make sure you follow the sign conventions. Okay. I know if this is the object, this is the object. It is at which side? It is at which side? It is at negative side. So we say U is equal to minus 5 centimeter over here. Okay. In this particular case. Okay. U is equal to minus 5 centimeter over here. Now guys, next thing, what I am supposed to do, and focal length of the objective in this particular case, focal length of this lens is given as 4 centimeters. Tell me one thing, what is the formula I am supposed to use? Guys, in case of the lens, from the lens maker's formula, if you remember, what does it say? Where is it? See, what does lens maker's formula say? 1 by V minus 1 by U is equal to 1 by F. Same formula you need to use. Same formula you need to use. That is 1 by V minus 1 by U is equal to 1 by F. Now take it over there. 1 by V is equal to 1 by F plus 1 by U. Now do the cross. So 1 by V will come out to be, so this is U plus F divided by U into F. So V will come, do the reciprocal, U into F upon U plus F. Now V comes out to be U in this particular case, my dear friends. So we say U in this particular case will be minus 5. Okay, this is 4 upon U plus F, that is minus 5 plus 4. Okay, V will come out to be, this is 20 minus 20 divided by minus 4 minus 5, this will be minus 1. This and this cancel, V comes out to be, that is 20. This is actually V naught, position of the object, position of the image due to this objective. Now guys, let's find the magnification. Magnification will be V naught by U naught, that is 20 divided by U naught. In this particular cases we say 5. Okay, 20 by 5. Then I write 1. Don't mention the minus plus over here. Okay, so this is just the magnification. 1 plus, then we say D by least distance of distinct vision is given as 20 divided by FP, focal length of eyepiece is given as 10. Okay, this and this will cancel. 2 plus 1 is 3. So M is equal to 20 into 3 divided by 5. Okay, so this will be 60 by 5. So M comes out to be 12. Magnification came out to be 12. Hope this is clear. Next, this is the question that I'll give you as homework in this case. You will have to do this from your end. Next, we have the telescope. Next, we have the telescope. See, guys, what is this telescope all about? Guys, why do we use the telescope? We say, sir, we use telescope because if there are things which are placed at a very large distance, like we see stars, we see moon, we see planets with the help of the telescopes. If there are things which are placed at a very large distance, if you want to see those things, you use telescope. We say it is used to magnify the objects placed at large distances. It is used to magnify those objects which is placed at very large distances. In telescope, objective lens is large and eyepiece lens is small. In telescope, objective is large, eyepiece is small. Okay? Okay. Like this telescope. Objective is large, eyepiece is small. And the lens facing the object is objective. The lens which faces the object is objective. It has a large aperture and focal length. Next. The outer lens through which the image is observed is eyepiece, and it has a small aperture and focal length. Now, my dear friends, basically, we say behind this object is present. So this catches the rays. And then this is your eye. You are seeing in this eyepiece. Okay, that's what it is saying exactly. Because if you see the telescope, you have to see with your eyes. Okay, that one is the eyepiece, and this first one which catches the light rays is called the objective. That bigger lens in front is the objective. Smaller lens where we see with our eyes is eyepiece. Okay. Now here also, case 1, final image is made at infinity. If you want to make the final image at infinity. Okay. Now guys, first thing over here is rays are coming from infinity, so they move into the objective and will capture the more rays. Guys, what I'm trying to say is that why this objective lens is bigger as compared to the eyepiece. The reason is the light rays are coming from infinity. If you keep this objective bigger, we say it will capture more light rays. And if it captures more light rays which are coming from infinity, if it captures more light rays which are coming from infinity, we say image will be clear. The image formed will be clear. It will have a good intensity. Why? Because light rays coming are large. Okay. Okay. Yes. Now guys, see. We say first in this particular case is image is made at infinity. These are the light rays which are coming, and this objective lens will converge all of these light rays exactly at the focus of the eyepiece. So this is basically the first image created because of the objective. Then these light rays, if this is at the objective, after refraction, we say, then now this H dash, I'll just mention over here. H dash is the image due to objective. Okay. And my dear friends, in this particular case, and final image is made at infinity. Now in this particular case, guys, we say if this is the image created because of the objective, now this image will behave like an object for the eyepiece. Now light rays will move something like this. These light rays become parallel. If you extend these, image will be made at infinity. So image will be made at infinity. Why? Because first image is made at focus. That's why second image will be made at infinity. And guys, this is the focal length of objective. Okay, this is the focal length of objective. And this is the focal length of eyepiece. Don't you think that in this case, tube length or distance between objective and eyepiece will be FE plus FO? FE plus FO. Yes. Next. Tube length is FE plus FO. Okay. Now let's talk about the magnification. Guys, magnification of the image done at infinity. If the image is made at infinity, magnification directly, remember you guys, that is minus FO divided by FE. Minus FO by FE. Focal length of objective, focal length of eyepiece. As simple as that. As simple as that. This is the magnification due to the telescope when image is made at infinity. Okay. Okay. Where FO is the focal length of the objective, FE is the focal length of the eyepiece. Just I have told you this. Case 2. If the image is made at distance D. Now guys, see the diagram. These are the light rays falling on the objective. They will converge exactly over here. They will converge exactly over here. Right now, this first image is not formed at the focus. It is not formed at the focus. If it forms at the focus, then after refraction, it becomes parallel. So it is not formed at the focus. Focus is still over here, FE. This is the focal length of eyepiece. Now guys, we say in this particular case, this is somewhere around over here. We say light ray will leave something like this. Another light ray will leave. These will diverge. Now, if you extend these refracted rays, they meet at this point. This is the final image. This is the final image. Final image. And this final image is made at distance D. This final image is made at distance D. Okay. This final image is made at distance D because of the telescope. Okay. And in this particular case, my dear friends, see, when it comes to the tube length, don't say tube length is FE plus FO. No. FO is still over here. That is FO plus from here to here. This is the position of the object. Guys, this is actually the position of the image, but for this is the object. Position of the object of eyepiece. Position of the object of eyepiece. That is FO plus UE. Position of the object of the eyepiece. And what is this? What is this? This is the position of the image of the eyepiece. This is the position of the final image of the eyepiece, because this is the final image. In this case, so tube length I have told you FO plus UE, where UE is the distance of the object from eyepiece. Sir, is this object or image? This is image for this, object for this. Okay. Now, when it comes to the magnification in this particular case, okay, first write the tube length. Guys, this is FO plus. How can you write this UE? That is the position of the image. Don't you think that you can find it with this formula? See, guys. You can say 1 by V minus 1 by U is equal to 1 by F. This is E. If we are talking about the eyepiece. Now, you can find this UE from this one. Here. VE into FE, VE plus FE. Directly put instead of this will be the tube length. This will be the tube length. Okay. And my dear friends, you can clearly see this final image is made at distance D, least distance of distinct vision. So VE, position of the final image, is equal to D. So we say here VE is equal to D because final image is made at D. So instead of VE, you can write D. So you can write D into FE upon D plus FE. D into FE upon D plus FE. This can be the tube length in this case. This will be the tube length in this case. Okay. Next. Sir, what is the final magnification? Here magnification is, guys, minus FO by FE. Okay. Minus FO by FE. Then 1 plus FE divided by D. This is the final magnification because of the telescope done at distance D. Done at distance. You have to remember this directly. What is FO? FO is the focal length of objective. What is FE? Focal length of eyepiece. 1 plus FE, focal length of eyepiece divided by least distance of distinct vision. I hope this is crystalline clear, and this is the maximum detail about this one. You don't have to go in the derivation part. Whatever the things I told you, that is more than sufficient. That is more than sufficient. Now, let's solve this particular problem that we have over here. Okay, see, guys, give me the signal in the chats. Is this clear till over here? Come on, tell me. Is this clear till over here? Please, please, please tell me, everyone. If you are confused at any point, I would request you to watch it tomorrow, this last portion. It will be clear. The magnifying power of a telescope is 9. Value of M is given as 9. When it is adjusted for parallel rays, the distance between the objective and the eyepiece is found out to be 20 centimeters. Okay, the distance between the objective and eyepiece. So tube length is given as 20 centimeters. Okay, magnification is this one, tube length. The focal lengths are, you guys are supposed to tell me the focal lengths. Okay. Magnifying power of a telescope is 9. Okay, guys, tell me. Can I say in this particular case, we say as magnification is FO divided by FE. This is given as 9 is equal to FO divided by FE. Take it over there. FO will be equal to 9 times of FE. Now, when it comes to the tube length, as we say tube length L is equal to FO plus FE. Tube length, we write it something like this also. This L is given as 20. FO is 9 times of FE plus we say, sir, FE. So 20 is equal to 10 FE. 10 ones are, 10 twos are. FE will come out to be 2 centimeter. Guys, if FE is 2, L is 20, FO will be how much? 20 minus 2, that is 18. FO is 18. Simple question, 18 centimeter. Okay. Next, the focal lengths of objective and eye lens, the focal lengths or objective and eye lens are the focal lengths of objective and eye lens of an astronomical telescope are 2 meter and 5 meter respectively. Okay. FO is given as focal length of objective and eye lens of an astronomical 2 meters. 2 meter will be 200 centimeter. And FO is 2 centimeter. FE is 2 centimeter. 5 centimeter. 5 centimeter. Final image is formed at least distance of distinct vision. Second is infinity. Magnifying power in these two cases. Guys, if the final image is made at infinity, in case of a telescope, if final image is made at infinity in case of a telescope, How to find the magnifying power? Minus FO by FE. Minus FO by FE. Okay. So we say here magnifying power is minus FO divided by FE. Sir, why didn't you take minus over here? Guys, because from there itself they are saying magnifying power is 9. So I took the magnitude of that. That's why. They are not asking us to find the magnifying power. They are giving from their side only, it is 9. So that's why I took magnitude only. Okay. And in this case, I am taking it along with the sign. Along with the sign. Okay. So now how much is the magnifying? And this is the first case. This is the second case when image is at, when image at infinity. So m will be minus 200 divided by 5. Okay. That will be minus 40. Minus 40. This will be the magnification in this particular case. Okay. Now guys, this is the magnification. And when, second one is when image at distance D, least distance of distinct vision, that is 25 centimeter. In that case, what is the magnification? Guys, see, minus FO by FE, 1 plus FE by D. We say minus FO by FE, 1 plus FE divided by D. M is equal to minus FO, that is minus 200 divided by 5, 1 plus 200 FE, 1 plus 5 divided by 25. Because FE is 5 and least distance of distinct vision is 25. Guys, is this crystalline clear? Okay. How much? Minus 48? Yes. So it will be minus 48. This is minus 48 in this case. Now guys, this is your homework. This question is also your homework. With this, we are done and dusted with the ray optics. Okay guys, that's all for today. Thank you so much. Make sure you, once I end the live stream afterwards, do comment down below. Okay. So take care and bye-bye. Thank you so much. Hello guys. I gotta go.